Welcome to this video on data structures by Intellipaat. No matter what company you want to get a job at, as an engineer, you need one skill to crack the interview. That is data structures. From Google to Intuit to Twitter and even startups, one thing that will increase your chances of cracking your interview and give you an edge over other candidates is data structures. Based on over 2000 profiles, employees with knowledge in data structures make an average salary of 20 lakhs per annum, with most earning between 16 LPA to 15 LPA, and 10% of workers in the top bracket make more than 29 lakhs annually. So whether you are a beginner or someone who wants to brush up their skills, this video is perfect for you. Make sure to answer all the quiz questions in the comment section below and add on to the topics you want to learn from us. But before that, if you find this video helpful, please like, comment and subscribe to our channel for more exciting content. So we are going to start with the introduction to data structure, what is coding, and after that we'll have an introduction to programming languages, overview of Java programming language, and moving further we'll have a Java hands-on, introduction to arrays in Java and various types of arrays in Java as well. After that we'll have an array hands-on in Java, and to top it with data structure quiz questions and interview question and answers.
So the very first thing that we are going to discuss about is what exactly is coding, what exactly is programming. Now, coding has multiple synonyms. Some people call it coding, some people call it programming, some people call it scripting. Okay, but anything that you write on a computer and make it do stuff, that is coding, scripting, programming, right? So these all are synonyms. So very first thing in a very basic, that's the base of everything. Whatever you'll be doing for the next course, it will be coding itself, right? So what exactly is coding? Now, in a very simple term and in a very simple explanation, if I can talk about what is exactly coding, is just writing instructions, right? Codes or code are instructions. For example, you have a chef, right? Or let's for example, you are a chef and you have an assistant and you want your assistant to prepare a dish, and you give your assistant a set of recipes, right? Recipe is a list of instruction following which your assistant can prepare that particular dish, correct? That's exactly our code. While when you code, you become chef, the computer become your assistant. You give instructions to computer around what are the steps or what are the instructions the computer needs to follow. Now, goal could be anything. Goal, if we are not bothered here about the goal of the code when we talk about what is coding. Irrespective of the goal, right? Whatever goal could be, you make the computer to achieve that goal with the help of instructions. And you put the instructions, and when you write it, that's exactly is what coding is. So in simpler terms, code or coding is instructions. Code are instructions. Coding is the process of putting instructions into the computer. All right, that's exactly it is. Now, why it is required? Okay, why do we need to give instructions in a form which is way different than we talk, right? I mean, if you have a human assistant, will you give him the instructions in terms of writing something which is way different, right? Writing something like codes and all that? No, I can just tell him if I'm giving someone a recipe of, let's say, making a tea, right? I would not type on a computer in a gibberish manner and give him that, right? I could just tell him, get milk, get tea leaves, boil the milk, put tea leaves, and all that stuff, right? That's the native language. It's a simple language. I can do that. Why can't we do that with the computers? Now, the reason is computer does not understand our language. It's not meant to be. The way computer has been made, they are not meant to understand the language we speak, right? They understand only one language. What's that language? It's the binary language, okay? The binary code, only zeros and ones. They understand, they function, they think, or they execute only in binary, 0 and 1s, right? Computer can understand only the instructions in binary code. So we need to have a middle ground. We, as in the humans and the computers, need to have a middle ground where we both can understand it can act as an interface where we both can communicate. And that's where coding does. You write code that gets executed in the computer, and the computer understands by converting your code into a binary code. How that conversion happens, we'll come to that later. But coding is basically you write code by learning how to code, and then it makes easy for computer to execute that code and convert that particular code into a binary language. And hence computer is able to understand your language, and we are able to, let and make computer do things that we want them to. Okay, that's it. That's about it. Now, here comes what is programming languages then. Now, we talked about that what is coding, right? That is simple, that it's a way to communicate with computers. Okay, coding is required because computers can't understand our language. They need to have certain aspect of, the middle ground where they can understand a language that is binary. We understand that. But again, why there are multiple programming languages then? Why can't we stick to one language? Because all the language in the end converts their code and gets executed in a binary language which computer can understand. For example, Python. Python does the same thing. You write something in Python, you execute the Python code, computer understands it by converting it into a binary language, right? When this is already happening and computer is able to understand, why do we need multiple programming languages? Why do we need Java? Why do we need C++? Why do we need Pascal? Right? It's all are doing the same thing, right? All are making it to change into a binary language.
Let's have a quick quiz question, guys. And the question is, which of the following is a linear data structure? And your options are array, AVL trees, binary trees, or graphs. Please mention your answers in the comment box.
Even though one programming language is enough to convert our native language into binary language. Maybe different system use build up with specific language. Maybe different system use build up with specific language. Okay. I did not clearly understand, but I got the gist of it. What you're saying is maybe different system are built up to understand a specific language. Okay. Different ways of viewing problem solving, different perspective. We have multiple programming languages. The only reason of having multiple programming languages is we have different use cases. Now, what do I mean by use case? Use case, you can relate it with goals. Okay. For example, you want to build a mobile application, or let's say, what's the most complex mobile application we have nowadays? Instagram we have, right? Everything is coming on Instagram. We have reels, we have stories, we have posts. You can put n number of things. You can, there is a video call feature as well, chat feature as well. So it's a heavy app. You have a lot of things in that, right? That's one thing, right? Other thing that you can think of is a calculator, a physical calculator, not the phone calculator. Imagine a physical calculator. Okay. Both have been built by code, right? But compare the complexity of these two. Instagram app has n number of features, has millions of users at the same time interacting with each other, right? On the other hand, there's a physical calculator which works on a battery, which has just small rectangular screen, which is black and white. I mean, it's not even white, it's just black or no black, right? And you can just see numbers, you can just calculate. There is only arithmetic operations possible. That's it. There's a drastic difference between the two. Now, do you think the same programming language can do the same way? I mean, just by sticking to one programming language, you can achieve both the aspect? Maybe true, but one programming language, relying on one programming language can create a lot more complexity to achieve someone which is way complex than a calculator. Hence, we have multiple programming languages which are meant for different aspects. For example, HTML, CSS. I mean, I'm just throwing out language names. Okay, if that goes beyond your head, don't worry. These are not very much necessary to remember. I'm just giving you the examples. HTML, CSS, JavaScript. These are the languages meant for website development. You develop website something. React Native, it's very popular nowadays, is meant for creating complex app, which uses state management, where you can see like Instagram, complex apps, right? Java or C++ are meant for computer applications that works in the backend servers, right? So probably in that physical calculator, C might have been used, or C++ might have been used, because they are very basic. On the other hand, if you want to do data analysis or machine learning, artificial intelligence, like Tesla has been built with artificial intelligence, the self-driving car, okay? Or we all have a phone that can tell you if it is gonna rain tomorrow or not, what is going to be the weather tomorrow, right? It's prediction. For such type of activities, Python are suitable, because it has such libraries and it has the tools that can suffice that need, right? So over the time, the languages has grown in their own way, and they all have a niche of use cases. And according to that use case, we generally pick the language, and hence there are multiple programming languages. Okay, so I hope that is clear. And whatever I told, it's exactly written over here. So we have multiple programming languages, and the most popular ones are JavaScript, which is meant for website development. Whatever interactions that you see, animations that you see on websites, it's JavaScript. Python, I mentioned, data analysis, machine learning, artificial intelligence. Java is more on the web applications, Windows applications. The native core exe files are mostly on Java. Ruby, PHP are obsolete now, so don't worry about that. They are gone. Okay, so these were the aspects, and different languages can be used for web development. As I mentioned, JavaScript is meant for such tasks. Software and apps, you have a number of use cases over there, and different languages are used for that. Okay, so this was mostly about, three things we covered, three major things. What exactly is code? What is coding, right? That's the first thing that you should be knowing about, right? Second thing that we covered is, why do we need coding? Because computers can't understand our language, and hence. And then we covered, why do we need multiple programming languages? Okay, now I would just give you a gist of certain terminologies. Okay, certain terminologies that are essential and you need to know them. Okay, this is something I have just written it by myself just before the class, because I don't want you to miss these 5 terminologies and get confused later on. Okay, so just have these in your mind. Okay, cool. So the very first thing is computer program. What is, I mean, you would see very often in your assignments, in your questions, that write a computer program to do XYZ, write a computer program to do set of this, right? Anything. So you should know what exactly is computer program. Computer program is nothing, again, it's basically saying you to write code. It's basically saying you to write the instructions step by step, right? That's exactly is computer program. Okay, so basically a computer program is a group of instructions given to a computer to be processed. The instructions are typically used to solve a problem or make long problems for humans shorter and easier. Okay, so computer program is just a piece of code that you put to the computer, and the computer processes it and gives the output according to what you have written. That's computer program. What is an algorithm? This is another term that you'll hear very often, an algorithm. Now, an algorithm is a procedure. Now, let me just give you a real world example of an algorithm. Okay, there could be, since we took a recipe, chef and recipe example, I'll again use the same example. There could be more than one way to prepare a same dish. Okay, both the dish might be called same, but there might be certain differences in the two dishes, because the way they were prepared were different. For example, I mean, I'm just taking random examples. I'm filing it over here, right? For example, you have been asked to prepare chicken chili, right? I mean, you can take any XYZ example, okay? Or maybe banana pancake, right? Anything, right? One chef followed the way of, if I take the example of banana pancake, he followed the way of first creating the batter by himself.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ENICT IIT Guwahati. The course link of which is given in the description below. Now, let's continue with the session.
Right? Putting bananas and then putting the oats, putting some milk and then grinding it and then baking it and all that stuff. Another chef used an approach of getting it from the supermarket. You get the pre-processed dough, right? And then you just need to use it and bake it, right? They both used these two different ways, but what would be the end product called? Both will be banana pancakes, right? There is no difference. I mean, if I give it to someone, you won't be much worried about how it was prepared. You might be worried about how it tastes and how it looks like, but you would not be worried about how it was prepared, right? But both are banana pancakes, right? The procedure was different. The output is same. Okay. In computer world, in programming world, that procedure is called an algorithm. That's the simplest definition I just created over a call. This example just came in my mind itself. So that's the algorithm, the set of instructions done to solve a problem. Okay, that's the algorithm. So basically, one problem or one goal can have multiple algorithms. Just like one dish can have multiple procedures, one problem statement, one goal, if you want to achieve, can have multiple algorithms. Now, remember, I mentioned that you will worry about how it tastes, right? You might not be worried about how it was prepared and stuff, but how it tastes and how it looks, because presentation matters, right? You might be worried about that. In the same way, there are key factors in algorithm that at times you need to consider, right? It's slightly higher topic, but I'm still touching upon that because we have created a good example for you to understand, right? In algorithm, you care about how much time it took to solve that problem and how much space it occupied, right? Again, relating it with the chef example, right? Suppose chef one used, the whole kitchen to prepare that particular dish, and the whole kitchen got haywire. I mean, it's dirt everywhere. The utensils are unclean, right? Used to prepare that banana pancake, right? And the chef one also took more time to prepare the same. On the other hand, the chef two took less time, okay, and also did not, created a mess in the kitchen, but the end product is same. End product is same. Both taste equally good. Both is presentable. Which chef will you hire? Which chef will you hire? One or two? One took a lot of time, created a mess in the kitchen. Obviously two, right? Because he took less time. He did not, created a mess in the kitchen. In the same way, in algorithm, we consider two aspects. Any kind of procedure is if two developers or two programmers have written two procedures to solve a problem, two programmers have written to solve a problem, the problem that takes less time to compile and execute, that is one. And second, it takes less space, is considered to be a better problem. And here we touched upon two important elements of algorithm. One is time complexity and other one is space complexity. What is time complexity? What is space complexity? In the bare understandable words, you can understand time complexity is basically a representation of how much time an algorithm took to solve a particular problem. That's all time complexity is. Space complexity is basically how much space an algorithm took to solve a particular problem. Time is pretty clear, that more time, less time. But what is space? Space is the memory, the RAM of the computer and all that stuff, which is something we'll touch upon later. But for now, you can just understand in this way. All right. Third thing that I wanted to discuss with you is compiler. What is compiler? Remember, I told you that we have a middle ground, me and a computer. The humans and the computer have a middle ground, which is a code, which is the programming language. I wrote something in the programming language, and computer converted that programming language into a binary language which it can understand. Now, how it was able to convert from that code to a binary language? Okay, that is something is compiler used for. Okay, so compiler is basically a program that takes the code that you have written and translates into a binary ones and zeros of actual machine code. So that's a compiler. You don't have to worry about how compiler is built, how we can make a compiler, nothing of that sort. Compiler is something it's already there attached with programming language. You don't have to, you just have to know the term. That's it. This slide is just for you to understand the terms. That's it. Okay, so that's compiler. What is execution? Okay, execution is something once you are done writing a program, you execute it. Okay, execution is basically means submitting it. You can just understand again the chef example. Once you're done preparing your dish, you serve it on the table. In the same way, once a programmer is done writing the code, he or she executes it. That's it. No need to go via all these ones. I mean, the example is enough to understand. The last one is important, syntax. Now, relate syntax with the grammar in English language, right? Now, suppose I am saying something right now in English and I start using incorrect grammar, right? I start using incorrect grammar till the extent that you're not able to understand what I'm saying, right? So hence I need to use proper grammar for you to understand and you to comprehend my words. In the same way, computer, when you're writing code, you need to stick to the grammar as accurate as possible. I mean, there is no, even if I do some grammatical mistakes, you'll be able to understand because you are a human, right? But that's not the case when you write code, because in that case, you're talking to a computer. Computer does not takes error for granted. I mean, if you have made an error, it will throw the error. That is something I do not understand. It can't just assume itself that this might be true or this could have been what the human was saying, right? So it's very specific on exactly what grammar you are writing on the code. So when I say grammar is between human and human interaction, same way syntax is something when you are interacting with the computer, right? So grammar is for English, syntax is for Java, or syntax is for Python. Syntax is for programming languages. Grammar is for human languages. Syntax is for programming languages, right? I hope these 5 terminologies are clear to everyone. All right, so we'll move on to the next segment now, which is again slightly around programming, and hold on for a while. This is light of the theoretical topic, but we'll get to the good part pretty soon. Okay, but just have the base strong so that you don't have to worry much on the later part. Okay. Okay, so this is the line I found very much very apt. If I talk in terms of Gen Z language, this 5 lines was very apt there for a programming language. Hence, I dropped it in the first slide of this particular PPT. So computer programming has a reputation of being cryptic and too complex for an average person. Okay, and that is something you all will feel if you are jumping into programming for the first time. Okay, that it's cryptic. What is cryptic? Cryptic is something which you don't understand, which is something that looks like encrypted, right? So it has a reputation of being cryptic and too complex for an average person to understand. However, once you get familiar with the basics programming logic, right? When you are familiar with the elements of programming, when you're familiar with the different verticals of programming, you will see pattern everywhere. Okay, that cryptic piece of code that you might feel right now, once you are done with the basics part, once couple of weeks after, you'll see patterns everywhere. You'll start understanding, okay, this part I don't need to understand the whole part. It's just like this part is doing this and this part is doing this, and then I'm able to get an understanding of what whole code is doing. So it becomes so habituated, and you become so expertise in that you start seeing patterns everywhere. Why learn to code? I think I don't need to cover this slide, because since you guys have enrolled to the course, I think you might have seen some amazing things code can do. So that's the reason you are here. So I'll skip this slide. And what is computer programming? I think we covered that part. It's more like a recipe for a computer to understand. Computer programs can help cure diseases, drive cars, create video games, make animated video graphics, you name it. Now, especially after coming, the chat GPT is out, you can pretty much do everything out of it. I mean, there is no limit of you doing wonders with computer programming. Okay. One activity I want to do with you all. Okay. And it's going to be an interesting activity, and we'll touch upon a very essential part of programming. Okay. I want you to describe in natural language how to make a peanut butter jelly sandwich in natural language. Okay. Or let's say this example was from Harvard. Okay. So I copied it, and it's a Western dish, right? Peanut butter jelly sandwich. It's a Western dish. We Indians, I have not eaten this peanut butter jelly sandwich. Okay. So I think as an Indian, we can stick to tea. Okay. Let's change. Describe in natural language how to make tea. Okay. Step one. That's the step one, boil water. Okay. So step two has been, which is put tea leaves into it. What would be step three? Add milk and sugar. Okay. Fourth step. Pour. Okay. Chalo. Let's keep pour. I mean serve, right? So pour. Okay. Now let me just copy and do things which you guys have written. So first was boil water, which was given by Mursidil, and second was, I think, put tea leaves into it. Put tea leaves. I'm just putting it in the order so that you can understand. Put tea leaves into it. And third was, I think, add milk and sugar. And fourth one was pour. Now, if you give this to a person, to a human, you might end up having tea. You might see that person has prepared tea successfully. Okay. But if you give this instruction to a computer, okay, I mean, just hypothetically, I'm saying, I'm not just asking you to code how to boil water or something, not like that. Hypothetically, I'm just trying to relate what is the difference that you can sense when you give instructions to a human, and what is the difference when you give instructions to a computer. Okay. When you will give the step number one instruction of boiling water to a computer, first of all, the computer will ask, boil water where, right? How? And how can I boil water directly? I mean, computer would expect you to write things like, get a utensil, put water into that utensil, put that utensil on a stove, light up that stove, let that stove run for 5 minutes, 10 minutes, till the time the water is boiled. Just for step one, boil water, it might be very easy to understand. A human can understand that, okay, boil water, obviously, I'll use a utensil to put water and then put it on the stove. How else can I do it, right? That's human. But as a computer, if you are trying to give the same kind of instruction, you'll have to give instruction where there is no sense of ambiguity, when it is absolutely clear that there is no factor of getting distracted or redirected. Get a utensil, put some water into it, put it into the stove. I mean, that should be the steps if you're putting it to a computer, because computers cannot interpret your 2 words of boiling water. Similarly, put tea leaves into it. How many tea leaves, right? That's the question that you would have to put when you are putting it to a computer, right? Humans can understand that obviously tea should not, I should not put the whole bunch of tea leaves, right? But computer can't sense that. Add milk and sugar where, right? Add milk, sugar into it, into the boiling water where you have put the tea leaves. How much? That's also you should be adding. 4, pour. Now human can understand that the tea has to be poured in a cup, right? Computers cannot. You have to exactly write, pour the boiled tea into the cup, right? And especially use that, what do you call that in English? I say it channi. I don't know what do we call it in English. So you use that particular thing while you are pouring, else you'll use the tea leaves into the cup. right? So these are the instructions you'll have to give it to the computer step by step in much detail as possible, which is way different than we give to humans, right? So did you get a sense of the exercise? I mean, what my intent was saying is, when you write program, there shouldn't be any sense of ambiguity anywhere. Okay, this was also the first class in the Harvard, and that's where I got this idea to have this exercise, and hence I shared with you all. Okay, did it make sense, guys? Did this exercise made sense to you? What exactly was I was trying to convey? 4 verticals that basically builds the basics of programming, irrespective of any programming language. Okay, once you have an expertise on these 4 verticals, you can be a good programmer. Also, you can excel when it comes to data structures and algorithms, right? So these are the 4 areas that we'll touch upon right now. Okay, so lesson 1 is about sequencing, and everything that we'll be talking about right now is with respect to computer programs, computer language, and the coding part. Okay, so sequencing. So this is basically, computer is designed to follow a set of instructions, right? And that's what we have been looking in the past couple of, like, past 1 hour. We understood that computers are very much aware and very much, efficient in terms of following the instructions, right? So if you give a bunch of instruction, if you give a bunch of, the notes to follow and the notes to play to the computer, it might be able to play that. But if you expect computer to do job of a musician, and when I say job of a musician, I meant being creative, being able to do things on stage, trying out stuff, and then just like DJs do, right? According to the crowd, make changes to the music and all that stuff. That is something computers cannot do, because they are not meant for that. They are just meant for following the instructions. Now, this is a very, very funny meme that if you told a computer to jump off a cliff, it would, because they are meant to execute commands. That's what it is, right? So they all they can do is just execute commands. Okay, so the 3 concepts that comes under sequence is, the one is sequence, second is selection, and third is iteration. Okay. Now, sequence is the most basic one. Now, when I say sequence, computer follows the sequence according to how it has been given. Okay, so when you write a code, it always executes the code from line 1 to line n, right? It cannot just randomly pick a line and execute. Computers are meant to execute your code in a sequence of order from line number 1 to the line number end. Okay, that's one, that's sequence. Okay, selection is something, making choices. Now, you can design the program in terms of having selection criteria as well, and computers are efficient in getting the selection criteria executed as well. For example, you have a set of instructions, and since we took an example of tea light, preparing tea, correct? So in that, if I compare that particular example with these 3 concepts, sequence is something you guys gave me, right? Whatever you said, step 1, step 2, step 3, that were sequence, right? But remember, you mentioned the step 2 was, once the water is boiling, you need to put tea leaves into it, right? That's selection, right? You basically made a selection over on the code itself, where you put a condition where if the water is boiling, then execute this particular command. So whenever there is a branching, right? Or for example, another example could be, you boil the water and then you ask the guest, or you ask the user, you want tea or coffee. If the user says tea, you put tea leaves into it. If the user says coffee, you put coffee powder into it, right? So the branching is something that is also possible when you write code, right? So one is sequence. It's all, this computer always follows a right sequence from 1, 2, 3 till n. And second, it's very efficient in taking selection and picking up the selection according to the criteria, right? That is selection, where there is a branching. Okay. Third important aspect over here is iteration. Now, what is iteration? Iteration is something where you want the computer to do things more than once till a certain time or till certain goal is achieved. Okay, and over here the example of boiling water would come. Okay, keep the stove on, keep the utensil with water on the stove till the time it boils. Okay, so that piece of instruction is an iteration. Computer will constantly keep a lookout of a condition being satisfied. Okay, computer will keep checking that particular condition, and once it gets satisfied, only then it will execute the next. If that has not been satisfied, it will stay on that particular instruction only. Okay, that is iteration. Iteration is basically executing the same command more than once. It could be n number of times, it could be three times, it could be 2 times, n number of times. Okay, depending upon a condition. So these are three major concepts: sequencing, selection, iteration. Okay, sequencing, which I mentioned, instructions performed in order with each executed in turn, right? And that sequence is always from top to bottom. Okay, an example of that is a music sequence, which we mentioned. Okay, now this is although all the examples we have used are from the real examples, right? Like we used the example of preparing tea on that stuff, which is not possible on a computer. Okay, the reason of using this real world example is because we have folks who are not well versed with exact syntaxes of programming, right? So over here you might not see the syntaxes, but in the subsequent lessons we'll have syntactical representation of each of them, that what exactly is selection, right? But for the people who are slightly aware, I will just give you a slightly high level example of all these three concepts, so that you are aware about, you know, how exactly it looks like in the computer. Okay, first example, when I say sequence, you can take an example of adding two numbers. Okay, the code, the line number 1 will be accept input from a user for number 1. I mean, ask what should be the number 1, the first number from the user. That could be step 1. Step 2 should be second number. Step 3 could be arithmetic operation between number 1 and number 2. And step 4 could be printing the output, right? That's the sequence order. And computer has executed that in the sequence because it needs the first number, second number, and then put the arithmetic operation and then print the output. That's an example of sequence. Selection, making choices. You need to return whether a number is true or whether a number is odd or even. That's the example, a programming example, not a real world example. How will you do that? Step 1, ask a number from the user. Okay, so you have the first number as in the only number that you want to return as odd or even. Okay, second step, you divide it by 2. Okay, that's a second step, and you store the remainder. Step 2, how will you do it? We'll come to the syntactical part later, but it's just the step so that you are aware about how these concept looks like in the programming world, right? Step 2 is divide the number by 2 and store the remainder. Step 3 is check if the remainder is 0 or 1. If it is 0, return even. If it is 1, return odd. Right? So last step, what did we do? We created a branching. We created a selection criteria, where computer had to select that whether it has to return even or it has to return false, depending upon the condition. What was that condition? The remainder condition. That is the remainder 1 or is the remainder 0. So that's the example of selection. So yeah, example of iteration, count till 10 or maybe print from 1 to 10. Over there, what would you do? First, you would take an input that from the user, that till what number you want to print. Okay, let's say the user provided 10, and then you will have a loop till the time I have not printed till 10, keep printing from 1, something of that sort. Syntactically, we will find how it is done, but that's going to be the case. Once 10 is printed, that loop will break. that loop will basically exit, right? So that's the iteration. So this three concepts we studied in this particular lecture, which is sequence, selection, and iteration. Coming to second thing, which is variables. Now imagine that you have, there's a story that has to be written. Okay, imagine as a story writer, as an author, you have to write a story. Okay, and it's a big story. Okay, and in that story you have 5 major elements that you can call it as. Okay, you have a country name, you have a town name, you have a hero, you have a villain. Let's put it as ABC, anything. I mean just for an example. Okay, anything. Okay, let's put anything only. Okay, so these are the 5 elements that are present in that story, for example, and then you begin with the story. Okay, you have a part 1 where it's a proper written story that in a faraway land called the country, there was a magical and mysterious castle in the town. It was said that behind the castle wall there was a magical princess called Hero, and then basically these are the variable names. Whatever we define over here should get stored over here. Okay, and there are multiple parts to that story, right? There is an interlude. I'm not exactly sure what that is, but there's an interlude, and there's a part 3, and there's again an interlude, part 4, and then there's a conclusion, right? Somewhere with a happy ending or stuff, right? You have a big story with 5 elements. Okay, now what you need to do, you need to rewrite this story, exactly same story, with different city name, country name, or maybe different name of the hero, different name of the villain, right? This, you see it as just a 5-part story. I mean, it got covered in just 5 slides. But imagine you have written a book with these 5 elements. I mean, hypothetically, these 5 elements are only there in this book, and it's a story around these 5 elements only. Okay, and you have written a book, but then you, for XYZ reason, you need to change the country name, the town name, the villain name, the hero name, the sister name, and all that stuff. Okay, how will you do that? You are going to basically edit all your slides with the changed name, right? That's going to be your approach. But in computer programming, we don't follow that approach. We follow an approach of something called variables. Okay, what is variable in an English language, or what is variable literal meaning? Variable's literal meaning is something that keeps on changing, something that varies. That's why it's variable, right? So in computer programming, what we do, and if this writing story would have been a computer program, we would have followed an approach of variables where we would have defined these 5 variables at one place and used the variable names, not the actual names. We would have used the country keyword, not the actual country name in all these stories. That would have been the approach from the programming perspective. Okay, and once you do that, your story might look like this. In a fairway called country, there was a magical and mysterious castle in the town, right? But when you execute it, these keywords will be filled by the actual names present in this particular variable. So over here, country, town, hero, villain are the variable names, right? Which we can vary, which we have a control on, right? By changing at one place and executing the program, we can actually change the whole story with the help of our actual names. So that's the core responsibility of a variable. Core responsibility of variable is to give the access to the programmer, to the coder, and access to all the places where that variable has been used. So by changing at one place, we should be able to change the variable at a number of places wherever it has been used, right? So this is the real world. This is the closest real world example I could have thought of, right? And this is the case. Okay, So in this lesson, we are going to define what a variable is. Okay. We are going to recognize that computers follow a control flow of input, process, and output. Yeah, using variable, we'll define the sequence again and how to include a variable in the sequence. Okay. Now, this is something we all are aware of. Input, process, output. That's what computer do. So in programming, how I relate this with programming, input is something user is giving. For example, in the previous sequence example, we talked about adding two numbers, right? Accepting input from the user, two inputs, number one and number two, and adding it. So input was number one and number two. Processing was the arithmetic operation of number one plus number two. And then output was printing of the sum of two numbers, right? So this is the usual process of any kind of activity which is there. Now let me showcase you this particular example. I just wanted to bring that before going to this. Okay, just give me a second, guys. I'm trying to search for an example that could suit the input, process, and output much better. Okay. All right. So I think this is the one. All right. So this example has been taken from one of a website which converts. There's a scratch.mit. This is the Massachusetts Institute of Technology, which basically converts the programming into pictorial representation. Okay. So ignore about why these colors look like, what is this green flag and all that stuff. Ignore that part. Just focus on the part that I'm going to discuss. Okay, and we are going to talk about the variables. What exactly is variable? Okay. Now let's say just read these two columns for a while. When flag is clicked, say hello for 2 seconds. Say I'm Big Ed from year 2082 or something for 4 seconds, and then it's putting ask name. Okay, and then over below there is a different block which says define ask name. Ask what is your name and wait, and then it's saying set name to answer, and then it says say join hello name for 2 seconds, something of that sort. Okay, actually the green flag is clicked. Okay, wherever it is, I mean, just assume hypothetically that there is a green flag which is clicked. What would happen? Okay, according to this sequence, what would happen? This sequence is I'm explaining you this sequence just to make you understand how to read this sequence. Okay, so for example, when this green flag is clicked, hello will be printed for 2 seconds. Okay, and this statement, I am Big Ed from year 2082, will be printed for 4 seconds. And then ask name, this is a reference to the below block, and below block will be called. Okay, now let's focus on below block and we'll try to relate this with the variable which we talked about. Okay, when ask name is called, there is a second block which says ask what is your name and wait. Now when ask is there, ask basically means you're asking something, you're expecting an input, you're expecting a response, right? This blue block basically represents the input that you expect from a user, right? This block is as same as writing a program to print your name with a hello appended before it, right? So if you have got a program which says print your name with hello before it, right? That's basically this program is doing. So ask what's your name and wait is basically the computer will say what's your name and it will wait for your input. Once you have given the input, it will set that name to answer. Now focus on this particular and try to understand it slightly better. Okay, this is set. What is set? Set means you are setting the name that you have received from the second block, right? The name that you have received from the user to answer. Okay. You have created a variable called name by yourself. Okay. You can create a variable. You have created the name called a variable and you have assigned the value of the answer to that name. So suppose if in second block you said Shubham as the input you gave, the answer in the line 3 that you see would be Shubham, because that's the input you gave, and you are setting name equals to Shubham. And in the fourth line, when you say, it's basically outputting the output with joining hello and name. Now see over here, name could be anything. Name is a variable here, but in the third step, we had assigned name to the answer, which was accepted by the user, right? This might become more clear when you go in the syntactical representation, when we do actual coding, right? But the intent of showing this particular example was that once you expect something from the user, once you take an input from the user, you assign it to a variable which is created by you. When you are a programmer, when you are writing a code, and you expect a user input, either it is number input or any kind of input, you expect a number input and you assign it to a variable. And then you use that variable to either print it or to either do any kind of changes on top of it. Okay, any kind of modifications if you want to do on that particular variable, it is done via variable names. Okay, and user input is stored as a value in that variable. Okay, this is slightly different than our usual real world examples, hence it might be slightly difficult to understand, but try to spend some time on it, right? That any input that we receive from the user, we store it in a variable. That is one. Okay, variables are created by us only. I mean, as the coders, you can create variables in the code. Okay, why we create variables? We just saw, because we want to control the code just by controlling it from one place. Okay, that's the intent of variables. Now, I think these are not very relevant, but yeah, and since it is a variable, the values can easily be changed. You can easily change the value. So let's say you saw this example, right, where you asked for a name and you stored it and you printed the name, right? You can again, after printing out the name with a hello, you can again ask for a different input, that what's your friend's name. And once the user input comes again, for example, if the friend's name could be any XYZ, you can assign that XYZ to the name itself. The same variable you can use to now point it to a different value, right? So now if you print the name, what will be printed? It will be printed XYZ, because now the value of name is XYZ. Previously it was Shubham when you printed, and after that you asked for input again from the user. Second input you assign to the same variable. So now the variable value has been changed. Okay. All right. So this was about the variables. So lesson 3 is about selection. Okay. We covered about sequencing in the first one, right? We in the second one, we covered about variables, and this is about selection. Now in this lesson, we are going to talk about conditions as an expressions. Okay, what is selection? Selection is basically branching. You create branches depending upon a condition. That is selection, right? And how do we define condition? That is something also we'll be covering in this program. And identify that selection uses conditions to control the flow of a sequence. So basically, selection uses conditions. There are certain conditions associated with the selection. Remember the tea preparing the tea example. The condition we had was asking someone that they want coffee or they want tea, right? And depending upon their answer, we control the flow of sequence. We control the flow of sequence as in whether to go for sequence 1 to put tea leaves or where to go for sequence 2 to put coffee powder, right? This selection would lead to different flow of sequence altogether, right? So that is how selection is all about. I hope you all have played with the deck of cards, right? We have hearts, we have spade. What else we have? Heart, spade, diamond, and what's the fourth one, guys? Heart, spade, and diamond, and I think heart, spade, and flower. And what do we have? Deck of cards. Types. We have we have clubs, hearts, spades, and diamonds. Okay, clubs, hearts, and spades and diamonds, right? So I guess you guys are aware about this. This displays of card. We call it teen patti. We call it with n number of names. Okay, you need to answer me true and false. So the very first question is, the color of this card is black. True or false? True. The suit of this card is hearts. True or false? False. Okay, that's right. The value of this card is greater than 5. True or false? False. Yes, absolutely. Okay. Now, we were so active and we were able to do this calculation very easily, right? The reason being, it's evident. We can see it on the screen, right? How do computers do the same? To cover that part, we are going to do this particular example of selections. Okay, now you see this block. If then, okay, this is the blueprint of how programming languages control the conditions and the control statements that we just had an activity on. Okay, now what would you do is, usually if you ask a question around how can we convert the activity that we just did into something in a form of a programming language, right? The very first thing that you would do is understand what exactly card is given to you by the user. So basically the card that I showed you, which had 5, which was black in color and which has the suit of spade, right? This is something will be provided by the user. So you need to have a program that can accept the inputs, right? So basically you would ask from the program itself the relevant questions that should be enough for you to make sure and to understand exactly which deck of card it is. So you'll ask questions like, what is the value of that card, which is 5? What is the color of that card, which is black? And what is the suit of that card, which is spade, right? Once you have these 3 knowledge in the system, you need to store them as on a variable, right? You would store them in a variable. The value equals to 5. So value is the variable. Suit equals to spade. So suit is the variable. And then color equals to black. So color is a variable. So you have 3 variables: value, suit, and spade. Now, all the questions that were asked, the very first question that was asked was, I mean, true, false, although it was true, false, but if suppose the question is print or tell me the color of the card, right? So what would condition go over here is, this is the snippet that should go in the code. Tell me the color of card. You should not directly print that print output equals to color, because the variables can change. So basically we'll use the if then statement. So if color equals to, and then you'll put the value black, then put the value as black, or else put the value as red, right? So I mean, this exactly is how you configure conditions in the computer. Okay, this rhombus that you see is the place for putting conditions, is a place where you can put conditions, right? And this rhombus will always return true or false. Okay, and depending upon if it is true, it will return the statement which is present right inside it, or else it will return the statement which is outside it. For example, the same pictorial representation if I give you, condition and expressions. So if the character has a heart is true, remove from the game, else keep in the game. Right? So basically, if the character has a heart, has a, sorry, not heart, has a hat. If the character has a hat is true, then remove from game. So basically, so you're telling the program to remove all those person who have a hat uh, in the game. In the game, the characters have a hat.
Let's have a quick quiz question, guys. And the question is, which of the following is not a type of queue? And your options are priority queue, single-ended queue, circular queue, or ordinary queue. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ENICT IIT Guwahati. The course link of which is given in the description below. Now let's continue with the session.
Right? So we have three such characters, this blue hat, red hat, and this one. So they'll be removed from the game. Right? And how would you achieve it? Is the if else statement I talked to you about. Right? Over here, if the condition goes, the character hand is empty, then remove from the game, keep in the game. And over here, you can put any condition. If the character has a hat, why am I saying heart and hand? I'm not sure, but okay. I think it's a tongue twister. Anyways, so yeah, if the character hand is empty, or if the character hand is not empty, if the character has a hat, if the character does not have a hat, any kind of conditions. If the color of the card is blue, if the color of card is black, anything of that sort, the conditions should go over here. And that's how you control it. Inside the if, you put the condition, and then depending upon that, the sequence is followed. Remove from the game, keep in the game. Comparing it with tea example, if user input is coffee, put coffee powder, else put tea powder. Right? So this is the pictorial representation of how programming languages look like. Right? And that's all about that's the only thing about conditions are. Okay. Other way of putting condition is you can put conditions in any of the case. I mean, just ask the user, how is your health? I mean, is your health good? Okay, ask the user and store their answer in a variable called health. Right? You ask the user, is the health good? Okay, if the answer is yes, then only print good, glad to hear it. Right? So depending upon what is the value got stored in the health variable, what is the value that was returned by the user as an answer, you are printing it. Right? So these are conditions involved. And that is what selection is. Right? Conditions are the green ones, are the conditions. And depending upon that condition, you make a selection. And hence, it justifies our statement that selection uses conditions to control flow of a sequence. Okay, that is about selection. And there are certain type of conditions. So we dealt right now only with one type of condition, which was equals to, right? Whether it is equal to n, whether it is equal to black, whether it is a spade, heart, right? But there could be n number of conditions. Like one is always equal to, one is comparison, right? Do you have a value of card which is greater than 5? You guys told false, right? How? Because you were able to calculate that this value is not greater than 5, is equal to 5. Right? So you can have variables, variable comparing to variable, or variable comparing to value. Such conditions are also possible in programming, where you actually compare those conditions and then print the output. Or other type of conditions would be AND operators or operators. In AND operators, you're basically combining the conditions. So you can have two different conditions appended with an AND. For example, first condition over here could be, is the color of the card is black, and is the value greater than 5. Right? Now to fulfill the overall condition, both of these mini conditions has to be true. Then only the whole bigger condition will be actually true. But in case of OR, any one condition, if it is true, it will make the overall condition as true, right? So first thing, you can have variables comparing to variable being logical operators you can apply between variables and have a condition operators. Also, you can have multiple conditions and append them with and or all that stuff, right? Everything is possible in the code. Now, when I say operators and selection, operators could be either comparison operator, less than, greater than, or equal to, or logic operators, and or not. Okay. Now, operators are something in programming language that we can use either as an arithmetic operation. All kind of operators, for example, addition, subtraction, multiplication, division, are arithmetic operators, which you can use to make any arithmetic operation in a program between two numbers, two decimal numbers, anything of that sort. Those are arithmetic operations, right? Those are fairly simple, hence I have excluded that from this particular exercise. But the comparison operators, the less than, equal to, or less than equal to, greater than equal to. So along with these three, you can also have things like this, okay, which basically means greater than equal to, less than equal to, right? I'm assuming you guys are aware of this. So yeah, and there is something called logic operators, which compares the logic, like and, which we discussed. To compare it, if there are two conditions, both has to satisfy to in order to make the complete condition as satisfied. That is something and is used for. Second is or, and the third is not. Not is basically negation. It just makes the condition as opposite. So not of false is true, not of true is false, like that. Okay. So yeah, that is something about it. And if you can spot the comparison operator in this code, this is something which I was mentioning in the previous example, that you ask the user, are you okay? And store the answer in the health variable. And if the answer is yes, the health variable value is yes, then you say, good, glad to hear it, something of that sort. So the operator in this particular scenario is on the line number 4, which where we are using the logic operator to convert to check if health value is equal to yes, right? So that's the logic operator. Okay. There are comparison operators as well, and examples that you see over here. This example shows, and this condition will satisfy only when variable 1 is equal to variable 2. Okay, that is the condition applied on that particular operation, where the condition is being checked between variable 1 and variable 2. Second condition is it's being checked if variable 1 is greater than 10, and the third is 200 should be less than variable 1, or maybe variable 1 is greater than 200, right? So these all are comparison operators that you can apply between two variables or between a variable and a value, right? Comparison operators are mostly in numerics. I mean, you can't compare to text, correct? So comparison operators are usually numerics. Okay. Apart from that, we mentioned about logic operators. Logic operators, as in you combine two different conditions to make a bigger condition, right? Over here, we have combined number greater than 30 and city equals to Athens, or number greater than 30 or city equals to Athens. Okay, I am assuming this is clear to you. What might be confusing for you is the last one, which is the negation one. Okay, I am assuming most of you or all of you are above 18. Okay, in terms of age. Give me the output of this particular statement in the chat in true or false by assuming this age equals to your age. What would be the output? So that I understand that you guys understand? Okay, cool. So I think you have understood. So basically for the folks who have not responded, or in case someone has not understood, age, assuming your age is 18, let's say 22. Okay, so 22 is greater than 18. So the inner condition becomes true, right? 22 being greater than 18 becomes true. Hence the inner condition becomes true, but there is an outer condition of not, which is a negation condition. Negation is something, it just flips the condition. If it is true, it becomes false. If it is false, it becomes true. That's the negation. Hence, since the inner condition is true, after putting negation, answer would be false, and hence the answer is false. Okay. All right. So this card deck, we have already done it. So yeah, I mean, related to card, if you need to put expressions, this is how would you do it. Okay, if suppose you want to check if the value of card is 6 or not, right? If your value is greater than 6 or not, if you want to check that, suppose you have been given a card, this is the same card we used in the previous example. If you want to check the card, the value of the card which has been given to you is greater than 6, this is the piece of code you can write. If value is greater than 6, then say true, print true, or say anything like that. That's the expression. If you want to check if the value of the card that has been given to you is king and the suit is hearts, how will you do it? This is an example. You'll use an if condition where you will compare value equals to king and suits equals to heart. And then if the both condition satisfies, you'll say it true. Okay. And just giving you some bunch of examples, so it becomes more clear how real world statements with respect to how you'll write in the programming language. Okay. Expression 3, if suit equals to spades or suit equals to diamond, return true, right? So this is how would you write. Expression 4, if you want to return true if the color is not red, this is how will you write. Okay, if condition and putting the condition below. Okay, expression 5, value equals to queen or value equals to 9 and color equals to black. How will you write this statement? So basically there is a bigger condition inside which there are two conditions. Two conditions are joined by and in the first condition, there are again two conditions joined with the help of or, right? So it's a nested condition, and that is also possible in programming. Value equals to queen or value equals to 9, that's one condition. And then after that condition, there is another condition of and. Okay, so this is how you will write, and it's possible. Again, it's possible that condition has two conditions. Both the two conditions have two other conditions within them. An example for that is return true if value is less than 5 or value is greater than 10 and suits is equals to club or suit is equals to hearts, right? 4 conditions are applied with a complex nesticity, nested conditions, but this is how you would write. Clubbing these two first, right? And then clubbing the other two first, and then clubbing the first one and the last one with an and, like that. And these are some statements with their evaluations, which you have already understood. I got an idea from the example, right? So this was a fairly simple lesson of operators and selections. Second last lesson we have is on the count control iteration. Okay, what is count control iteration? Now remember the same example I think Akshay gave in the example for iteration when we were in the lesson 1, count till 10, right? So that's the exact count control iteration is over here. So in this lesson, we'll define iteration as the process of repeatedly executing instructions. Okay, describe the need for iteration. I mean, till what time iteration is required, and implement a count control iteration in the program. All right. So iteration is basically keep doing the same thing till the time it's done. Okay, that is iteration. An example for this is you can print same thing repeatedly n number of times, or you can print 10 numbers or 10 different numbers, anything of that sort. Now there are two type of iteration. One is count control iteration, other one is condition control iteration. Count control iteration is when you execute the commands set number of times. For example, there's one way of saying print numbers starting from 1 10 times. Okay, 10 times print numbers starting from 1. Every time print the next number, but print only 10 numbers. Again, 1 to 10 will be printed only. But there could be another way of saying print the numbers starting from 1 till the time it reaches 10. That is other type of condition, which is condition control. Over here, we were counting that print 10 numbers. As soon as you have printed 10 numbers, irrespective where have you reached, stop. But in the second one, we are saying till the time you have reached 10, keep printing the numbers. Okay, so that's the difference between count control and condition control. Count control is something that is keep executing the command n number of times. Condition control is keep doing it till the time certain condition is fulfilled. Okay, and there is this example where it's an example for iteration, where you see fifth line is the iteration. First line, you're asking what times table would you like? Okay, basically table, table, right? 2's table, 3's table, basically you keep multiplying with 1, 2 and 3 like that, right? And then you repeat the same with the help of the number that has been received from the user and multiply by something is over here. So we have set it to 1. So basically iteration is you repeat the same thing either by counting it or either with the help of a condition. Okay, nothing more on that front. We can learn about the exact syntactical representation once we start the coding part. So this was around count control iteration. Okay, now any program that you write, you obviously create a file before you write, right? The IDEs, when there are IDEs like VS Code, Atom, right? Or even Notepad. When you create a Notepad and you write a code, any program that you write anywhere in a coding IDE, you need to put an appropriate name for that file. And that's one thing. And second thing is each program follows a proper structure, its own unique structure of framing the code, right? So two things are very important in the syntax. The very first thing is the name of the file, which is over here, as you see, main.java. Instead of main, you can put anything else, right? It's just that for this is, for example, over here, it has been used as main, and you can use any other name provided the first letter is capital, right? That's the convention. Okay. Once you create a file .java, and it's very important to put the extension of .java. Okay, if you are writing the code in Java. Okay, and then you can write the code by yourself, just like it is shown over here. In that, it's very important to understand first 2 lines of code. Okay, the very first thing what we are doing is we are creating a class. Okay, what you see it over here is public class main. Now, this main keyword is actually matching with the main keyword that is present in the name of that particular file on which Java code is there. So your file name should always match your class name. That's the first thing. Okay. There are 2 other keywords as well, which is public and class. Now, public, I will not go in detail on this public keyword, but just to give you a high level idea, this public is an access modifier. When I say access modifier, it takes care of the access. It takes care of who this class will be accessible to. Now, this is obviously not relevant in our course because we are not building any large scale project as part of the curriculum. But there are a lot of times when there are large scale projects and there are certain class you will have to put instead of public as private or protected, so that the cyber attacks or the threats, it is saved from that particular angle. The access modifier is used, but we are not dealing with those aspects in the curriculum that has been designed. It's more about data structures and algorithms. Hence, you can just assume this to be a housekeeping activity, right? Just mention public class and use the word which is there in the file name. All right, that's the first line. Second line of code is public static void main string args. Okay, now this is something, it has a lot of keywords, there are a lot of things, but do not get confused. Let's go one by one by breaking this whole line into chunks. First keyword is public, which is as same as what I mentioned in the first line, the access modifier. It is a class. The first line was defining about the class. The second line defines about a method. Okay, now there is a slight difference between a class and a method. Okay, so if I write it in a way, a class can have n number of methods. Method 1, method 2, method n. Okay, that's usually a class. It has a lot of methods, and collection of methods, one or more, should fall under one class. Okay, in this example, we see only one method, which is okay because it's a class and we need to have only one method. And that's why you see public static. Now, what is static? Again, static is a keyword which is responsible for talking about the dynamicity of a particular language. Okay, now if I show you the exact meaning of static part, I should be seeing over here. Okay, it's not mentioned over here. All right, anyways, so static is something that is basically judging whether your code is subject to change during the runtime or not. While the code is being executed, is it supposed to change or not? Again, from our perspective, since we are dealing with data structures and algorithms, we will be sticking to static only because we are not building something that will be around spawning of threads, multiple parallel processing. Those things we are not dealing with, right? So we'll be sticking with only static. That's the two keyword, public and static. Next keyword comes as void. What is void? Okay, what is the literal meaning of void? Let's check that. So literal meaning of void says an empty space or a vacuum, right? Or let's say an empty thing, empty space. Same thing is reflected over here as well. You need to put things over here according to what is being returned by your code. If your code is returning an integer, if your code is returning a number, or if your code is returning a value or text, image, anything, if it is giving back something as an output to the user, right? If it is returning in the form of, let's say, integer, or it's expected to return something. Okay, it will become more clear once we go ahead in the system. But right now, you can just imagine that if it is supposed to return something to the code, not to the user, but to the method itself, if it is supposed to return something that can be used by other methods, then this keyword will change according to what is being returned. But the code that we have is just printing out a statement called hello world, right? Hence, we do not need any kind of any kind of other value except void. Had it been the case that we are writing something like this over here, right? Instead of system.printout out, if we are doing something like return 1, right? That means we are returning something. we are giving back something to this method. Now, what is giving back and how it can be used by different stuffs, that will be covering later. But you can just imagine if you are returning something, if you're giving back to the function something, in that case, instead of this void, we'll be putting int. Okay, so that's the intent behind this particular keyword, which is void. Okay, main. Now this main, you can make this name to be any other name as well. Okay, this main and this main are not related. I mean, the example might sound you confusing, but this main and this main are not related. You can put class name as anything. You can put the class name as anything. I can put the class name as Shubham over here and then put it over here as public class Shubham, right? But in this method, we need to follow the convention of calling the parent method as main. Okay, and that too with a small case. It's required to put the method name as main. Okay, and then again, this one you can ignore. This is basically saying that it is free to take. It is taking an argument of strings as the input, which we will cover more on that part. But you can just imagine and just assume this to be something which is required for JavaScript format. Right? Once we deal with functions, you'll come to know about this one. But for now, most of our problems, in most of our problems, will be following this exact two lines as it is. And there won't be any change. Okay. So I hope you have gotten the syntax part of Java. Except this line, this is more or less the format. And over here, you can put your code. Right? This is a required thing that has to be done for most of the cases. In case you are making notes digitally, I have pasted in the chat that can be used. Okay. All right. So this was the syntax. Now let's come to output part. How do you print something from a code? That's the most basic thing we need to learn today. What and how to print something in a code. Now for that, we have a statement called system.out. System.out.println. Okay, and that will print whatever you mention inside the braces and inside the quotes. Right? Now there are few things I want you to note it over here. Okay, first thing is, we are focusing on this line right now. We are talking about how to print statements or how to print through a program. Okay, this is the required keyword, system.print.ln. If you are trying to print a string, you need to use a string inside a quote. These are the quotes. If you're printing a string, you need to use quotes. And that's where once you run, it will show you the output. It showed you hello world, right? In case you want to print some other output, you can print as Shubham. It will show you as Shubham. Okay. And I think I pasted the code only to host and panelist. I should paste it to everyone. Okay. You guys should have told me, but anyways, yeah. So this is the case. All right. This is for printing strings. Now, for printing the integers, if you want to print integers, you can straight away print without any quotes. Okay. I mean, if you see the example over here, we are talking about printing text, and there are multiple examples on the same. If you want to print a one-liner text, you can directly use system.print.line. It will print the text. If you're wanting to use multiple lines, you can use this part to print multiple lines. right? In case you are trying to print something without the quotes, right? Let it run. You are trying to print something without the quotes. It will only work if it is an integer, or I should say a number. Okay, since you are not very familiar with the data types, a number can be printed without any quotes. But for printing anything apart from that, you need to have quotes, right? Now I'll show you what happens once you do not put quotes if you're trying to print an output. Let's say I did not put a quote and I'm trying to print it. It showed you an error, an unclosed string literal, right? So you need to have the quotes in order to print a string. Now there is a difference. There is a print method as well. But so far we have been using println method, right? Now println method, what does it do? After printing, the pointer goes to a second line. Now when I say, I'll show you with the help of an example. I'll try to print my name with println. Okay, this is my name and I'm trying to print it with the help of println. When I do that, both of these gets printed in the different lines, right? But when I try to print with the help of this print keyword and I click on run, it will print in the same line, right? What is it happening right now? The difference is println, once you do it, once you execute it and print something with println, after printing the text, it goes to the other line, to the next line. That's why after using println, Shubham goes, the pointer goes after printing Shubham to the next line, and over there it prints the surname, which is Lal, L-A-L. Okay, so this is the difference between print and println. I hope that is clear. So this was about printing text. Now, when we talk about printing numbers, it is as same as printing text except the quotes. Okay, so over here you see we did not use any kind of quotes. We printed the number as it is, right? The very interesting thing over here that is coming up is it's not required that you print only the results. For example, I want to print 3 multiplied by 5. I do not need to use calculator separately and figure out the answer and print it over here as 15. What I can do is I can execute the operation on the print statement itself. 3 multiplied by 5. And once I print it, if you see the answer, it will come as 15 and not as 3 multiplied by 5. But what if I actually want to print 3 multiplied by 5? Not just the answer, but I want to print the 3 multiplied by 5 as it is. In that case, what I can do is I can use this quotes to make it appear like a string. And now if I run it, I will be shown as 3 multiplied by 5, not the actual answer. Okay, that is the beauty of print statement. If you want to print something as it is, if you want to print a number as it is, you can use a string literal, or if you want to use an operation, you can use without a string literal. This quotes, I'm calling it as string literal. You can use without the quotes and it will print as 15. Okay, so this was about outputting numbers. These are the very simple and the most basic concepts of Java, so we won't be spending much time into it. Next thing that we'll be studying is Java comments. Now, Java comments are something which is present to help other person understand your code. A very interesting thing that I was asked in couple of months back from one of the student, that why do we even need to put comments, right? Now, as an academic person, since you are studying right now, since you are writing code and you are reading it yourself, it might not make a lot of sense to put comments in your code, right? But once you go into the industry, it makes a lot of sense. It makes sense because if you write a code, once you have written a code and you have posted it somewhere or the other, it will be used by someone to understand. Someone else will be seeing your code and trying to understand. To help other people understand your code is the importance of comments. That is the first importance. Second importance is, if you're writing hundreds of lines of codes, right? Not just 3-4 lines, you might need to have certain pointers that can help you to see which part of code is written where. That's where these are the comments you can put. So comments should go with 2 / single line comments. So this is a single line comment. Okay. Or I can say below code prints output of 3 multiplied by 5. Okay. Now, what if you want to have, let's say, 10 lines of comment? I would not want to keep putting / on start of every 10 lines of comment, right? In that case, you have something called multi-line comments, where all you have to do is use / with a star in the start of the comment, and by the end of the comment, use star with a slash. So what you would do over here is use star and then write n number of comments you want. This is a multi-line comment. Okay. And then once you are done, you can close it similarly by doing the same. Now, if you write something, it will be treated as a code. Okay. So that is the comment part, which is required to be known to you at all times. Next thing is variables. Now, it's very important to understand what is a variable. So let's check the literal understanding of a variable first. Something that is a variable, something whose value may dictate or discovered, a quantity that may assume any one set of values, right? These all were definitions of variables holds correct even in the programming language. A variable is something whose value can change, and whose value we can change as well in our code. That's a variable. Now, when I say variable, it also comes with certain types, right? There, it could be a string variable, it could be a numbered variable, right? Now, there are a few things I want to discuss with you on the types of variable. Very first type of variable is string. Okay, we have been discussing string over here, right? We were talking about system.print as a strings, right? So over here, this is a string, right? Anything that is textual in nature, anything that is alphanumeric or textual in nature is a string. This is a string. Basically, any literal, any textual content, anything that contains text, anything that contains what do you call it? Alphabets, right? Even if I say something of this sort, right? A, B, C, D, 1, 2, right? This will also be a string because even though it contains numbers, but it doesn't matter. It has at least one character. So this is also a string. All right. So anything that contains alphabet is a string. Next is integer. Now we call everything as numbers. I have been calling everything as numbers, whatever is having number, right? But that's not the case in program. There is no such thing called number, right? There are things like integers. Okay. Now when I say integer are whole numbers. Integer are whole numbers. Like we talked about printing something like 2, right? Or 22, 23, right? These are integers. What are whole numbers? Whole numbers are something which is either greater than, equal to 0 or greater than 0, right? At least it is not less than 0. Also, it doesn't has decimals. Okay. So it could be whole numbers, and since it is an integer, it could go in the negative side as well. So sorry for the correction. Integers are not just whole numbers, but it's also it can fluctuate between minus infinity to plus infinity. Okay. So even if I try to print something like minus 243, I should be able to print it because it's also an integer. Okay. So minus 243 is something if printed. Okay. These are integers. These are integers. I'll come to the definition part, how to declare integers and all that. Right now, I'm just showing the examples of each. Then comes to float. Float is something which are not integers, but are containing numbers like digits, decimals, right? So if I give you an example of integer or sorry, float, it could be something like this. Okay, this is string. This is integer. And this is float. You should be remembering these keywords names properly. Now this is char. Now what is char? Char stands for character. Now when I say character, it's not the literal meaning of character in English, which defines someone's personality. It's not that character. It's the character of a particular string. For example, A is a character, B is a character, right? So char stores a single character, which is A, B, C, or it could be anything, any alphabet from the alphabet, 26 alphabets, right? It could be either uppercase or it could be either lowercase. And you need to know that in programming, uppercase A is different than lowercase a. So casing matters. So characters are A, or it could be B, right? So this is char. Last thing is bool. Now bool stands for boolean. Okay. Now when I say boolean, it's again the literal value, literal meaning of boolean. What does the literal meaning of boolean says? Oh, there is a no word of boolean. Okay. Anyways, so boolean is something which is either true or false. We also state it as 0 or 1. Okay. Now, if I show you the example of boolean, which I'll be showing in some time, you can treat boolean as this: true. Okay. If I show you the example of how boolean is printed, you can print it in the same way by putting it as true. So true or false. One second, guys. I think in Java it should take 0 or 1. Okay. So in Java, you can treat Boolean as 0 or 1, which might seem very similar to that of an integer, but it can be controlled as a Boolean. Okay. When we talk about how to initiate a Boolean and print a Boolean over there, I'll be covering this part of how to print a Boolean. Okay. True, I think let's try that as well. I'm not sure. Okay, yes, this will work. I was actually using the capital T. Yes, that's right. So true, or you can also use it as false. Okay, all right. So let's come to the part where we are declaring variables. We need to declare variables. Okay. So when declaring variable, each of these variables has their own way to declare, right? Declaring variables. Okay. The very first thing that we need to declare is string. Okay. Let's say we want to declare a string called maybe your name or anything of that sort. You need to follow this type of syntax where first you put a type, what type of data value or variable you want to declare, put a variable name of your choice, whatever you want to put, and then put the value that you want to give on that particular variable name. Okay. So over here, if you want to declare string, we'll use string or maybe small case string. Okay. string string. Let's say name equals to, and since you are declaring string, you need to use this quotes. Okay. So we have followed the same way it has mentioned it over here. Okay. Now, when you try to run it, doesn't much will happen. So think, okay, what did I miss? I missed the semicolon. Now, when I printed it, nothing much happened. Things got printed till here, which is around print statements, but then nothing happened for this statement. Why? Because we have only created a variable called name. We have initiated a variable called name and have not done anything with that particular variable. Okay, so later on, I'll show you how to exactly use that variable as well. But for now, we'll just use the print statement to use this variable. Let me also use a print statement to create a demarcation so that we don't get confused. Okay. And then use a print statement. Now what happens? Remember, I told you you can't print something without using without using quotes. You can't print a string, right? That was for string. But for variables, once you have created a variable and assigned a value to it already, you can use that variable name directly without using any quotes. And when you do that, you can print your name semicolon. Okay. Once you do that, you can print whatever is present in the name variable through this name keyword. So you see over here, it has been printed as expected. Next, we come to declaring integer. And to do that, it is int. Let's say, put it as my int. And you can put any integer 001. Okay. And you can do the same way to print the integer as well. Copy, paste, and then run it. Similarly, you can use it to declare float. Okay. Float, in case of float, you need to put keyword as float. My float equals to 12.3 or any number of your choice. You can print system dot out my float. Once you do that, it will show up like that. Similarly, you can do it for character as well. For character, you will use char, and for Boolean, you will use bool. Okay. Let me also verify what is the Java one for Boolean so that it's correct. Okay. For Boolean, you will use Boolean. Okay. In actually Python, it is used as bool. For on Python, it has to be Boolean. Okay. Like this, you can create your own variables. Let me copy that and paste it over here. These are the types and the ways you can create a Boolean. Okay. For printing, again, you can use these variable names to print any of these. And in the same way, we have been doing it in the above. Okay, there is a error in incompatible types, possible loosely conversion from double to float. Okay, so let's see what the error is. First thing, it says it's in line 44, where we have declared the float integer. Okay, and this float integer is coming because we have 1 second, guys. This is float. This should not be the case. We are not trying to change it. Did we use this variable anywhere above? No, right? Okay, no problem. We'll look into it, why the error is coming. So float should be the right keyword. That is something I don't think it's using F. Okay. There are certain Java syntaxes which are specific to Java, and this is, I think, one of them. So when you declare float, you need to mention in the value as well that it's a float by highlighting it as F. Okay. I think that's what happens when you have multiple programming languages learned. I at times get confused between which is the ideal way to, execute on which language. But yeah, in all the cases, you can just mention it as it is. All decimals in my default double in Java by default. Okay. Okay, Akshay. Awesome. So this is the way you can declare the elements. And for float, I think F has to be appended after the number. Okay. Printing variables. We talked about it right now. How can you print variables? But there is an interesting way of printing variable as well, which is by appending a text onto it. For example, I have used on this part, used my name, right, to print. I can also do it in a way where I append my name into a different keyword called hello, and then I append my name on top of it. I will also give a space after O so that it becomes clear when someone reads hello and name. Okay, and once you do that, you would see both getting printed as hello Shubham. Okay, that's about printing variables. You can also do things differently where you have created first name and last name as different variables, and you created a third variable by appending and adding first variable to the second variable, right? And then you printing the final created variable, right? What you can also do is, we talked about print statement executes the arithmetic operations as well. You can do that via variables as well, where you have created a variable x equals to 5 and y equals to 6. And then you are using variables to execute that arithmetic operation on a print statement. Okay. Now, if you want to declare multiple variables, that is also possible. You can either use multiple lines to do that. If you want to have 3 integers declared, this is the way you should do it, by declaring it x, y, z separately. Or if you want to simply write it once, this is the way you can do it in a single line, where you have to use int only once. Okay. Again, it's also possible if, first thing, if all of them are integers, This is the ideal way which can save your lines of code. And if all of them has same value, then instead of assigning values like this over here, you can initiate all three integers in the same line and then at one go assign the value to all three integers at once. This is not just true with integers. This is also true with text variables, like float, decimals, boolean, or anything, right? It's true with all the data types. Okay. Now, identifiers, it's not required for programming, but it is required from the industry standards perspective. Like if you use m equals to 60, right? What is m? You might not be aware what is 60, right? So that's why in the industry we are promoted and accepted to requested to use things which are more meaningful, right? Minutes per hour. Now it makes more sense. The 60 defines actually the number of minutes per hour, right? But for you guys, I would not suggest this to use for now, because these things will also already get built up once you are in the industry. For now, you can use single letter keywords, and that will be good. Okay. All right. Next thing that we want to discuss is data types. Okay. And I would not go in detail with this particular segment because it just talks about first thing, which we already discussed, what are int, float, character, boolean, string. And next thing, it talks about the sizes of each. Now, these sizes defines what is the amount of space it occupies in the memory location of a system. Okay. And why is that important? First of all, why do we even need to know that? Okay, int requires 4 bytes, long int requires 8 bytes, float requires 4 bytes, something of that sort. Why do we need to know that? Now, I will just touch upon two aspects of something. Remember in the last class, we talked about two chefs, right? Two chefs preparing a same dish. One taking a lot of time to prepare and creating a mess in the kitchen. Other one preparing the same dish in less time and making less mess in the kitchen. And we will always prepare the second chef. Why is that? Because the second chef is better in terms of organizing things in time and also preparing things properly. Similarly, every program takes certain amounts of time and space to execute. That space could be because of your variable, or that space could be because of runtime variables that is being created, or something is being stored in the memory of anything of that sort, right? And time taken can be different for different programs as well, depending upon what is the approach that has been taken by that program to solve a particular problem. All right. Now, these two factors leads to complexity, and we call them in our coding world as space and time complexity. I think I had touched upon this in the last time. Space complexity basically defines what is the amount of space your program is taking to execute. And time complexity defines what is the time your program is taking to execute. Right? With this space and time complexity, say space complexity can be calculated with these data types. I mean, you can actually, when you know the size of each, if you have used 3 integers, 1 long integer, 1 float, you can actually count the number of space you're using, right? That's why this is required to be known if you're trying to optimize your program. But since we are not in that stage yet, we will skip this part. Next, we have integer types, bytes. I mean, this is something, again, I will skip, because data types, whatever we have studied so far, is enough for our learning. Okay, typecasting is something we'll skip for now. Next comes to operators. Now, what are operators? Let me just erase all these. I will put this in the chat in case any of you wants to have a reference of this. Okay. Oh, I can't paste so much content. All right, I can't paste so much content. Anyways, what I'll do is I'll copy this. And run it over here, and I'll give you this link in case anybody needs it. Okay, so this link, this is not a unique link. It's not generating a unique link actually. Okay, it can generate. I'll put expiry of 24 hours.
Let's have a quick quiz question, guys. And the question is, when a pop operation is called on an empty queue, what is it called? And your options are overflow, underflow, syntax error, or garbage value. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ENICT IIT Guwahati. The course link of which is given in the description below. Now, let's continue with the session.
All right, this is the link. Over there, you'll find the code around whatever we spoke till now. Okay. All right, so I'll remove this whole content. Okay, now we'll come to operators. Now, what are operators? Operators are simple arithmetic operations. That is the first thing that what operators do. Or it could be assignment operations like equals to. This is also an operator. Okay, or comparison operator. It has rightly classified over here. Let's go one by one. Very first thing is the arithmetic operations. Now, when I say arithmetic operations, is as simple as, let me do this way of int n equals to 4 plus 4, right? And then you can do system.print.n will be equal to 8, right? That's the arithmetic operation. Now, along with 4 plus 4, you can also do things like subtraction, multiplication, division, which is something that you already know, right? I don't need to touch upon this. But there is something called modulus. What is modulus? Now, modulus is something which returns the remainder. For example, I want to see what is the remainder that remains when I divide 5 by 2. Right? What should I get? I should get 1, because once 5 is divided by 2, it's 1. Right? And that's what you would see over here, 1 as being printed. That's what you see. Right? You can put anything over here. If you put 10 divided by 20 divided by 2, 20 is actually divisible by 2. So what I should get would be 0, right? So these are the arithmetic operations. There is something called plus plus or minus minus. This is something might be new for you as well. Plus plus is something which will increment your variable by 1. Minus minus, that will decrement your variable by 1. So if I do plus plus 2, let's see what happens. One second. I think, wait a minute. You should not put it like this. I should be putting plus plus 2 like this. N equals to 2. Okay. It works only with variables. So once you have assigned the variable, you have assigned 2 on a variable, and on that variable you can append the plus plus as written over here, and it will increment it by 1. Okay. Now if I do minus minus, it will decrement the variable by 1, and you will see 1 being printed. Okay. So this was about arithmetic operations. Next is assignment operations, which is as simple. You can just we are already being using assigning something on an integer, right? There is one interesting thing, which is this part. Plus equals to 5. What is plus equals to? So if now I want to x equals to 10, and I want to use this operation, which is x plus equals to 5, what would happen? Now this statement is as same as x equals to x plus 5, nothing else. Okay, don't get confused by something like this. Now if I print this part, what we like? X was already 10. Later on, we assigned, oh, every time I'm missing the semicolon. Yeah, X was already 10. Now what we do, we assign X equals to 10 because the value was already 10 to 5. So it became 15, and hence you see 15 being printed, right? This is true for all the cases. And this is example, and what is it same as? Okay, just focus on things which we have studied so far, which is still over here. From below, it is more on the bitwise side, so we'll see that in later part. Okay, so this was around assignment operation. There is something called comparison operation, which you can use to compare stuff, right? And that's how you do it, by using double equals to, not equals to, greater than, less than, greater than or equal to, less than or equal to. Let me just use the same example which is mentioned over here. We put x equals to 5, y equals to 3, system.print.ln, and we need to print if x is greater than y or not. Now this will, as I had mentioned, this print statement will also take care of the Boolean expressions. I mean, it will also take care of the operations, not just arithmetic operation, but this is also an operation of a comparison operation. And comparison will always return you Boolean values. So in this case, since 5 is actually greater than 3, I should be seeing true being printed. Okay, we are reusing the x value. Let's change it to, let's say, z. We see true being printed. And that is the case with this one. Similarly, there are a lot of other operations you can do with these as well. Okay. Now there are some operations you should also know that along with just one operation, you can have multiple operations along with it. For example, I'm assuming you guys are aware about and or, right? So let's say we are putting it as D and F. Okay. And doing this and D less than F and run it. Now what will happen? This statement was true because Z is actually greater than 3, but this statement D less than F is actually false, right? One statement is true, one statement is false. That's the reason we see false being printed, because we have AND operations. If you're aware about AND operation will return true only when both the conditions are true. And similar to that, we have something called OR operations. Like this it is mentioned, logical OR, right? Now when you print it, either of the statement, if it is true, the resultant will be true. And that's what we would see over here, that now it has printed true, right? So this is about the logical operators. You can apply negation as well, which is logical NOT. It will make true as false and false as true. Okay. So that is about it on the operation side. Next thing, we have strings. Okay. I'll use the same window. Now I'll be using the same example where strings, we have created a string called hello, which variable name as greeting. And there are certain operations that will be defining on strings, right? The very first operation is dot length. Okay. Dot length basically will give you length of a particular string. And since length of a particular string is always an integer, length of anything, I mean, length of a text will be anyways an integer, you will see an integer being printed. So if I run this code with string text like this, and then appending this particular keyword, which we have studied in the first segment, and then putting text, which is the variable name dot length, will give you the length of the string. Okay. Next thing is changing the casing of the text. Okay. Let's use the same text, but now we need not use this one. What we want to do is we want to make it an uppercase, and also we want to make it a lowercase. Let's change. Okay, that's fine. And if we do that, since text value, now we have changed. Previously, text value was ABCD till all the way to Z. Now the text value is hello world. When you try to change to uppercase, it will become hello world. And if you try to change to lowercase, it will become hello world in the lowercase. Okay. Next thing is finding a character. Now this is quite unique. Let's show it to you guys, and then we'll discuss this once this gets printed. Finding. And also, since once we have defined the text is a string, when changing the value of that particular variable, you should not use the string variable, string keyword again, else it will give an error. Okay. Now, let's say we want to search in this string, where is the locate keyword situated? Okay. To do that, what we are doing is we are doing string, the name of the string dot index of locate. Now, what is index? Now, see one thing, whenever there is a string being created, whenever there is a string, there are index associated with each of the character. And those index are nothing but these are the index. So when I say 0th index, it will correspond to S. 1th index, first index will correspond to T, second R, third I, fourth N, fifth G, right? These are the index of strings. And when I say this string, the index of locate, please locate the index of this particular locate keyword. What it will do, it will count from P with 0. 0, 1, 2, 3, 4, 5, 6, 7. Now at 7th, it found the first character of the locate keyword. Hence, it will return 7. And when we run it, it should return us 7. Okay, so that's the intent and that's the programs. Okay, concatenation, we have already covered that you can use your plus symbol to concatenate the string, but there is also a method using which you can concatenate strings, which is variable name dot concat. Dot concat will append this first name with this last name. Okay, but the only problem is in this one, you can actually put a space between first name and last name. In this case, let's see what happens. Okay, so even if you do not have a space anywhere shown, not in the string or not anywhere over here, it will still append along with a space. But if you do something like this, first name dot last name, and it will, okay, one second guys, there is something, there is a space after John. Okay, I'm so sorry for that. Yeah. So now if you see, the last statement will not print with any space, nor the first statement will. Okay. In plus, when you're doing concatenation via the plus symbol, you can actually use this functionality of putting the space in between. But in case of concat, you need to handle it on the variable's end. Okay, that was string concatenation. Similarly, we have numbers and string, where numbers will be added in the way that you expect them to. But if you declare a number as a string and you add them like a string, it will be added in the string manner, like 10 plus 20 as strings will become 1020, right? Similarly, for the special characters as well. Okay, special character is something not required as of now, so I'll save it for the next subsequent session. Okay. There are certain math functions which I would like to discuss with you all. And those math functions are, the first and the most common one are max and min. What does max and min does? It takes input of numbers and returns you the maximum of them. For example, system.print.out. We would need to import the math keyword actually. Let me do that as well. Math, system.maths. All right. Okay. So when you see system.print.out will print using the math.max function, will print the max of the numbers present in this. Now let's try to put something else over here as well. Let's see what happens. Okay, it gives an error. And why did it give an error? Because you can't put multiple elements in the math function. It will only take max of 2 elements and compare them to return. Okay, same case with min as well, and square root, abs are few other methods as well, which is not fairly used from the data structures and algorithms perspective, but these are good to know. Square root will return the square root of your particular number, and abs will give you absolute value, absolute as in if it is minus 4.7, it will return you 4.7. Random number, it will keep generating a random number till, you know, till whatever you have specified. Okay, so it will generate a random number of an integer, or let me explain this as well. This function math.random will actually generate a random number multiplied by 101, or when you use only math.random, it generates a number between 0 and 1. Okay, let me show it over here. Right now, okay, I need to print it out, guys. Okay, let's see what does the last print statement prints. Okay, last statement prints as 93. Now, if I remove this 101 multiplication, what am I doing here is I'm generating a maths.random and trying to make it as integer. Okay, it generated a 0. Because I am trying to put it as integer, it will always return me a 0 because it has been generating only between 0 and 1. Let me remove this int function. Now you will see the actual random function, what exactly it is generating. Okay, it will be generating something between 0 to 1 with any character to int. Okay, I have put it over here as int. Let me put it over here as double. Okay, now you see it is being printed anything between 0 and 1. That's the beauty of random numbers. It prints as per whatever range you have specified. If you have not specified, it will print anything between 0 and 1. Okay, Boolean we have covered, and we have also covered these statements as well. So this is something we have covered as well. Now let's come to conditions and statements. This is the most important aspect which you will be seeing in lot of your journey towards data science, data structures and algorithms. If statement, the syntax is quite simple. The syntax is if followed by a condition and followed by a block of code. If I write it over here, let's say create a variable int n equals to 20, and then followed by a if condition, if n equals to 20, followed by this spray. Why is it happening like this, guys? Oh man. See, system dot print dot else. Okay, this editor is not very strong in terms of indentation, but I can bear with it. Okay, system.print.out, let's say 0. Okay, anything. Now let's run this and see what does it prints. Okay, there is something has gone wrong. Illegal start of type. Okay, you need to put a space over here and here. Okay, now if you see, it should work. Do I need to put spaces over here? Okay, I think while copying, I edited the main method as well. Let me take the main method from somewhere else. Okay, and the whole thing like this. Okay, so what did happen over here? We assigned an integer. We initiated the integer n and assigned it to n20, right? And then if n equals to 20, we are basically comparing the value of n with 20, right? This is the comparison operator, which we have seen in the previous sections. If it is happening, print the value of n, else print 0. Now, if I change this to, let's say 0, if n equals to 0, print 20 or print the value of n, or else print 0, right? Now it will print 0. Or if I change it to any other thing, I can even compare it with a string ABC, right? Overall, when this statement is true, when the comparison operation is true, it will, oh man, okay, guys, I need to do the typecasting over here as well. So don't worry, the intent behind this is whenever this statement is true, whatever is inside if it is true, it will return the statement which is inside the if condition. Else, if the condition is false, it will execute the code which is in the else conditions. So right now you saw value of n is 20, which is not equal to 45. Hence, the code in the else statement got executed. Right? So this is the way for you to do the if else part. Now this was a very, very simple example of if else. Once we discuss the questions, things might become more easy. Scanner function. Okay, now so far whatever we were discussing were around, we were ourselves creating variables and putting value to it, right? But that's not how usual function works. usual program works, right? How does it work? Mostly we take input from the user. In most cases, we accept and we take inputs from the user by prompting the user to put the value. And that is done by a scanner library, which is present under util, and we import the same. So far, we have not been doing that. So you see, we were just starting with public class main, but now we need to import a library as a scanner class, and then we create this function. Okay, once you do that, that's the first thing you need to do. And if you are being confused, public keyword, why is it not here? It's like you can do it. That's not an issue, right? And you can write public, that's not an issue. After importing the scanner library, what we need to do is create a scanner object. Okay, while bringing up any new library, we need to create an object, and using that object, we can accept user inputs. For example, in this case, we are seeing that there's a scanner library we have imported, and we have created scanner object called myobj. Okay. In order to accept an integer or a string, let's say if we are wanting to accept a string, we can do something like this, where we prompt the user like system.print.ln that enter username, and then we create a username variable and say my object, which is a scanner object, dot next line. When we say next line and we run the code, you see something over here being written, and user can put the input. As soon as the user inputs the input, username is Shubham gets printed according to the last line. Okay. If we want to take input as an integer, byte, boolean, float, anything of that sort, this is the way we should be doing it. Okay. Only in the cases where you actually need to have input, you can do this in this manner. In case it is not required, that's well and good, but this is the way you should be doing it. So if I just copy this code and paste it over here. Okay, and I run it. It will give me next line, as you see, is responsible for integer inputs. Next line is responsible for integer inputs. And that's what you see over here. It comes as a integer. Okay, but if I change this as next int, or it gives the prompt, nice. Just like this, it will now accept an integer. If I put anything apart from the integer, it will return me, return me as an incorrect statement. And I run this. I hope there are no errors. Let's see. Okay, there will be an error because it's initiated as a username. We'll have to put it as int over here as well, and then run it. Enter username 007 and username is 7 because it's an integer, right? Integer basically removes zeros from the front. That's why you see 7. So this is the scanner class. So the first question that we had was sum of two numbers, and it's very simple. So far, whatever explanation I had gave you was around adding the variables. But since now we need to take the input from the user, we are using the scanner function. Okay. I had also told you, if in case you're not able to take the scanner input, if you're not able to take the input from the user, you are eligible and very okay to use directly adding variables, like hard coding it. Instead of doing this, you can also do this, just putting number 5 or number 6, anything of that sort, and printing it, right? But only if you are not able to do the scanner part. You're not able to do this part. If you're able to do this part, that's the perfect approach to do the solution. Okay. Let me undo that. Okay, so this is straightforward. You took the first integer from the input and named it as number 1. and second as number 2. You created the third variable called sum, and you created the summation of number 1 and number 2, and then you printed it out. Okay, even if you printed out just sum, that's also fine. I made it slightly more generic in order to you to understand the sum of number 1 and number 2 is sum. Next question we had was largest of 3 numbers. So in the same way, you need to take 3 inputs from the user. Okay, number 1, number 2, number 3. And then if you have used math.max function, that's also correct. You don't have to do, I mean, that's not a problem if you use math.max function. Okay, but over here, I just use logical operators to find the maximum of 3 numbers. The first condition is comparing between number 1 and number 2. If number 1 is greater than number 2 and number 1 is also greater than number 3, then number 1 is actually largest. Else, if number 2 is greater than number 1 and number 2 is also greater than number 3, then number 2 is largest, or else the only number left is number 3, which is the largest. Okay, there could be multiple ways to achieve the same. The end goal is you should be getting correct result. That's it. If you are running the problem with 3 different numbers every time, and every time you are getting the largest number as the output, your solution is correct. Okay, there are multiple ways to do the same thing. And also, this is not the ideal way. This is one of the way I suggested. It's not that this is the best way. This is one of the way. That's it. Third question was checking if a number is even or odd. Okay, over here, we did the same thing by getting the number. And then there is one statement in the if condition where we are dividing the number by 2. If the remainder is 0, the number is even, else the number is odd. I think Akshay had a problem in this where he was asking about comparison. Maybe he got confused in the logical operator, which I mentioned in the question. So you can use the arithmetic operation. I think you would need to use an arithmetic operation. Okay, if you have used this approach, that's well and good, or any other approach is also fine, like any other approach. Okay, so it's up to you. The end goal again is to have a correct answer. If that is something you're getting, that's perfectly fine. Fourth question, or I don't know which number question it was, but anyways, comparing of the strings. If a string is the other string, I think that was the question. Let me check again. Where did this go? Okay, let me scroll up. 1, 2, 3, 4th question. Write a program to compare 2 strings and print equal if they are equal. Yeah. So you took 2 inputs from the user, first string and second string, and then you use dot equals to. Either you can use this, or you can also use double equals to sign. In both cases, you will get the required answer. Okay. Converting uppercase, it's as simple as what I discussed with you all. This is something I already discussed. Take an input and then use str.to uppercase. This is the exact function we already discussed. So hopefully you were able to do it. Find string length. Exactly. This is something also I also discussed, which is string length dot length, and you'll be able to do it. Find character position. This is also I discussed with a function of string dot index of. Now, what is happening here? Let's spend some time on this. We took an input as an integer. We took input as a string, and then we took a character input. Which character we want to find the position in, right? Now, look at this line. Int position equals to string dot index of c. Over here, position will have a value equal to at what index character c is present in the string, right? Position will have a value which is equal to index of character c in the string. Now, what if the character c is not present at all in the string? This position will have value equal to -1, and I wanted you all to decode it by yourself. So the folks who have done this question, excellent. If you're able to figure out this part, that if a character is not present in the string, the position will have value of -1. The specific you can print the specified character is not present in the string, or else print at what position it is present by putting the position character in the print statement. All right. Moving on to next one, concatenation of strings, which is very simple. You can either use concat function or you can use the plus sign. Take the input first string, second string, and then concatenate it. Simple calculator. This is an impressive one, but I'm sorry because I did not teach you guys the switch statement. So you can ignore this question for now. I'm not sure why this question came in right here. Okay, calculator question, I think is the second last question. And the last is check Boolean value. Question was, write a program to check if a Boolean value is true or false using an if-else statement. All you have to do is take a Boolean input. This is the line which I wanted you all to do it. Taking a Boolean input by using next Boolean. And depending upon what Boolean value is, compare in the if-else statement and print the Boolean value. Okay. I hope you all have taken this solutions on your local drive and copied the questions as well. For comparing strings, let's check what are the methods you can use. Okay, let's check it together. And the intent of checking this together is two things. I'll also help you how to debug things by yourself. Okay. So Java compares strings, and there is a website called Java Point, which will give you all the methods. So these are the three methods using which you can compare strings. So yes, using compare to method, you can compare strings by using equals, by using double operator, double equals to as an operator, or using equals to. Equals to method is as simple as you saw that right now. Dot equals to, pass the string and initiate the equals to function on the previous string. That is one way. Second way is the equals to operator, which is as simple as s1 double equals to s2. And the third is compare to method. Okay, compare to method will be like this. Compare to and equals to and all these three will return you the Boolean value, true or false. So the answer is yes, you can use that. So in this case, I think since we created two different variables, this is pointing to two different reference memory locations, and that's the reason this is giving it as unequal. The reason is, I'll show you with the help of the example, and thanks for folks who are in the call for correcting that part. Over here, you see S1 and S2 are created, and they both are initiated as Sachin, and then string S3 has been created with a new string Sachin. Okay. Now, if you compare S1 and S2, it will return you true because both refer to same instance. All right. Let me just try this out again. We have while loop, which is based on a condition. Now, while statement basically executes the same block of code till the time the condition is satisfied. Okay. As soon as there is a condition that doesn't hold true anymore, the while condition breaks. Okay. Now, these are the two things which I wanted you to understand before we start on the data structures part. Okay. And
so what is an array? First, let us see what an array is. So what does an array do? It stores certain values. All the values need to be of the same data type. Okay, they can all be integers, they can all be characters, they can all be double, floating point numbers, whatever they are, they need to be of the same type. That's the only condition for a array. Okay, so let's say we have an integer array. So it would look something like this, right? Here we can have values, any value that we like. Okay, they may be sorted, they may be unsorted. Okay, they may have larger values also. So this is what an array looks like. This is what an integer array looks like. So, okay. So how do we declare these arrays, right? So right now we are talking about Java. So in Java, we have this syntax to declare arrays. This is the name of the array. Right now we are taking the name as A. Okay. Here we have the size of the array. So here we have the data type of the array, and here X is the size of the array. This is how we declare an array in Java. Okay. So now let us see how we can insert values into an array. So one interesting thing about arrays is the indices in arrays start from 0. So this is the 0th index. This is the first index. This is second index. This is third index, fourth index, and so on. Okay. So the first number in the array is at the 0 index. This is very crucial when we start coding. You will see that indices are very important to know what is at which index. Okay. So now I'll just share the coding screen and we'll actually implement a few things. So the screen that is visible right now is the IntelliJ screen. Right. So this is the IntelliJ screen. It's a IDE. You may be working on any IDE like VS Code or Code Blocks. There are many IDEs. This is IntelliJ. So let's try to implement a few things on arrays. Okay, firstly, let us declare an array like we just did, array named A. Here we had the size of the array. So we can give it any size that we want. Let's give it a size of 10. So what we have forgotten is this bracket. Right. So if you code on an IDE, it will help you code as well. If you make an error, if you make a mistake, it will highlight that part. And let's say we forgot this semicolon and we run our code. So it will tell us that we have forgotten the semicolon. So this way, IDEs will help us out. Let us now see how to insert values into an array. So we can do it one by one using indices. So here, if you want to put some value into 0th index, we simply put, let's say 5. So 5 gets inserted into this index. Now, if you want to put something in index 1, this is how we will do it. Index 2. Let's make a smaller array. Let's make it of size 3. So an array of size 3 will have 3 indices, 0, 1, and 2. Okay. So let us now try to print something. Let's print A of 1. So let us run this code and see that this indeed is our output. So you can see 2 has come out as the output. So very good. So on index 1, we have 2. This is another way to declare an array, right? We don't want this. We want a static array. We already know what the elements will be. So let's just put some elements in. So many times what happens is we do not know the elements that you want to put into the array, and we do not even know the size of the array that we want. Okay. If we take a very large array in every case, let's say we take a array of size 100 in every case, and the input size is only of 10 integers, then we are wasting 90 space of 90 integers, right? So we don't want that. So we can size the array dynamically as well. So if we do something like this and we take an integer n, so whatever will be the value of this integer n, that will be the size of the array. Why? Because we have put n as the size of the array. So now the size of the array would be 10. So when we are filling our array, let's take the size of 3 only. So we have seen one way of filling our array. We can individually take elements on each index. So on 0th index, like we took 12. On first, we can take 10. On second, we can take 20. Okay. So this would be very lengthy if our array size is long. If we have a very long array, let's say of size 100. So writing the array like this would, like inserting the elements in this manner would become a very tedious process. So we don't want to do that. We want to make our dynamic array, and also we want the user to input the values into our array. What do we do in that case? Let's say we have a small array of size 5. Okay. Now we can use a for loop to insert the elements into the array. Now we'll use this for loop to insert values into our array. Let us see how we can do that. Okay. Let's type for int I equal to 0, I less than. So there is a keyword that we can use to find the length of an array. Okay. So what is that keyword? I'll just show you. It is length. So what does a dot length return? It returns the length of that particular array. So in this case, it will return 5. So before actually moving forward, let us see that keyword in action. So we'll just print the size of the array. Okay. So the name of the array is a dot length. So let us try to run this and see if we are correct or not. So you can see the output is 5. So we have seen the length keyword in action. What it does is it gives the length of the particular array. Now we have to input the numbers one by one. So you all know about the scanner class. We have to make an object of the scanner class. Okay. So scanner class is something that we use to take input from the user. Okay. So firstly, we create an object of the scanner class, and then we call different functions to take different types of inputs. So we'll cover that moving forward. Right now, it is enough to understand that we'll take input from the user using this scanner class object. So from here, what do we do is, so initially we were giving each value one by one, a of 0, a of 1, a of 2. Now what we'll do is we'll put a of I. This will be equal to sc dot next 8. So what happens is this function takes the integer input from the user, and we are putting that input into a array at index I. Okay, this is what this particular line is doing. How many times are we doing it? We are doing it from 0 to length minus 1. So from 0 to 4, it is 5 times, right? So here we are doing it 5 times for 0th index, for first index, second, third, and fourth index. So every time it will take an index, an integer from the user and put it at the corresponding index. Okay. So at the bottom, let us try to print a of, let's say 3. Okay. Let's run this. So now you can see the code is waiting for our input. If we give the input 1, 2, 3, 4, 5. Okay. So only 4 will be printed on the screen. Good. So arrays is a very hot topic, and a lot of interviews you will get questions from arrays. So let us now try to solve a few basic questions from arrays. So moving forward, the question that we'll see is finding the largest element, or let us first see sum of all elements in an array. Okay. Question. Sum of all elements in an array. So for this, firstly, we are taking a few inputs from the user. The first input is going to be size of the array. Secondly, we'll take elements of the array. And what will be the output? Sum of all elements. Okay, so let us now see how we'll do this. So like we just saw, we can create a dynamic size array, right, of size n, and we can take that n from the user. So let us start coding right from scratch. Firstly, we'll create a scanner class object. Okay. Now we'll declare an integer n and take a user input. Okay, so n is the size of the array. So we have taken the user input of size of array into n, and now that number is inside n. So n is our size of the array. Now we'll declare an array A of size capital N. So is it clear? We have declared a array of size n, and n is given by the user. Okay. Now what we'll do is we'll take the input into the array. So for that, we were using the for loop. Again, we'll use the same for loop. Again, we'll use the length keyword and I plus plus. Okay. So now we'll fill the array with these values that the user is giving. User will now give n values and we'll fill them in the array A. So A of I is now equal to sc dot next int. So now we have taken the number n and n different inputs from user, and we have put that into our array. Is this much clear to everyone? Type a yes or no if this much is clear. What we have done till now for this particular code. So now what we have to do is we have to traverse this array and add up all the elements. So we'll take another integer variable. We'll initialize that with 0. Okay. Now we'll again use a for loop. Again, traverse the array A, and in sum, we'll just add all the elements one by one. Okay. So in this loop, what is happening is we are traversing through the array, and one by one, we are adding all the elements into this variable called sum. And at the end, we'll just simply print the sum is sum, variable sum. Okay. Okay, so we have made a spelling mistake here. We'll just quickly correct it. Okay, so now it is waiting for our input. The first input is going to be the size of the array. Let me put 5 here. Let me just make it a bit larger. Now I have to put the 5 different values, which will be the elements of the array. Let me just put in 1, 2, 3, 4, 5. Now when I press enter, okay, so let us now run it. Let's press enter. So it's showing the sum is 15. You can see that we have forgotten to put a space here, so it's not looking very nice. We'll just put a space here. Okay. So we'll move on to another code. This time we'll find the largest element in the array. Now we'll see the next question. All right. So the question is, largest element in an array. Okay, so we have to find the largest element in an array. So again, we'll have the same inputs. Firstly would be the size of the array. Second input is going to be the elements of the array. And then our output will be largest element. Okay, so how will we do it? So let's say our array looks something like this. So it's not a sorted array, it's just a general array, random numbers. Okay, 1, we can have 12 here, then we can have 2, then we can have 28, and we can have 30. Okay, let's add a few more numbers to make it more interesting. 3 and 5 at the end. The largest element would be 30. Good. So let us see how we can solve this. Okay, so firstly what we'll do is we'll make an assumption. We'll take an integer largest. Okay, we'll take an integer variable largest and we'll make an assumption that the first element is the largest element. So we'll put set its value to the first element, that is 1, or you can say a of 0. Okay, now what we'll do is we'll start a loop from the second element and we'll go right up to the last element. At each step, we will compare largest with this current element. And if this current element is greater than the largest, then we'll change the value of largest to this new value. So is 12 greater than 1? So is 12 greater than 1? Yes or no, everyone? Is 12 greater than 1? Yes? Good. So because 12 is greater than 1, we'll change the value of largest to 12. Then we'll move the pointer forward. We'll get here. Now is 2 greater than 12? Yes or no? Is 2 greater than 12? No. So 2 is not greater than 12. 2 is indeed smaller than 12. So we won't change the value of largest. We'll move to the next element. Is 28 greater than 12? So 28 is larger than 12. So we'll change the value to, let's say, 28. Then we move the pointer forward. Is 30 greater than 28? Yes or no? 30 greater than 28? Yes. Very good. So we'll change the value of largest to 30. Now we'll move the pointer forward. Is 3 greater than 30? No. Very good. Very good. So 3 is not greater than 30. So we won't change the value of largest. We'll move to 5. Is 5 greater than 30? No. Good. Very good. So at the end, the value of largest comes out to be 30. And this is what we'll print on the screen. So we wanted to print 30 and the output is 30. So is the approach clear? Type a yes or no if the approach is clear or not. Yeah, we'll just see how to code it. Don't worry. Approach should be clear. So we'll just delete this part. So the initial part remains the same. Here we are creating an object of the scanner class. Here we are taking the size of the array as the input in integer n. Here we are declaring an array of size n. And through this loop, we are filling all the values in the array A. Okay. So through the line number 4, this line that I have highlighted, we are creating an object of the scanner class. Through this line, we are taking the input an integer that is the size of the array. Through this line, we are creating an array of size n. And through this for loop, we are inserting all the values, all the elements of the array into the array A, right? One by one. Emmanuel, is it clear now? Yes, very good. Very good. So we'll move forward now. What we need to do is, firstly, we had the assumption, right? So we'll make the element largest, the variable largest, and we'll put the element at 0th index into the largest variable, right? This is the assumption that we had. Now we'll use another for loop. We now have to loop through the array. So we'll use a for loop here. So int I equal to 1 because we don't have to check against the first element, right? We started with the second element, the element which was at index 1. So here we are starting from I equal to 1. Then what we'll do is we'll go till a dot length I plus plus. So every time, like while we are looping through the array, during each iteration, we'll just check if uh, you are all familiar with if else, right? Conditional statements. Okay, Mushadul, you are familiar. Mona Lisa is familiar. Everyone else, Manuel, good. Okay, so you guys are familiar with if else. Good. So here we'll check if the largest number that we have assumed is smaller than a of I. If the new number is greater than largest, what do? We change the value of largest to a of I. As simple as that. Okay. So after this loop is over, like we saw, largest will have the greatest element in it. So we simply have to print it out.
Let's have a quick quiz question, guys. And the question is, which of the following data structure find its use in recursion? And your options are stack, queue, dequeue, or strings. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ENICT IIT Guwahati. The course link of which is given in the description below. Now, let's continue with the session.
Okay. So let us try to run this. So we'll put in 5 elements, 12, 43, 56, 2, 4, and 8. So what would be the output when I press enter? Everyone type it in. What would be the output of the code? Okay, Emmanuel is saying 56, Suryabrata 56. Very good. Mona Lisa 56. Good. Akshay, very good. Very good. Largest element is 56. Mushidul. Good. So I'll just press enter. So you see the output is largest element is 56. So let us understand this new question that we have. That is second largest element. Okay, second largest element. So here again we'll have the same inputs. The first will be size of the array. Second will be elements of the array. Okay, and our output will be second largest element. All right. So how do we do this? How do we solve this question? So it's a bit tricky. So everyone, please listen very carefully what we'll do here. Okay. It's a bit tricky. So let's first take a sample array. Okay. Yeah. So this is what our array looks like. What should be the output? Which is the second largest element? Everyone type it in the chat. 12. Okay. Very good. Good, good, good. Okay. So very good, Murshidul. So the output should be 12. Okay, because that is the second largest element in the array. The largest is a 23, second is 12. So how do we solve this particular question? Let us see. So here we'll take two integer variables. The first integer variable will be largest. The other will be second largest, or let's just call it second. Okay. So initially what we'll do is we'll initialize them with integer dot min value. Okay. We'll initialize them with integer dot min value. Okay, so it's nothing much. It just gives the minimum integer value that is possible. Minimum integer value that is possible. It is we are putting that into largest. And in the second one also, we are doing the same thing. Okay. So we have initialized both of them with the minimum value possible, minimum possible value. Okay. Now what we'll do is we'll traverse the array. Okay. Let's say our pointer is here, 1. So what is the case here? 1 is greater than the largest value, right? So we have 3 cases. We mainly have 3 cases here. Let's study them case by case. Case, let's say 1. Okay. So what is the first case? A of I is greater than the largest value. Okay. So basically it is greater than the largest value. So what do we do in this case? What we do is we copy the largest value in the second largest value. And this new value is put into largest. Okay, let's see why we have done this. Let's say the largest value is 5, second largest value is 4, and the new value is 6. So 5 now becomes the second largest value, and 6 becomes the largest value. Right? I'll explain using the same example. Let's say the largest value is 5, second largest value is 6. The new value that we have seen is, the second largest value is 4. The new value that we see is 6. So what should be the ideal answer now? Largest value should become 6. Second largest value should be 5, right? So here what we are doing is we are copying this value, largest value into second. Through this line, we are copying 5 in S, in second, right? So here 4 becomes 5. Next thing what we are doing is we are copying the largest value, A of I into largest. So we are copying 6 here. So this becomes 6. So this transforms to this. Largest becomes 6, second largest becomes 5. Is it clear now? Now we have a case 2 with us. Okay, so what is case 2? A of I is less than largest. But at the same time, A of I is greater than second largest. For example, largest is 5, second largest is 3, and the new number that we see is 4. So after solving this, the condition should be largest is again 5. Of all these 3 numbers, 5, 3, and 4, 5 is the largest. Second largest in this 3 numbers is 4. So this particular scenario should transform to this scenario. So here what we do is we do not change the largest value because it stays the same. It was 5, and after this thing also it is 5. So we just change the second largest value. So we change the second equal to A of I. So this 4 is changed by, this 3 is changed by 4. And this scenario changed to this. Is this clear? This case also clear? First, did we compare 3 of the numbers for largest, then to second largest value from remaining 2 numbers? Case 2 is like second. Yes, case 2, Emmanuel, for case 2 you are correct, and for case 1 also you are correct. Okay. So what we did was, whatever was in the largest, we compared it to A of I. If it is greater than the largest number as well, then we did the case 1 thing. Now if A of I is between largest and second largest, we are doing the case 2 thing. Now there's another case here, case 3. Okay, so case 3 is A of I is less than second largest element. So it will look something like this. Largest is 5, second largest is 4. This new element is 3. So what, after doing all the calculations, what should happen is, largest among 3 is 5. Second largest among the 3 of these is still 4. So nothing has to be done. Okay, we are carrying forward the old value only. 5 remains 5, 4 remains 4. So in case 3, nothing has to be done. Okay, so these 3 are the cases that we have to deal with. That's it. So again, we'll just keep the starting lines with us. We don't want to write them again and again. So like we saw, what will be the input from the user? An integer n. That will be the size of the array. And then we'll declare an array of size n. After that, we'll use a for loop to insert all the elements into the array that we have created, the array A. Now we have to find the second largest element in the array. So we'll create 2 integers here, largest and second. We'll initialize them with integer dot minimum value. Okay. We'll initialize the largest as well with the same thing. Okay. So we have initialized them correspondingly. Now we'll traverse through the array. Okay, now we'll use this particular for loop to traverse through the array. Now for every index, we have to check the 3 cases that we just created. The first case, A of I is greater than largest. What we do is, firstly, we'll make the second largest equal to the largest element. Okay, sorry, largest element. And then we'll make the largest element equal to this new element that we had. Is it clear? Let's name it second largest only, so that it's a bit more clear. All right. So moving forward, let's take care of the second case now. If this case is false, that means A of I is smaller than largest, right? And if this case is true, it means A of I is greater than second largest. So we don't have to put this condition. Because this condition we already know is true. Why? Because we haven't got inside this if, we have come into this else if. So if this is false, automatically this becomes true. Okay, so we do not have to put this particular condition here. We are in case 2 right now. So now we are left with the third case, else. So in if else, else is optional. We don't have to compulsorily give it. So we'll just delete this. We did nothing in the third case. So after this thing is over, after we come out of this for loop, let us just print system.out.print second largest element equal to second largest. We'll quickly move on to 2D arrays. Okay, they are very similar to 1D arrays. It is just a collection of 1D arrays. We'll just see how we can do similar things on the 2D array as well. Okay. So firstly, we will see how to declare a 2D array. So it is pretty much the same thing as 1D array. So what is a 2D array? So this is how we declare this. If you want an integer 2D array, we'll give it a name. We'll put two boxes in front of it this time. In 1D array, we were putting one box. In 2D array, we'll put two boxes or two square braces, right? Two sets of square braces. Then new, then int. Then here we used to put size of the 1D array. Now we'll put number of rows, number of columns. So this is how we declare a 2D array. Okay? Similar to 1D array, nothing fancy. So we can also, like we were using a static array, right? We were declaring static arrays, static 1D arrays like this. We can also declare static 2D arrays. Let's call this one B. This is how you do it. Okay. So let's see what we have created. So B is nothing but a collection of 1D arrays. Here we have two 1D arrays. So B would look something like this. This is the 0th index of B, B of 0. This is one array, B of 1. This is the second 1D array that we have. Okay. So how do we access these different numbers inside a 2D array? So we use two indices, that is row number and column number. So let's say we want number B0, 0. Can anyone guess what will be at this index? B00? 2. Okay. 2, 2 and 1. Okay. All right. So I'll just quickly explain. So B00 means 0th row and 0th column. So 0th row is this one, right? This is B0. And inside this 1D array, 0 index. So this will be just 2. It won't be 2 comma 1, it will be just 2 because it is B00. 0th row, 0th column. So B0 we have seen. This is the 1D array that we are calling B0. So B0, 0th index is 2. All right. So this B array looks something like this. B array basically looks like this. So we have a 2D array, as I told you, it is nothing but a collection of 1D arrays. So B0 basically is this full array, this complete 1D array. 2, 3, and 4. And B1 is the second array. 1, 2, and 12. So B00 just means, firstly, we go to the B0 1D array. So this is the 1D array that we are talking about, this one, and the element at the 0th index. In this, we have these indices. So element at the 0 index would be 2. Okay, so these are called 2D arrays. Now these 2D arrays need not have same number of elements in each 1D array. I'll just explain to you what I'm saying. So right now we have 3 elements in each of the 1D array present inside B. They may be different number of elements. I'll just show you what is the other thing that we can do. So we can create a 2D array like this also. Let's call it C. And this is equal to, let's say, 1, 2, 3, 4 and 5 and 6. Okay. So now what happens is C0 is a 1D array. 1, 2, 3. C1 is a 1D array that looks like this. And C2 is a 1D array which looks like this. This will be 3. Very good. So you all have understood the concept of 2D arrays. Now we'll try to solve a few questions based on 2D arrays. Firstly, we'll see how to take input, right, from the user. Then we'll solve a few questions. All right, let's delete this code. Okay. So we have made a object of the scanner class. Let's delete it for now. So here we go. So the first thing we'll do it, we'll declare an array, a 2D array. Let's name it P. Let's give some values. 2, 3, 4, 5, 6, 7, 1, and 2. Okay. Now let us traverse this array and print all the elements that are present in this particular array. So let's see how we can do that. So we'll use a for loop here. Int I equal to 0, I less than b dot length I plus plus. Okay. Then we'll use another for loop. So here we'll use a nested for loop to traverse this particular 2D array. Let's see how we can do that. We'll use another for loop. Int j is equal to 0, j is less than. So here we'll go till whatever is the length of b of I and j plus plus. I'll quickly explain to you what we are doing. So firstly, length of b will give me 3. That is, there are 3 different 1D arrays inside this 2D array. Okay. So here we are traversing from 0 to 2. Now inside this, for that particular 1D array, let's say I is equal to 0. So what is the length of the 0th 1D array inside B? It is 3. So it will give 3 in that case. For this case, when I is equal to 1, what is the length of the second 1D array inside B? That is also 3. When I is equal to 2, what will this give me? Everyone try to answer in chat. When I is equal to 2, what will be the output of bi dot length when I is equal to 2? So this is how we are traversing our 2D array. Now inside this, what we'll do is we'll simply print. What we will print? B of I, j. Right? We'll print this, we'll leave a gap here. And after every row is printed, one complete row is printed through this for loop, we'll give a next line character. So you all know what a println is. It just gives you a next line. So let us try to run this code. So you can see that our matrix has been printed properly. 2, 3, 4, 5, 6, 7, and 1, 2. Tell me what is the output for, let's say 1, 2, 7. And we can see that it is 7. Okay, next, what is the output for, let's say 3, 0. Okay, so it is 10. Okay, good. So I hope 2D arrays are clear. Now we'll go for a question. Firstly, I'll explain the question, then we'll solve it. So pay attention, everyone. The question is sum of all elements. Like we did in 1D array, we'll do the same thing in 2D array. sum of all elements in 2D array. So how do we do it? Let's take a sample 2D array. So as you already saw, the number of elements in different rows can be different, right? So in this row, we have only 3 elements. In this row, we have 4 elements. In this row, we have 4 elements. So what we'll do is we'll initialize a variable called sum with value 0. Okay. So one by one, we'll traverse each of these elements and we'll keep adding it to sum. So let's say we start with this. So here we add 2 to sum. So it becomes 0 plus 2. Then we come here, it becomes 2 plus 3. Then you go here, it becomes 2 plus 3 plus 4. Then here it becomes 2 plus 3 plus 4 plus 5. Then we come to the next row and we do the same thing. Plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, and then finally plus 7. Okay. So 7 plus 3 is 10, 20, 30, 8. And 4, 42. Okay. So we already have a sample 2D array with us. Let us stick to it, right? No use changing it. So we'll just follow this particular 2D array and try to sum it. So as you saw, we'll make a variable sum and we'll initialize it to 0. Then we'll traverse through the 2D array. How do we do it? We have already seen it while printing. So I equal to 0, I less than b dot length, I plus plus, nested loop, j equal to 0, j less than b of I dot length, j plus plus. Inside what we do is we add these numbers into some variable b of I, j, right? At the end, we just print this out. Okay, so let's run this. So we have made a small mistake. Let's run it again. And the sum comes out to be 79. All right. So we have a 2D array. So now we are talking only about square matrices. Square matrices have same number of rows and same number of columns, right? Number of columns is equal to number of rows. That is a square matrix. So let's create a sample square matrix. Okay, so this is a 3 by 3 square matrix. All right. So what we want to do is we want to sum the diagonal elements. Diagonal elements, right? There are 2 diagonals, right? One diagonal consists of these 3 elements. The other diagonal consists of these 3 elements. So when we are talking about matrices, the first diagonal, the red one, is called a diagonal and the green one is called the anti-diagonal. So basically, this is what we called a diagonal and This is what we called an anti-diagonal. Okay. So the elements that we're talking about are 2, 6, and 4. And you want the sum of these three elements. So it's 2 plus 6 plus 4. So I'll just take, so there are two main methods that we can follow to code such a problem. One second. Let's discuss both the approaches, because it is important that we understand all the possible approaches, right? So the first approach is pretty straightforward. So like we were just, we take a sum variable like we just did, initialize it to 0. Okay. Then what do? We use the for loop to traverse the array like we were just doing. Int I equal to, let's call the array A. Okay. 0, I less than A dot length, finally I plus plus. Cool. Then we had another for loop, int j equal to 0, j less than A of I dot length, then j plus plus. Right? This is what we were all doing till now to traverse the 2D array. Type yes if you guys remember that this is the code to traverse the 2D array that we were using till now. Yes. So there is one pattern that we have to see, that here row number is equal to column number. 0, 0, 1, 1, 2, 2. Row number is equal to column number. Then we are calling this a diagonal element. In no other case, row number will be equal to column number. So now what we'll do is, we'll put a if condition inside it. Okay, we'll put a if else. So while we are traversing the 2D array, we'll just use a if right here. Okay, so if I equal to j, right? If I and j are equal, then it is a diagonal element. What we need to do is we need to make sum plus equal to a of I. We close the if, we close the first for loop, we close the second for loop. Right? This gives us the row number. I gives us the row number, j gives us the column number. When row number and column number are same, we are using, sorry, not a of I made a mistake here, a of I, j. So this is one method or one way of solving such a question. There is also another way. Let us see what that other way is. Okay. So now we are traversing. We'll use only a single for loop now. We'll create a sum variable, initialize it to 0 for int I equal to 0. I is less than A dot length and I plus plus, right? Here what we can do is sum plus equal to A of I. So this is the matrix that we have. Let's put whatever numbers we want here. So this particular loop will tell you how many 1D arrays. This will tell you how many 1D arrays are inside the 2D array. So this will give us 3, right? There are 3 1D arrays inside this 2D array. This will go from 0 to 2. 0 to 2. So when I is 0, we will sum A, we will add to sum A00. So what is A00? A00. Then I becomes 1. We add to sum A11. What is A11? This number. Then I becomes 2. We add to sum A22. What is A22? This number, right? So let us try to code both the ways, right? Let us try to solve this question in both the possible ways. So first of all, what we'll do is we'll take the 2D array, like a square 2D array. So int, let's name it array, ARR. Okay. We'll give it simple values, nothing. Let's take a 3 by 3 array so that we don't have to type a lot of numbers. 6, 7, 8, and 9. Okay. So we have a 3 by 3 2D array. It's a square matrix. Now we want the sum of the diagonal elements. Okay. Let us make the sum of the diagonal elements. So the first method was the unique method we are using as a variable sum. The first method was we were traversing the entire 2D array. So how do we do that? Okay. So we are using these two loops, which are nested loops, to traverse the 2D array. We are giving a condition if I is equal to j, sum plus equal to array of I, j. And this gives us the sum of the complete array. Oh, sorry, of the diagonal elements of the array. At the end, after the two loops are over, we'll simply print the sum. 1, 2, 3, 4, 5, 6, 7, 8, and 9. What would be the output of this particular code? So basically the diagonal elements would be 1, 5, and 9. 1 plus 5 is 6, 6 plus 9 is 15. Very good. Cool. Let's run this and see what our output is. So sum of diagonal elements is 15. Okay. Then we saw the other method to do it, right? We had another way of doing it. Let's try that. Now, one second. Yeah. Okay. So the other method that we used to solve this particular question was very simple. We use only one for loop this time. I is equal to 0. I is less than array dot length I plus plus. Now after this, we simply add to our sum. What do we add here? I, right? Let's run this and see if we get the same answer or not. So again, we are getting the same answer, that is 15. So these are the two approaches of solving this particular question. So A of 0, 0 is 2, B of 0, 0 is 11, 11 plus 2 is 13. This is 13. So now we have 3 plus 10, that is 13. Okay. Again, this would be 13. What would come here? How did we calculate it? Just keep writing the formula here. So in this blank, we'll have a 12. Why? 4 plus 8 is 12. I'll just quickly write a 12 here, and below it, I'll write the formula for it. Moving forward, what would come here? 2. Next, what will come in the next place? 1, 1, 4. So it is 2 and 2. It is 4. What would come in the next place? 1, 2 will be 9. Why? 6 plus 3 is 9. What would come in the next place? 2, 0, 7 and 4, 11. So it is 7 plus 4, 11. 2, comma 1, 13. Very good. 8 plus 5 is 13. Awesome. Next, 9 and 6, sorry, 2, comma 2, it is 15. Right? So one thing that you have to notice is, okay, let's say we have these two matrices. Why can we add these two matrices? What is the dimension of this matrix? How many rows are there? 2 rows. So 2, how many columns are there? 3. Very good. So 2 cross 3. For this also, it is 2 cross 3. Right? So we can see that number of rows are equal and number of columns are also equal. So number of rows are 2 in both of them. Number of columns is 3 in both of them. Let us see what would be the output of this particular matrix quickly. So the first thing would be 1 plus 1, 2. 2 plus 2, 4. 3 plus 3, 6. 4 plus 4, 8. 5 plus 5, 10. 6 plus 6, 12. Okay. So let's clear all of this. So first of all, we'll see a simpler version of the question. We'll take the matrices ourselves, okay? And then what we'll do is we'll ask the user to give us the dimension of the matrix and the complete matrices after that, okay? So we'll go step by step. Firstly, we'll do the simple thing, then we'll do the difficult thing. Okay. Let's take two arrays or matrices that we can add. Okay. Let's take another matrix. Let's call it matrix 2 or mat 2. All right. So now we want to add these two matrices. Okay. So now we know how to traverse a matrix, and these two matrices have the same size, same number of rows and same number of columns as well. So let us try to traverse these. Okay. So now we are traversing using the dimensions of matrix 1. But that is okay because the dimensions of matrix 1 and matrix 2 are equal, like they are same, right? 2 by 3, 2 rows, 3 columns. So now what we'll do is we'll create another matrix, an empty matrix. Let's say we create a matrix 3. Okay. We'll put all the zeros in this one. So in matrix 3, I row j column would be equal to matrix 1, I row j column plus matrix 2, I row j column, right? Then we'll simply print our matrix 3. For that, we'll use the same type of loop. we'll print. We'll leave a gap after each element. And after printing a complete row, we'll again print a blank line. Like to go to the next line, we'll go to the next line after this. So now let us try to run this code. So we can see that we have obtained the output on the screen, right? So like this, we can add two matrices. Now we'll add a little bit of complication in this. We saw how we can declare a dynamic 1D array, right? This is how we were doing it. Of dynamic size, basically. Yeah, we used to have a n. We used to take input from the user, right? And we used to create a user defined size array like this. It's the same thing we can do with 2D matrices also. Let us see how we can do that. Okay, let's clear all of this. So now we want the user to give us the number of rows of first matrix, number of columns of first matrix, then elements of the first matrix. After that, number of rows of the second matrix, number of columns of the second matrix, then the elements of the second matrix. After that, we will decide whether these two matrices can be added or not. If they can be added, we will add them. If they cannot be added, we'll reflect it to the user that these arrays or these matrices will not be added. Okay, let's see how we'll go about it. Okay, see, look at it very carefully because it's a bit lengthy and a bit difficult as well. Okay, so be very careful. And so let's declare row R1 for number of rows of first matrix, C1 number of columns of first matrix, R2 number of rows of second matrix, C2 number of columns of second matrix. Now we'll make an object of scanner class. Okay. Now after this, let us take the input from the user for row 1 and column 1. So row 1, sorry, R1 and C1. Now we have row 1 and column 1. We create a 2D array of size R1 cross C1. Let's see how we'll do that. We'll do it in a similar fashion like a 1D array. Okay. So it is a 2D matrix of size R1 cross C1. Okay. Now we'll take R1 into C1 inputs from the user. That is for the different locations or the elements of this particular matrix. Okay. For that, we'll again go for the for loop. I is less than 1 dot length plus then for j equal to 0, j is less than mat1 I dot length, then j plus plus. Now for mat1 I, j will take the input. Now we'll do a similar thing for the second array as well. So let us now take the input for R2 and C2 also. So R2 and C2. Okay. So we have taken input for R2 and C2. Now again, we'll create a new matrix. Matrix 2. with R2, C2. So now this second matrix has dimension R2 cross C2. Now again, we'll take the input from the user, right? R2 into C2 inputs from the user. Okay. So int j equal to 0, j less than matrix 2, I dot length, j plus plus. And inside here, what we'll do is we'll take the inputs. So matrix 2, I, comma j equal to sc dot next state. Okay. So now we have created the two matrices that we want to add. Now we will have to check whether or not we can add them or whether or not we can add them. Okay. Let us now check that. So now so what do we type here? If we want to check if we can add them or not. What do I type inside if? Any guesses? So here I want to check if I can add them or not. R1 equal to R2. Correct. So we want to check if the number of rows of first matrix is equal to number of rows of second matrix, and number of columns of first matrix and number of columns of second matrix are equal or not. So R1 equal to R2 and C1 equal to C2. Sorry, yeah. Okay. So if R1 and R2 are equal and C1 and C2 are equal, what do we want to do? We want to actually add these two matrices. Inside else, like if this is not true, if they are not equal, what do? We simply print. What do we print? These matrices cannot be added. Okay? These matrices cannot be added. Put out here. Okay. So inside this if we actually want to add these two matrices. So we create a third matrix, okay, where we want to put the sum of these two matrices. So this would be of size R1 cross C1. So we can also write R2 C2, okay, because R1 and R2 are equal and C1 and C2 are also equal, okay. All right. So we have declared a new matrix 3, where we will put the sum. Now we go for loop int I equal to 0, I less than matrix 3 dot length and I plus plus. Then again another for loop int j is equal to 0. J is less than matrix 3 I dot length, then j plus plus. Okay. Now matrix 3 I j is equal to matrix 1 I j plus matrix 2 I j. Right. So we have made the addition. Okay. So after this for loop, we have basically got the matrix ready. Matrix 3 now holds the sum of matrix 1 and matrix 2. Now we will simply display it. Let us try to display it now. We go for int I equal to 0, I less than matrix 3 dot length I plus plus for j equal to 0, j less than matrix 3 I dot length j plus plus And here we'll simply print it out. Okay. And after each row, we'll give a next line. All right. So we have got our code ready. Now we just need to test it out. So let's start testing the code. Okay, so let's test it now. So let's give a matrix of 2 cross 2. Okay, now we have to give 4 numbers 1, 2, 3, and 4. Again, we have to give a second matrix. So let's give a wrong matrix now. Let's give a matrix of 2 cross 3. Now we have to give 6 numbers. So these matrices cannot be added, right? This is what we wanted as the output because the number of columns in the two matrices is not equal, right? We'll again test it. This time, let us make the number of rows unequal. 2, 3 cross 2, 1, 2, 3, 4, 5, 6. Then let's say 2 cross 2, 1, 2, 3, and 4. So again, these matrices cannot be added because the number of rows is different in both of them. So we have understood both of these cases. So now let us actually give two matrices which can be added. So 2 cross 2, 1, 2, 3, 4 is a bit larger. And 2 cross 2, 5, 6, 7, and 8. Right? So here we have the final matrix, that is 6, 8, 10, and 12. So the next question is one of the most difficult question that we do. So we have two matrices, 1, 2, 3, 4. And let's say 5, 6, 7, 8. So what we do is, in the first matrix, we go row wise. In the second matrix, we go column wise. So 1 into 5 plus 2 into 7. 1 into 5 plus 2 into 7. This will come here. So this is equal to 5 plus 14. That is 19. Okay. So 19 comes here. So again, we'll go row wise from the first matrix and column wise from the second matrix. So it is 1 into 6, 1 into 6 plus 2 into 8. So it is 6 plus 16. 6 plus 16 is 22. So 22 goes there. Okay. What will come here? 3 into 5 plus 4 into 7. Okay. So this is 3 into 5 plus 4 into 7. So this is 15 plus this is 28. So this is equal to 43. So 43 comes here. This is 3 into 6 plus 4 into 8. 3 into 6 is 18. 3 into 6 is 18. 4 into 8 is 32. So the sum is 50. All right, let me explain it once again. So from the first matrix, you go row wise. From the second one, you go column wise. So the resultant matrix is, let's say it is R1 into, sorry, let me just write it a bit more clearly. R1 into C1. This is R2 into C2. The resultant matrix is always R1 into C2. And for these two matrices to be able to, so that we are able to multiply them, R1 must be equal to C2.
Let's have a quick quiz question, guys, and the question is maximum number of swaps that can be performed in selection sort algorithm. Your options are n-1, 1, n, or n-2. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ENICT IIT Guwahati. The course link of which is given in the description below. Now let's continue with the session.
I'll just explain it a little bit. I'll explain it a little bit later. So this is the dimension of the matrix, R1 into C2. So what is R1? Number of rows in the first matrix. R1 is equal to 2. Right? Very good. R1 is equal to 2. Number of columns in the second matrix, 2. So it is 2 cross 2. Very good. So the first element that we'll get here is going to be, we go row wise in this and column wise in this. 1 into 1, 2 into 3, 3 into 5. Okay. So 1 into 1, 2 into 3, 3 into 5. So what is the sum here? 1 plus 6 plus 15, 16 plus 6, 22. Okay, let us see what will come here. So 1 into 2 plus 2 into 4 plus 3 into 6. So this is 2 plus 8 plus 18. So this is 28. Okay, very good. Akshay, Moshedul, Mona Lisa, very good. Next, one second, let me just write 28 here, 49. No. So it is 4 into 1, 5 into 3, 6 into 5. Four into 1, 5 into 3, and 6 into 5. So it is 4 plus 15 plus 30. So it is 49. Very good. Very good, guys. You guys are learning very quickly. Now for the last number, it will come here. $64. 64. All right, it's 64. So this is how we multiply two matrices. So now you will all remember how to multiply two matrices. Okay, so one thing that you must have noticed is we are going row wise in this and column wise in this, right? So how do we code this? It's a bit tricky. So be very attentive while we code this. Now you know what to code. Let us see how to code this, how we can go about coding such a typical thing. So let us take the two matrices. One second. All right, so let us just delete the old code. All right. So first of all, we need two matrices. Let us make two matrices. So we are taking mat 1 or matrix 1. Let's give it some values 1, 2, 3, and 4, 5, and 6, and we're done. Let's create another matrix, matrix 2 or mat2. Let's give it some other values. So it's 2, 4, and let's say 1, and 4, 8, and 9. Okay. So these both of them are 2 cross 3 matrices, 2 rows and 3 columns. Okay. So can we multiply these two matrices together or not? Question number 1. So what did we see? What rule did we see to be able to multiply two matrices? We saw a rule. What was the rule? Okay, we'll just code in the rule, don't worry. For now, let's take a square matrix to make things a bit easier. Okay. So now we can definitely multiply two square matrices together. Yeah, R1 equal to C2. Correct. Good. Okay. So we have these two square matrices, and now we will try to multiply them together. Okay. So now we'll take a resultant matrix. It is RES. Let us fill it with zeros. Okay. So now we have the resultant matrix. Let us now try to multiply these two matrices and put the result in resultant matrix. So we'll take three integers for this, I, j, and k. Okay. So let's start the for loop with I equal to 0, I less than. So number of rows, let's take a few more integers. Okay. So R1, R2, C1, C2. So R1 right now is equal to 3. This is equal to 3. This is also equal to 3. And this is also equal to 3. Okay. So we'll make a generic code which will run in all the cases. Okay. Not just for 3, 3. I just wanted to make that clear. That is why we have taken these four new integers R1, R2, C1, and C2. So R1 and I plus plus. So we are starting from 0. We are going till row, number of rows on the first matrix. Like we saw while we were multiplying. I'll just complete this for loop. It's a nested for loop and then explain it. Okay, it's a bit tricky to understand. J would be less than C2 and J plus plus. So inside our result Ij, we'll initialize it with 0. Then we'll use another for loop where k will be 0, k would be less than R2 and k plus plus. Now inside this particular loop, we'll keep adding to the resultant. Like we were doing, we were multiplying two numbers and adding it into the result, right? So here we'll multiply matrix 1, I and k with matrix 2, k and j. Okay. So if you are not being able to understand, no problem, I'll just explain it. Don't worry. So after this for loop is over, we have added our results into the particular block that we wanted to. So now we'll take a sample, okay? We'll take a small sample and try run this thing. Instead of 3, because 3 is a very large number, it will take a lot of time to try run. Let's take 2 cross 2. Right, so it's much easier that way. Okay, so we have a 2 cross 2 matrix. Let us make a comment section over here. Let us put the matrices 1, 2, 4, and 5. 2, 4, 4, and 8. Okay. And these are the two things that you want to multiply. So for the first 0, 0 location, it should be 1 cross 2, 1 into 2 plus 2 into 4, right? 1 into 4 plus 2 into 8. For 0, 1 location, 0th row, first column. Yes, very good. Very good. All right, so I need you all to cross check what I'm doing, okay? So for this location, we have 4 into 2 plus 5 into 4. Is this correct? Type a yes or no. Is this correct? For location 1, 0. So for the last location, we have 4 into 4 and 5 into 8. Okay. So this is the final matrix that we have in hand. And this is basically just equal to 2 plus 8 is 10. 4 plus 16 is 20. And 20 plus 8 is 28. And 16 and 40 is 56. Okay, so we have something like this in our hand, right? So let's see what we are doing below. So we have created another array called resultant array, and we have started it with 0, 0, 0, 0. And these will all become 2 now, because we have reduced the size, right? So this will become lesser. Okay. So now what we are doing is we are going from 0 to R1. Then in J, we are going from 0 to C2. Okay. So basically 0 to 2 and 0 to 2. And then inside here, we are going for K0 to 2. 0 to 1, like 0 and 1, no, not 2. Then in the resultant, what are we adding? Matrix of, initially it is 0, I is 0, K is 0. So matrix 0, matrix 1, 0, 0 multiplied by K is 0, J is 0. So matrix 2, 0, 0. Then K becomes 1. Then in resultant 0, we are adding matrix of 0, 1 and 1, 0. So let us see here. 0, 0 into 0, 0, 0, 1 into 1, 0. This is what we have written here. 0, 0, 0, 0, 0, 1 and 1, 0. So next, after we have computed this one, this for loop gets over. We go back to this for loop. Now J becomes 1. Now we'll calculate for 0, 1. Row 0, column 1. We'll calculate this one now. So how did we calculate this one? 0, 0, 0, 0, 1, 0, 1, 1, 1. Let's see if this happens or not. Now K starts from 0. Resultant 0. Now J is 1. 0, 1 is equal to 0, 0 and 0, 1. Then K becomes 1, 0, 1 and 1, 1. Oops. I pressed something by mistake. Okay. It has become red. Okay, done. Okay, got it. Everyone understood what we have just done? Or should I write it down once so that it is more easy? What do you guys say? You have understood what we are doing, or should I just write it down on the board once? If you want me to write it down again, type yes. If you don't want me to write it down on the board, type no. Okay, so it is clear. It is clear. Mona Lisa, you want me to explain it once again? Yes? Yes, okay. I'll explain it once again. So now we'll calculate for this particular position, right? Well, just I, J, and K, these are the 3 variables that we have, right? Initially, there was 0, 0, and this was 0. Then what happened? In the next iteration, j increased, but I did not. So it is 0 and 1. Okay. So right now I is 0, j is 1. I is 0, j is 1. Now we again go back into this loop. Okay. So for now, k is equal to 0. K is equal to 0. So for rest, I, j, let's see what we'll do. Firstly, we are adding matrix 1, I, k. I is 0, k is 0. So matrix 1, I is 0, k is 0. Multiplied by matrix 2, k is 0, j is 1. So it is matrix 2, k is 0, j is 1. Then this loop iterates again, k becomes 1 now. So when k becomes 1, what do we add in this? Matrix 1, I is 0, k is 1, 0, 1. So it becomes matrix 1, 0, 1 multiplied by just now k is also 1, j is also 1, so matrix 2, 1, 1. So it is matrix 2, 1, 1. Okay. So result 0, 1 is basically equal to, let's put the values now. 0, 0 is 1 multiplied by matrix 2, 0, 1, 0, 1, it is 4 plus matrix 1, 0, 1. So row 0, column 1, that is 2 multiplied by matrix 2, 1, 1. So 1, 1, that is 8. Okay. So this is equal to 8 into 16, 16 plus 4, 20. So you see this calculation is equal to this. It is same as this calculation. Right? This calculation and this calculation is exactly same. I'll just remove these comments and show you the complete code ones. Okay. So after this particular loop has run completely, we have our answer in the resultant matrix. Now we'll display it to the end user so that we know we have got the correct answer. Okay, so I and j we have already declared outside, so we don't need to use end keyword here. Now j is less than resultant I dot length and j plus plus. So like any normal 2D matrix that we have been printing till now, we'll print this one as well. It's nothing different, nothing new. We'll just print resultant I and j. We'll leave a space here. After one row has been completely printed, we'll move on to add a new line character so that there is no confusion. Okay. So that it is printed clearly. Now we'll just run this thing. Let's see if we have made any error. No, we haven't made any error. We have got the correct answer. So we are done with this particular concept.
So let's continue. So the first topic that we're going to see is stacks. So first of all, let's just forget about computer science. We'll talk about a normal stack. Okay. So it's an English word, and what it actually means is, so stack is basically putting one thing on top of the other, right? So when we create a stack, it's simply let's create a stack of blocks. Okay. So these are our blocks. And if we put one on top of the other, this is called a stack, right? So let's say that these are books. Okay, this is book number 1, book number 2, book number 3, and book number 4. And this is the table that we are putting the books on. All right. So let's say we add a book number 5 to this particular stack. So where will it go? It will go on the top.
right? So whenever we add a new element, it will go on the top. That the latest element will go on the top of the stack because the structure that we are following. That whenever we add a new element to it, it will go on the top. Very good. So this forms the basic of a stack. Whenever there is a new element, it goes on the top. So now we want to take a book out. Let's say we want to take out book number 2, right? Let's say we want to take this book out. So how will we do it? Which will be the first book that you can pick? You can't straight away pick this one, right? Because the stack, all the books on top will fall down. So you can't just take away this one. So first element that will come out will be book number 5. So let's say we keep it on the side. Then we take out book number 1. And then now finally we can take out book number 2. Is this clear? If we have this stack, book number 5 is on the top, then we have book number 1, 2, 3, 4. If you want to take out book number 2, firstly we'll have to take out book number 5, then book number 1, and then book number 2. So our structure is such that we are keeping the books on top of one on top of the other, right? So if we have this particular structure and we want to take out book number 2, right? We're trying to take this book out, book number 2. So if we take out book number 2 straight away, book number 1 and book number 5 will fall down. So first book that we take out is book number 5, right? Then we take out book number 1, and now we can finally take out book number 2. Okay, so the new element that we have will go on the top. And if we want to take out any element, we have to start from the top. Okay, so this is the structure of a stack. We haven't done anything in computer science yet. This is a normal stack of books that we create at home. All right. So now one very interesting concept here is the last element that goes into the stack, or the last book that you have kept, will be on the top. And this will also be the first element that comes out of the stack. So the last element that goes in will be the first element that comes out. So if we write it like this, LIFO. So what does it mean? It means last in, first out. Last in, first out. So the last element that went in was the first element that came out. That a stack is a LIFO structure. It follows the LIFO approach. LIFO, last in, first out. So the thing that we have seen till now is a stack, and we have seen that the last element that goes in is the first element that comes out. So let us now see how we can code such a thing in computer science. Okay. So in computer science, we have, let's say, a memory, right? So these are some of the elements that are already in the stack. So there are basically 3 functionalities that we'll use. Let's say these are the elements, 5, 4, 3. Let's say we have some random elements here, 12, 13, and whatever. So if you want to look at the top number, whatever is at the top of the stack, we just want to know what is at the top. This is called peak functionality. Peak. What does it tell you? Top element. It doesn't remove the element, it just tells you the top element. So let's say this is our stack and we have a pointer at the top. We have a number, we have a pointer that has the address of the top of the pointer of the stack. This is all the information that we have. So through this pointer, we can see the number that is stored here. It tells you the value of the top element. That's it. It doesn't remove it. It doesn't do anything, doesn't change anything. It only tells you what is at the top. The next functionality that we can have is pop. So as the name suggests, it removes the top element. Okay, it removes the top element from the stack. So if we call pop, what it does is it will remove this particular element, and our pointer A will now point to 12, because now 12 will become the top of the stack. So the third functionality that we have is the push functionality. All right. So third thing that we have is push. What it does is it adds an element to the top, adds a new element. Okay. So here, if we push 15, what will happen is, if we have this stack now, so if we push 15, 15 will come at the top of the stack, and our top of the stack pointer, that is A, will now move to 15. Push, peak, pop. Type a yes or no so that I know. Is push clear to all of you? Okay, it's clear to Murshidul, Mona Lisa, good, and Surya Pratap. Excellent. And Emmanuel as well. Very good. So we have these three functionalities in a stack. So this is what this is the theory for stack. So we have a lot of functionalities where we use stacks. So where do we use stacks? Let's see. Okay. So in your computer, you must be opening a lot of different things at the same time, right? Let's say you open the VLC media player or window media player, right? You also open, let's say, Google Chrome, or maybe Edge or Internet Explorer, whatever you're using. You can also open, let's say, a game. You are playing a game, a video game, and you also open a calculator, right? So what happens is you have a single, let's say you have a single processor inside your computer. So the computer now has to juggle all these different applications. So the computer or the single processor only processes one of the application at a time. It doesn't process all the applications together, but it does so fast that you feel like all of them are working together. So basically, it gives, let's say, 1 millisecond to the first application, then to the second, then to the third, then to the fourth one, and you don't realize because it is so fast that you can't perceive it. Right? It cannot be perceived with the human eye. The pause that that is there, you can't see it because the clock cycle of a computer is so fast that it is doing the switching so fast, thousands of times within 1 second. So you are just not able to see it, but computer is only processing one application at a time. So for this functionality, many computers employ a stack. So whenever you open something, it creates a new element in this stack. Okay. Let's say this is our stack. So the first thing computer processes is the VLC player, let's say. Okay. It processes this and then removes it from the stack and adds it to a second stack. Okay. This is stack 1. This is stack 2. This gets removed from this one and gets added to second one. Then the top of the stack moves to Chrome. It executes Chrome and moves it to the other stack. Then it executes your game and moves it to the other stack. Then it executes the calculator and moves it to the other stack. Okay. Then it does the same for the second stack. Now it executes the calculator, moves it to the first stack. Then it executes game, moves it to the first stack, and so on for Chrome and VLC as well. So this is how it cycles through all the different processes that are open. Okay, so this is one use case for stacks. So now we'll see how we can code it in Java. So any programming language has a number of APIs or inbuilt libraries inside it. Okay, to make our lives easier. So we'll use one such library to code this particular stack. Let us see how we can do that. Okay? Yes, very good. Okay, so now we will try to code this. So I'm telling you we will use a library for this. Let us see how we can use that. Okay. So the first thing you need to do before you use a inbuilt library is import it into your own program. So you have to write a few lines so that you can import them. So stacks are inside the util package itself. Okay. So if you have imported java.util.star, That means you have imported everything that is inside the util package. If you want to import only the stack, you can write it like import java.util.stack, S capital. Okay. So you can use this line to import stacks into your program. And now you can use stacks. Let us see how we can do that. With this line, we have imported everything that is inside the util library. So we don't need to add the second line. Okay. So you straight away write stack. Be very careful and look at the syntax very carefully. Okay. So this is the type of stack that you want. What stack do you want? It can be an integer stack, string stack. You can create any stack that you want. Let's create a stack of all the animals. Okay. So new stack. So this is how we create our stack. So stack has been created. Right now it is empty. Okay, so now the first thing that we need to do is populate this particular stack. So we'll put elements into it. Let's try to put some elements. So this is the name of the stack. Then we use the keyword push. So we saw three functionalities: push, pop, and peek. So we'll try to use all of them one by one. So let us try to add dog into our stack. So we have added dog. Let us now try to add horse into it. Okay. Now we will add, let's say, cat. So we have three animals in our, So we have three animals in our stack. Is it clear to everyone? We have a dog, we have a horse, and we have a cat. Let us now print it. Okay. So it's very simple to print out your stack. So let's say you just write stack plus the name of the stack, animals. So this is how you print your stack. Let us try to run it and see what happens. So here you can see at the bottom, we have a stack with three animals in it: the dog, the horse, and the cat. Okay, so this is our stack. Now, one very interesting question I'm going to ask you. Okay, you will have to tell the output of this particular thing. So we take a string, let's call it top element. Let's make it equal to element. Let's make it equal to the top element of the stack. System dot out dot print ln top element. Okay, so we are taking the peak into top element, the peak value into top element, and we are printing it out. Okay, so you can see the answer is cat. I'll just do one thing so that it's a bit more neat. Just rerun this. Okay, so you can see this is our stack, and at the top we have the cat. Very good, everyone. So you guys were correct, and I know that you guys are able to understand it really fast. So that is very good. So all the students have really good grasping power, and that is all we need, right? We don't have to cover a lot of ground, but whatever we cover, we have to be very sure that we understand every part of it. So now we can also search an element inside the stack. Let's try to search an element. Let's delete the peek function. Now we'll try to search a particular element. So int position equal to animals dot search. So for this, we'll use the search function. So which animal should we search for? Let's say we search for horse. Okay. Now we simply print it out. Okay, so we are printing the position. Let's just write a message so that it is more clear. Okay, so we are printing the position of the horse. So what would be the answer? Any guesses? Everyone? Any guesses? Okay, let's try to run this. Everyone is saying 1. So we'll just try to run this. So position of horse is 2. This is not an array, it is a stack. Here indices start from 1 only, not from 0. Okay. So at index 1 we have cat. Or let's try to find out the index of cat. Cat now. Let's run this. We have to type cat here as well so that it makes sense. Okay, so position of cat is 1. So cat is on the top, then we have the horse, and at the end we have the dog. Right? This is what we saw in the diagram as well. We put one animal on top of the other. Okay. We have another function to check if the stack is empty or not. Okay, these are all the functions that you will frequently use while you are coding. Okay, so make sure you understand each of them. It is not very difficult. If there is any issue, do let me know. Let's move forward. So sometimes we need to check if the stack is empty or not. So let's take a boolean. Let's name it result. So basically the empty function will return a boolean, either true or false. That will tell us if the stack is empty or not. So let's print it. Is the stack empty? So this is our question. If the stack is empty or not. Now we'll print the result. So let us try to run this once. So here you can see that it is false. Why? Because we have these 3 elements inside our stack. So it is not empty. So this empty function will tell us that it is not empty. So it will return false. Okay. Let's move forward. Okay, so this was for stack. Now we'll move on to a new concept called queues. So let us try to understand what a queue is now. Queue. Okay, so let's see how a queue works. Okay, so it's a standard queue. Let's see what it means in English. So student 1, let's say, is the first one to stand inside our queue. Okay, to stand in the line. After this, we have student 2. So where will student 2 stand? It will stay. The student will stand after student 1. So the students 2 will stand here. Then comes student 3. This student will stand after student 2. Then we have, let's say, student 4. Okay. So they are waiting for the bus to come. Let's say the bus has arrived. So who will be the first one to enter the bus? Student 1, 2, 3, or 4. If this is how they are standing in a line, so all of you basically think that S1 will get on the bus first. And that is correct. So S1 will get inside the bus. Then S2 will also get inside the bus. Then S3 and S4 and so on. Right? So in this, what is happening? The first student who was standing in the line was the first one to come out of the line and get inside the bus. So this is first in, first out. The first person to come will be the first person to go out. In stack, it was opposite. First person to come in will be the last person to go out. So last person to come in will be the first person to go out in stacks. So that was a LIFO approach. Like we just saw, I'll just show you again. So with stacks, we have the LIFO, but with queues, we have the FIFO. So FIFO means first in and first out as well. So let's take another example. So let's say there's an ice cream stall or a ticket stall, right? Tickets. And it is closed right now. It's not functional. Okay. So there's a huge line outside. Person 1 is the first one to come. Then person 2 comes. Person 3 comes. And there's a very long line after that. Okay. Now suddenly the person responsible for the ticket counter comes back and the ticket counter is now open. So who will be the first person to be able to buy the ticket? P1 will be the first person to be able to buy this ticket because he's standing in the front of the queue. So if you remember, he was also the first person to come into the line. So first person to come in is also the first person to go out. So first of all, we'll cover the one functionality that is left in a stack. That was pop. All right. So animals dot pop. Then again, let's call it three times. Okay, let's call it thrice. So now what will be the output of this particular code? So let's try to run this. So you can see it has now become true. Why? We entered 3 animals into the stack and we have removed all of them one by one. So now it is now empty, right? Let's play around with these concepts a little bit so that we can get a better understanding of these. So let's pop an element. Let's push another element in. Animals dot push. So we'll go ahead with the tiger. We'll put tiger in. One more animal. Anyone? Just one more animal. We'll put another animal in. Okay, fox. Cool. So we have put the fox and the tiger inside our stack. Here let us try to output. System dot out dot print. Let's print animals dot peak. Okay, so now you will have to guess the output of these functions, like of this particular code. Okay, so we are printing only thrice. So there will be 3 outputs that I can tell you for sure. All right, so peak only gives one element that is at the top. All right, so let's try to run this and see if we have completely understood or not. So it's fox, tiger and horse. Okay, I forgot to put a ln here. Let's try to print it again. So it's a fox, tiger and horse. Let us try to understand how this happened. Okay, so that is important. Only the answers are not important. So initially we had the dog inside our stack. Then we put the horse on top of the dog. Then we put the cat on top of the horse. Okay. Then we removed one element. So the top element was cat. So cat got removed. Then we put tiger and fox. So now our stack would look something like, at the top we'll have fox. Then we'll have the tiger. Then we'll have the horse. And at the end we'll have the dog. Now we print the animal at the top, so fox gets printed. Then we pop the element. So we remove one more element. So here our fox gets removed At the top, we'll have tiger, then we'll have the horse, and then we'll have the dog. Then we'll again print the animal at the top. So tiger will get printed this time. Okay. So again, we pop one element or remove the top element. So our stack would look something like this. The horse and the dog. Again, we are printing the top, so horse gets printed. So it's fox, tiger, and horse. So we are all on the same page. We all now know what a stack is doing. Now we will try to understand what a queue can do. Okay. Then we'll play with the stack and the queue a little bit. We'll create a stack and we'll create a queue, and we'll see what we can do with both of them. Okay. So that we are very clear with the concepts. So as I've already told you, there aren't many concepts. Yeah, if you completely understand the basic ones, that is more than enough. So now we'll create a queue. Okay, so to create a queue, we need two things, a linked list and a queue. So for that, we'll need to import java.util.linked list, and we'll need to import java.util.queue. Queue. All right. So we'll understand the linked list right after queue. So don't worry about it right now. But because we have imported this particular line that says import java.util.star, that means we have imported everything that is inside the util package. So we do not have to import these two lines, right? Because we have already imported everything that we had like inside the util package. So we don't have to separately import linked list and queue. So we'll delete these lines, right? So now we'll create the queue. So the syntax is very close to stacks itself. You just write queue. You type what type of queue do you want. Let's say we need an integer queue. Let's name our queue queue. New linked list. This is how we declare our queue. Okay. So don't worry about the keyword linked list right now. We'll understand linked list in great depth right after we have completed stacks and queues. So this has created our queue. Let us try to add a few elements into it. Right. So for this, we have the function add. What does add do? It adds an element to the queue. Okay. So let's queue dot add, let's say 1, queue dot add 2, queue dot add 3, queue dot add 4. Okay. Let us now print the entire queue. Queue. So we have 1, 2, 3, and 4 in it. So instead of push, we have add. Instead of pop, we have remove. Let us try to remove an element. Let's remove it here. So the answer is 2, 3, 4. So I'll again go to the whiteboard and I'll explain it, and then I'll explain what has happened. Firstly, we added 3 elements to our queue. So the first element was 1, then it was 2, then it was 3. Then we removed one element. So which element will get removed? That is what you have to keep in mind. This is not a stack. So the top element won't be removed. The first element will be removed. So 1 will be removed. Then we added 4. So the elements left in the queue would be 2, 3, and 4. And hence this is our answer. So one question that has been asked is, what if we remove an element before adding 2? So 1 will be added, then 1 will be removed, then 2, 3, and 4 will be added. So 2, 3, 4 will be the answer. Nothing very difficult here. We have 2, 3, 4. Very good, everyone. So we have add, we have seen remove. So now we'll study just one more function of the queue. One more function call that we usually do. Let's study two more, okay? Queue dot peak. All right. Let's try to run this. So the top element is 2. Why? We added 1, then we removed 1. Then we added 2, 3, and 4. So what is at the top? If it were a stack, 4 would have been on the top. But it is a queue, so 2 is on the top. Okay. So with peak function, we can easily see what is on the top of our queue. And if we are using a stack, then we can, with the same function, see what will be on the top of the stack as well. There's just one more function that we need to study. Then we'll try to play around with the queue and the stack. Okay, so we are removing twice here. Size of the queue dot size. Okay, so what would be the answer here? Let us try to run this. So the size is 2. Very good. So now we are clear with the queue and we are clear with the stack. So after this queue, I'll try to create a stack. Let's make it of type string only. This also, let's make it of type string. All right. Okay, so here we are. So we have a queue and we have a stack. Let's add some elements into the queue. Okay, so these are strings now. Okay, sorry. Let's try to print it, run it. Okay, so the answer is dog and elephant. Okay, so first of all, in the code, what we were doing was we were adding a cat to the stack. So we have a stack, okay, and we have a queue. So we were adding a cat, dog, and elephant. So it went like cat, dog, and elephant. Right? In the stack, the elements will go one on top of the other. right? Like this. Okay, so we are firstly adding elements into the stack. No, sorry, we are firstly adding elements into the queue, not the stack. So this stack remains empty. So it's cat, dog, and elephant. So inside the queue, first animal is cat, dog, and elephant. So we have these three animals lined up like this. Now we are pushing into the stack the very first element of the queue, and then we delete that element. So into the stack, we push the first element of the queue. So the animal at the front of the queue, that is the cat, will move to the stack. Okay, so it will go to the stack. So cat would come here. Then we are removing the element from the, we are removing the top element from the queue. So this gets removed. After this, we are again doing the same thing, moving the topmost element of the queue to the stack. So on top of cat, we get the dog. Then we are removing this element from the queue. Now at the end, we are printing the top of the stack and the queue. In what order are we doing it? We firstly print the top of the stack, then of the queue. So top of the stack is the dog and top of the queue is the element. Yeah, because coding is simple. Logic building is that is the main problem. Most of the students, what they'll do is when they try to learn coding or start coding, they'll straight away jump to the coding screens, the coding competitions. They won't build up their algorithms or the basics, right? And that is where they'll lose out on basic theories that will help them code. So let us now take two stacks only. Okay, so let's delete this queue for now. We'll take two stacks. Both of them will be of integer type. Another stack of type integer. This is S1, this is S2. Okay. The output for this. Tell me the output for this. We are not using stack 2 for now. So firstly, we are putting 0, then 1, then 2, then 3, then 4. We are stopping at 4. Okay. So what would be at the top? The last element that has been added, and that is 4. We'll run it. We'll use a while loop now. While s1 dot. So s1 dot empty not equal to So let's just do it like this. While not s1 dot empty, let's push the elements into s2. s2 dot push it. It is getting a lot more tricky as we move forward. So you have to be very careful that you understand the concepts. Right? Only after that you answer the questions. All right, let's try to run this. Okay. So what we did now was we created two stacks. One we named S1, the other we named S2. In S1 we added numbers from 0 to 4. So firstly 0 was added, 1 was added, 2 was added, 3 was added, and 4 was added. Then we started emptying S1 and added these elements into S2. So what we did was we transferred the top element to S2 and we removed the top element. So 4 came here. We kept doing it again and again.
Let's have a quick quiz question, guys. And the question is, which of the following is divide and conquer algorithm? And your options are bubble sort, selection sort, heap sort, or merge sort. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ENICT IIT Guwahati. The course link of which is given in the description below. Now let's continue with the session.
3 got deleted, 3 came here, then 2 got deleted, moved here, so 2 came here, then 1 got deleted and moved, so 1 came on this side. Finally, 0 was also removed and deleted. So this is stack 2. Then we displayed the top element in stack 2. So this was our output. So the trick to become a good coder is not knowing a lot of concepts vaguely, but a few concepts with extreme clarity. So very good, we have done this much. Now I'll do something else. So let's put another while loop here, not s2 dot empty. Okay. So s1 dot push, s2 dot peak, s2 dot pop. All right. So the concept that I was introducing here was very simple. We have 2 stacks. One stack, we are emptying one stack and putting it into the other stack. So we don't make a copy. We make an inverted stack here. If it is 1, 2, 3, 4, we make a 4, 3, 2, 1. So what we did here was we inverted the stack twice. Right. So 1, 2, 3, 4, 4, 3, 2, 1, and then again 1, 2, 3, 4. So we got the original stack back. So the top would again be 0. Right. Very good. So now let us play with the stack and the queue. So stacks, I think, are completely clear to all of you. Now we'll go for the queues. Right. So we have a stack and a queue now. Let us put some numbers into the queue. Okay, name of the queue is Q1, not Q. We'll put I here. All right, let's try to run this. So the answer is 0. So we'll use a while loop now. Or we'll just use another for loop, no issues. I equal to 0, y less than 5, y plus plus. So from this queue, we'll add the elements to the stack. So in S1, we push Q1 dot peak, Q1 dot pop. Sorry, it's a queue. So we're removing, push and removing, and then y s y. For now, let's keep it to this much. So 4 is the answer. So in this code, what we did was, I'll just quickly recheck. So we added elements 0, 1, 2, 3, 4 into the queue. Then we one by one added those elements to the stack and we then printed the top of the stack. Okay. So it's nothing very difficult. We had a queue and we had a stack. So in the queue, we added 0, 1, 2, 3, and 4. Then we moved them to stack one by one. So when 0 went to the stack and got deleted from the queue, it got to the bottom. Then 1 went over there, then it's 1. Same thing happened with 2, 3, and 4, right? 2 went there, 3 went there, 4 went there, and they all got deleted from the queue. Then we printed the top of the stack, that is 4. And you all understood the concept very clearly. So 4 was the answer that you all have given. So we'll change the code just a little bit and see how that changes our output. So we'll do a while s1 dot empty, we'll put not here, while this is not empty, we'll just print s1 dot peak. So here we'll get a error. Why? Because this is an infinite loop. So you missed out this thing, only Akshay caught it. We are not removing the elements of the stack, so stack will never be empty. It will keep printing the same number over and over again. So at the top of the stack we have 4, it will keep printing 4. So you can see that it is just printing 4. I just have to stop it. So s1 dot, let's pop this time. Right. Now what would be the answer? Manual 43210, Moshadul 43210, Mona Lisa also 43210. Let's print it. Let's run this code. So it's 43210. So we'll move forward and see and play a little bit more with these things. Let's make another queue. Integer type only. Q2. Okay. All right. So we have our queue ready here. So firstly we add to the queue, then we put to the stack. Now we put into the queue. Let's go into Q2. Pops. Okay. Okay, so let us run this. So the answer is what happens if we copy one queue to another queue. Okay, so let's remove the stacks. We don't need the stacks anymore. Q2 dot add Q1 dot peak. Removing and okay, be very careful. We have done a similar code with the stack where we created one stack, copied it into the other stack. So there the stack got inverted. What will happen here? So let's see what happens. Firstly, let's print out the answer. Okay. So it's clear what the answer is. So it's 0, 1, 2, 3, 4. So here we have two queues, Q1 and Q2. Okay. So we added some numbers in Q1. So firstly we put 0, then 1, then 2, then 3, then 4. Then we removed elements one by one from Q1 and added them to Q2. So firstly we take 0, we add to Q2. Then we take 1, we add to Q2. 2 moves, 3 moves, and 4 moves. So you can see that Q1 and Q2 are identical. They are not inverted. It is the same. Okay, so these are our answers. So in case of stack, when we copied elements from one stack to another, the elements got inverted. In case of queues, when the elements are copied from one queue to another, the queue remains the same. So we have till now understood clearly two interactions. when one queue is copied to another queue, when one stack is copied to another stack. Let us see what happens when they interact with each other. Okay. So let's say we have a queue and we have a, let's delete the code first. Let's create a stack here. All right. So let us add some elements in this. Okay, so we have added some elements into the queue. We have added some elements into the stack. Now we're adding some elements from the queue to the stack. At the end, we are adding some elements from the stack to the queue. Okay, so this is a very tricky question. If you guys get this one correct, it will mean that all the concepts of stacks and queues are completely clear to you all. So here what we'll do at the end is we'll simply print the stack, then we'll print the queue. If you simply print the stack, it will be printed in the opposite like if the stack is 3 to 1, it will print like this, it will be printed 1 to 3. So let's print the stack the way you were doing. Okay, so here we are printing the stack and here we are printing the queue. So this is our code. So the answer is for the stack it is 98765. Okay, 98765. For the queue it is 23410. So first of all, what we did was we created the queue and the stack. In the queue, we added numbers from 0 to 4. So let's create the queue. So we have a queue and we have a stack. So in the queue, we added numbers in the range 0 to 4. So it goes 0, 1, 2, 3, and 4. In the stack, we added numbers from 5 to 9. So stack goes like 5, 6, 7, 8, 9. Okay, after that, what we did was we went from 0 to 1 in a loop and we pushed two numbers from the queue to the stack. Okay, from the queue to the stack, two numbers. Right, from the queue to the stack. So 0 went to the queue, 0 went to the stack and 1 went to the stack. So first 0 went here, then 1 went here. Okay. After this, we again ran a loop for, we ran a loop twice and added two numbers from the stack to the queue. two numbers from the stack to the queue. So 1 actually goes back to the queue. So in the queue, it will get added to the end and will get removed from the stack. Then 0 goes to the queue and gets added to the end. And that is it. This is all we did. Then we printed the stack. So stack will be 9, 8, 7, 6, 5. Then we printed the queue. Queue would be 2, 3, 4, 1, 0. So we'll just add a space here so that it's more clear. So Mushaddal's answer is also here. 43210 is the queue and 86420 is the stack. Okay. All right. So let us try to print this now. Okay, Mona Lisa's answer is also here. 0864 243210. Okay, let's print this. So 86420 and 43210. The stack is 86420 and the queue is 43210. It won't take much long, don't worry. We'll try to quickly wrap it up, right? But we'll have to actually go a little deeper into this concept because it's a bit more tricky and a bit more important than the concepts we have covered till now. So what, first of all, let's try to understand what a linked list is. Okay. So linked list is very similar to what its name suggests. I'll just share my screen and try to explain to you what a linked list is. So a linked list is a list that is linked together. Okay. So basically, we have these small blocks. These blocks basically contain two things. Firstly, the value that we have to store, that we want to store, let's say it contains a 5. The second part contains address of the next block. Basically, this block contains address of this block. In the next block as well, we have something similar, the value and the address to the next block. Again, we have something similar, and the last link has a null pointer at the very end. Null simply means pointing to nothing. Okay, so it won't make a lot of sense right at the beginning. As we try to code, it will make a little more sense. Okay, so what was happening in an array? We were allocating the memory that we need all at once, right? Statically, all at once. This means statically. So let's say at the beginning of the code, we don't know how big of an array do we want. We can't make it very small because what if we make an array of size 10, but we want an array of size 15? So we take a large array. Let's say we take an array of size 100. Okay. But the values that we want to store are only, let's say, 20. So how much space is wasted? 80 blocks are unfilled. This is for an array. Is this understandable? What I've just explained about the arrays is this much understandable that we have to declare the size of the array right at the beginning. So in case we don't know what the size should be, we have to declare a very large array, and that can result in space wastage. So if we declare an array of size, let's take a very small example of size, let's say 5, 1, 2, 3, 4, and 5. And we store only two values, 1 and 2. So these spaces that are left, so this is our array. Now we'll move on to linked list. So the first thing that you should understand about any new data structure is, why do we want that? So this is exactly the reason. This wastage is the reason why we want the linked list. In linked list, we allocate memory one by one. Here we were going for all at once approach for the array. For the linked list, we are going for one by one approach, or the dynamic memory allocation. So we start with a single element. Okay, we start with a single element and we store our value there. Whenever we need more space, like we have to store another number, we'll create one more element and we'll link these two together and put the second number there. Let's say we need we need more space, we need to store one more element. That's cool, we can do that as well. Okay, and we'll make this point to this one. The last one will point to again null. Okay, null just means nothing, pointing to nothing. Okay, nothing. So in this, we don't have to allocate all the memory right in the beginning. We are allocating it one by one. So we are not wasting any memory. We needed space for 3 values and we created space for 3 values only. So this is dynamic memory allocation. Just write the word here. It's called memory allocation. Okay, memory allocation. Arrays may cause wastage. Linked list, no wastage. Very good. So this much is clear to us that array can cause wastage, but in linked list we are causing no wastage. We are allocating the memory when we need the memory. In arrays, we are allocating the memory right in the beginning. Very good. In linked list, we have to traverse it linearly. One more concept, one very important concept. Linear, traversal. Okay. We have linear traversal in the linked list. Now we'll try to understand this part. While we have random access, in arrays. Now we'll try to very carefully understand what I've said, because only these 2 points are important. Wastage, no wastage, we have understood. Now linear access and random access. First we'll go for the array. So this is how arrays are stored, right? In the memory. Here we have a number. Let's say its address is 0. Here we have another number, its address is 1. Here we have another number, its address is 2. 20 is at 3. Okay. Now let us say we want to access this particular element. We want to access 15. How can we do it? We have stored the starting address of the array. So 0 is the starting address. We want to access something at index 2. We'll add that to 0. At address 2, we will find our element. We don't really have to access 5, then go to 10, then go to 15. We can straight away do this calculation and go to 2. This much is clear to all of you? Random access, is it clear? Right? If we want to go to the 1000th element, for 2 element it may seem very useless. If you want to go to the 1000th element, We don't have to traverse 0 to 1, 1 to 2, 2 to 3, moving forward, and then go to thousands. We can simply do 0 plus 1 0 0 0 get to 1 0 0 0 thousandth element. Okay, at this address we can straight away go and access the element, whatever value is there. Okay, now it should be very clear what is random access. It is saving our time. If we want to access the thousandth element, we are not traversing like one by one, 0 to 1, 1 to 2, 2 to 3, 3 to 4. We're not going like that. We are straight away moving to the thousandth element. Now we'll go for linked list. Okay, so as we saw in the linked list, now I'll create a linked list. So this has random access. Arrays have random access. Now we'll go for the linked list. Let me draw one linked list. Okay, so the first element is at address 0. Second element is at address 10. Third element is at address 21. First element will give you the address of the second element. Okay, so we can come here. Second element will give you the address of the third element. So we can come here. Now if we want to access the third element, okay, so can we do this? 0 plus 2, this is the 0th element, first element and second element. Okay, we want to access the second element. Can we do this? Is this the address of the second element? Yes or no? So we can't simply calculate the address of the element now. We have to go one by one. Okay, first we get here, we get address 10. So we jump to address 10. Then we get this 21 address, then we jump to address 21. And this is how we get to our second element. Imagine there are 1000 elements. Now we have to go linearly. Firstly to address 0, then to the next address, then to the next address, and we have to do this 1000 times. Is it time taking? Yes or no? More time taking? Yes. So even for the CPU or the computer, it is more time taking. So I'll just quickly summarize what we have done about arrays and linked list. Okay, very important. Try to understand this. Arrays. Okay. May waste space, but there is an advantage also. Otherwise, we would never use arrays, right? If there is something that has all the disadvantages only, we will not use that concept. But arrays is being used, so there should be an advantage also. Advantage is random access. Okay, so this is a disadvantage, this is an advantage. Now, linked list. One, no space wastage. Okay, why is there a space wastage? Static memory allocation. Right in the beginning, we have to say how much space we need. Why no space wastage? Dynamic memory allocation. Right. Second point is now there's an advantage, but there is also a disadvantage. Disadvantage is linear access. So we are talking about ROM and RAM. Yeah, so you can say that, correct. In a way we are. But ROM and RAM are hardware concepts, right? In those, we do use linear access and random access. We are only talking about the software concepts for now. Okay, they are being implemented in hardware as well, but right now we're talking about the software aspect of it. Okay, so linear access. So no space wastage is advantage. Linear access is disadvantage. So now we know why we have to create a linked list, right? Or why we have to create an array. Okay. So this is the most important thing, because even linked list, we are just going to import one library and our linked list will be created. No issues in that. Now, one question I have. Okay, we'll see some very interesting questions here on the board itself. Okay. So we won't involve code for now. Firstly, we'll do the theory. Okay, just theoretically, if this is our linked list, this is how it looks. I've already explained what this structure is. This is null. How do we find the midpoint of a linked list? While declaring an array, we give the size as well, right? So for this array, we give size 4. So there won't be a midpoint because size is 4. Let's say size is 5. Okay. Let's say this is the array. While creating the array, we give the size 5. So we automatically know that the midpoint would be 5 upon 2. This is equal to 2, right? Floor function. So 5 upon 2 basically is equal to 2.5. So the greatest integer before 2.5, greatest integer less than or equal to 2.5, that is 2. So this is the floor function. Greatest integer before or equal to the particular number inside the floor function. Okay, so this is 2. So this is the midpoint. How do we calculate the address of the midpoint? Starting address plus 2, 2. We have found the midpoint. So is it clear that finding the midpoint of an array is very easy? Move to the next element, count equals 3. Move to the next element, count equals 4. Move to the next element, count equals 5. Next element is null, so we don't count it. Now we know that there are 5 elements. Is this much clear to everyone that we can count the 5 elements like this? How many elements are there in the linked list? We can count it by traversing. Is this much clear? Yes or no? Yes? Very good. So we have counted how many elements are there. Now we can use the floor function. 5 upon 2 floor, that is 2. Now again start from here and move 2 spaces forward. Because this is 2, we move 2 spaces forward. We move forward once, we start from here, we move forward once, we get here, we move forward again, we get here. This is the mid element. Very easy approach. Count number of elements, divide that by 2, start from the beginning again, move that many spaces. Yes, we have found the middle element. Now what if I tell you that there is a very interesting way of doing it? Very interesting. So we have a race track. Okay. This is our race track. This is the ending line. This is the starting line. So this is basically the start and this is basically the end. Now there are 2 people standing here, person 1 and person 2. Okay, so we can't iterate from both ends, Saurabh. One thing very important, Saurabh is saying that we can iterate from both ends. If we are here, we can't go back. There is no pointer to the previous element. We only have a pointer to the next element. we can't go back in a linked list. Okay. So coming back to what I was saying, this is the start point, this is the end point. There is person 1, there is person 2. Person 1 is running at, let's say, 20 kilometers per hour. Now I know this is not a realistic speed, but let's say this person is running at 20 kilometers per hour. And person 2 may be running at 10 kilometers per hour. So one very interesting question I'm going to ask you, when person 1 reaches the end, where will person 2 be? Where will person 2 reach? When person 1 reaches the end, where will person 2 be? Half, right? Half of the track. Person 2 will be exactly at midpoint. Okay, so we'll use something like we'll use this exact concept. Okay, so what we'll do is I'll again make a small linked list and I'll explain what we have just done. Right, so this will be like, I find it very interesting. We have used a completely real world problem solving technique and put it into code. This is our linked list. We'll put two iterators. One iterator will move two steps forward and one iterator will move one step forward. This is called fast and this person is called slow. Fast will move two steps forward, 1 and 2. Slow will move one step forward. Fast will again move two steps forward. Slow will move one step forward. Now fast cannot go any further because this is null. So wherever slow is, that is our answer. Okay, fast, I just mean that fast pointer is going two steps forward and slow pointer is going one step forward. So we're just calling this guy fast. Is this jump by 2? Yeah, so one by one it is going two steps forward while slow is going one step forward only at one time. Okay. Okay, so if fast moves one space and then gets the address from here and moves another space. Slow gets the address from here and moves one space only. So addresses will have to be contiguously followed. You can't take a two jump. I mean, fast can't directly reach here. It will move one space forward, get the new address, then move the second space. Is it clear now, Saurabh? Okay, very good. So this is how you find the midpoint in a linked list. Clear? Now, another very interesting concept I would like to introduce in the linked list. This much is clear, right? Everyone type yes or no if this much of linked list and array is clear. Because this is the basic of linked list. This has to be clear before we move forward. Okay. Okay. Again, so let's say we have a linked list. And because we have made some error, this has resulted in a loop. I'll just show you how. Okay. This guy is pointing here, 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 and this guy is pointing here. Let's take imaginary values 1, 2, 3, 4, 5. Let's take addresses 0, 10, 20, 16, 18. This guy is pointing to 10, this is pointing to 20, this guy is pointing to 16, this guy is pointing to 18, and this guy again is pointing to 20. Now we have the pointer here. Now we have to find out, okay, listen very carefully what we have to find out. We have to find out whether or not there is a loop in the linked list. If we try to iterate to the end, what will happen? Our pointer will go here, 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 move back to this place, move forward, move back to this place, move forward, and we will never find the null pointer, right? So now we have to find out if there is a loop or not. How do we find it? We do not know the size of the linked list, so we can't say that we go 10 spaces forward. If we do not find a null, then there is a loop. The linked list might be of 15 size, right? There may be 15 elements. Let's say we have a park, okay, that has a loop. We have a circular park, a circular path. Yeah, this is how the racing tracks are, right? They're circular normally. So we have this circular path. This is the starting point. And then we have a straight path. Okay, and this is the starting point. So there are two people standing at the beginning, person one, person two, person one, person two. Now person two is moving at 20 kilometers per hour again. Person one is moving at 10 kilometers per hour. Same is going on here. Person two is moving at 20 and person one is moving at 10 kilometers per hour. So if it is a straight line, will they ever meet each other? If let's say it is a very long straight line, will they ever meet each other? No, right? No? No. If it is a circular park, will they meet each other? Yes? Yes? Okay. So we'll use this concept now. Okay. We'll use this very small, simple concept. We'll take two pointers. We'll name this fast. Sorry. We'll name this fast. We'll name this slow. Fast will move 2 steps. Slow will move 1 step. So fast goes here and here. Slow goes here. Fast goes here and here. Slow goes here. Fast will go here and here. And slow will come here. They will both meet here. This is the point where slow and fast will meet. If they ever meet, we have a cycle. If they do not meet and fast reaches null pointer, then there is no cycle. If fast reaches null pointer, no cycle. If fast reaches slow pointer, there is a cycle. If I write this statement, like for fast pointer, we have two options. Null, it reaches null or the end, no cycle. Second, it reaches the slow pointer, then there is a cycle. Is this thing clear to everyone? Does this make sense to you guys? Yes? Yes? So was this interesting? Again, we have used a real life concept and put it into our code. Interesting, right? Yes? Very good. Very good. So we have understood how to find a cycle in a linked list. Okay? With the help of racing tracks. Good.
Let's say we have an array and the array is not sorted. It has random numbers in it. Okay. And we have to search for an element, let's say 5. So we just take a pointer to the first number in the array. We check if it is equal to 5 or not. Okay. So it's not equal to 5. We move forward. Then we check if 2 is equal to 5 or not. It is not equal to 5. We move forward. So we have found 5. These are the indices of the array. So we have to return 2 because 5 is on index 2. So this is our answer.
So now let's see a larger array and just look at the concept once again. Let's say we have 23, 46, 2, -8, 10. Okay. And let's say I want to find if 12 is there or not. Okay. So what I'll do is I'll put a pointer to the first element. This is not equal to 12. I'll move the pointer forward. It is not equal to 12. I'll keep moving forward until I find 12 or I reach the end of the array. 2 is not equal to 12. 8 is not equal to 12. 10 is not equal to 12, and we have reached the end of the array. If we haven't found the answer, we just return -1. Okay. -1 signifies that we haven't found the uh, number that was being searched for. Okay. There's 0, 1, 2 index, 3 index, and 4 index. So we return a -1 here. This is the most basic type of searching. If the array is not sorted, it will work. Okay. So there are two things that after uh, discussing the next algorithm, we'll discuss two things, two parameters. Okay. So the next type of searching is called the binary search. Let us have a look at that. And then we'll compare these two algorithms in terms of time complexity and in terms of in how many cases we can run this particular algorithm. The next thing is binary search. Okay. So let's see what a binary search is. So when we have to find a particular, let's say, word in the dictionary. Now I know most of you wouldn't have used a dictionary recently because we simply Google the meaning of the words if we want to. But if imagine you're using a dictionary, how do you find a particular word? So dictionary is arranged in an ascending order, right? So if we have, let's say, 3 words in the dictionary: cat, like dog, cat, and let's say rat. Okay, these are the 3 words that we have in our dictionary. Okay, so in what order would they be placed? They will be placed alphabetically. So firstly, we'll compare the first letters. So C is the smallest letter. So cat goes first. T is the second smallest letter. R is the largest. So this is how the dictionary would be arranged, right? So if the dictionary is of 1,000 pages, so what we can do is we can open a random page in between, let's say page number 500. We have to find, let's say, dog. Okay. So on page 500, let's say we have words starting with P. So we have to go backward or we have to go forward. On page 500, we have words which start with P letter. We have to go forward or backward? Backwards. Very good. So you will see that our dog would be in the range 0 to 500 now. So earlier we had the range 0 to 1000. Then we checked page number 500 and found letter P as the starting letter. So our range suddenly became 0 to 500. We have eliminated 500 pages through one search. 500 pages have been eliminated. That is 501 to 1000. That we have eliminated 500 pages, and now our search space has been reduced to half of what it was. Next, let's say we go to page number 250 and find that we have words starting with F. So is dog in 0 to 250 or 250 to 500? Backward, or like we have divided this into two parts: 0 to 250 and 250 to 500. Where do we find dog? We have words starting with letter F, we go backwards. So again, we have reduced our search area to half, right? We have eliminated 250 pages this time. Now we go to page 125. Okay. So here, let's say we have words starting with letter C, right? We have words starting with letter C. So where do we search now? What is our remaining search space? So we have these page numbers with us because 0 to 125 will contain letters A, B, and C, right? So we don't want that. So again, our search space is broken down into half, right? If we continue like this, if we keep on going like this, do you think we'll find dog? Keep eliminating half the range every time. And we know for sure that dog would exist in the dictionary. We'll be able to find it, right? So this type of search is called binary search. Okay, so let's take an example that we were taking earlier and try to see if binary search can be applied there or not. So let's take this as example 1, 2, 5, 3 and -2. Okay, so we'll take the example 1, 2, 5, 3 and -2. So 0, 1, 2, 3 and 4. Okay, so we need to find 3, let's say. So what is the first index that we look at? So basically, we'll put a pointer here and we'll put a pointer here. So we'll just see why it can't be applied. Okay, so we'll put a pointer at the beginning of the range and the end of the range. Okay, of the range that we are considering. So then we'll add index beginning and index end. So that is basically 0 plus 4 divided by 2. This gives us 2. So we'll search here. This is equal to 5, right? So this is our midpoint. This is the beginning, this is the end, and this is the midpoint. At the midpoint, we have 5, but the array is not sorted. We don't know where 3 will lie. 3 can lie here, and 3 can lie here as well. So we can't divide the range into 2 if it is an unsorted array. So what we found on a particular page was sufficient to tell us whether to search in the next half or the previous half, right? Very good. So it's clear to all of you. It's clear to Emmanuel as well, right? Cool. Cool. So we'll see an example where this will work. We'll take a sorted array. Okay. So let's try to find -5. We will try to find -5 here. Let's see if we are able to do that with this particular approach or not. We'll put the beginning pointer here, end pointer at 40. Okay. Then we'll find the midpoint. Midpoint is beginning plus end upon 2. Right? So this is 0, 1, 2, 3, 4, and 5. So this is the midpoint. So midpoint has 0. So we compare the number that is to be searched for, let's call it K, and the number at midpoint. Let's name the array ARR K. If this is less than, if the number at midpoint is less than K, if it is less than K, we make end equal to mid -1, right? So now if the number to be searched is less than 0, we will now search only in this particular range. So we'll search in this particular range now, right? So let's move forward. So now we'll again find a new mid. Okay, so mid will change because beginning and ending have changed. We'll use this formula once again, and our mid will become 0 plus 1 by 2, right? So 0 plus 1 by 2 is equal to 0 itself. Right? We are dealing with integers, so this will be equal to 0 itself. Yeah, is it clear? We'll find a new mid and we'll put the mid pointer there. Now again, we'll try to search for -5. Now if array of M is greater than k. Sorry, last time our array was greater, right? So we had a 0 there, and 0 is greater than -5. So this was the case. So we make the end equal to m minus 1. Now if our array index m, so the element as index m is less than k. If it is less than k, then what do we do? We make the beginning equal to mid plus 1. So if our element on this particular index m is smaller than the number that we are searching for, we take the beginning and transfer it to m plus 1. We make it equal to m plus 1. Okay. Then we calculate the new mid. So now we'll again use this particular formula, and our new mid will be 1 plus 1 by 2. This will be 2 by 2 or 1. Now the third and final condition that we have to create, array of m equal to k. Just return index m. Right, so we have successfully found out our number that was to be searched. So just a second. Yeah, we'll take an example: 5, 10, 15, 20, 25. Okay, so we have these numbers with us, and let's say we have to find this number 10. We are searching for 10. The algorithm that we are using is, this is the beginning, this is the end. Basically, beginning is equal to 0, end is equal to length of the array minus 1, right? So there are just 3 rules that we have to follow. Rule number 1, if array of m is less than k, right? So what do we do? If the midpoint, if the value at midpoint is less than k, so the number would be in the next half, second half. So in this case, we'll make beginning equal to m plus 1. So we'll just apply these rules in this example and see. Okay, don't worry. You don't have to memorize anything. It will become very obvious. If array of m is greater than k, if the element at index m is greater than the number to be searched for, then we make end equal to m minus 1. Okay, mid minus 1. Third case, if array of m is equal to k, we return the midpoint. So let's apply these rules. Okay, so firstly, we'll calculate a midpoint. We have beginning, mid, and end. Beginning is equal to 0. Let's write the indices. Okay, beginning equal to 0, end equal to 4. So the value of m would be 2. Correct. So we'll search here. So is 15 less than k, or 15 is greater than k, or 15 is equal to k? Less than, greater than, or equal to? Like case 1, 2, or 3. All right, so this is case number 2. Why? Because 15 is greater than 10. So we make end equal to m minus 1. So we take this m, we take this e, and make it equal to m minus 1. So end now becomes 1. Beginning is 0. What is the new mid? We use the floor function. So 0 plus 1 by 2 is not equal to 1, it is equal to 0. Right? So mid becomes 0. Okay. So we take the mid and put it at 0. Now, which case is it? 1, 2, or 3? 5 is less than 10, greater than 10, or equal to 10. Third case. Third case, is 5 equal to 10?
Let's have a quick quiz question, guys, and the question is, which of the following is not an NP-hard problem? And your options are vertex cover problem, 0/1 knapsack problem, maximal independent set problem, or traveling salesman problem? Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ENICT IIT Guwahati. The course link of which is given in the description below. Now let's continue with the session.
Yes, it is the first case because 5 is less than 10. So 5 is less than 10, so it is the first case. So what do we do in the first case? We make beginning equal to m plus 1. So we delete this beginning part and make it equal to m plus 1. Right? So beginning becomes 0, end becomes 0. What is the value of mid now? So 1 plus 1 upon 2 is equal to 1. Okay, so it is 1. Now mid also becomes 1. So now which case is it? So it is the third case, and we return the value of m. So we return 1. So is 10 at index 1? So we have found out the index where 10 was. So there are two things that we have to compare. Okay. So the first thing we did was called as linear search. Okay, we were linearly going from the left end to the right end, one by one, and checking if the number is equal to the number that has to be searched for. As simple as that, the most basic type of search. Second thing we did was binary search. So the first point that we have to look at is, can be applied on any array. Here, binary search can only be applied to sorted arrays. Okay. Second, time complexity is O of n. We are traversing the whole array, so time complexity becomes O of n, right? Okay, so this is called a log n time complexity. Why is it a log n time complexity? Log base 2. Basically, we are every time discarding half the numbers. So in how much time we can discard all the numbers? In the first case, we are discarding half. Again, half of what is left, right? So if we say, let's say we have 8 numbers. In the first go, we discard 4 numbers. In the second go, we discard 2 numbers. In the last, we discard 1 number, right? So it is like a power of 2. So if it is 2 to the power 3, we're discarding all the numbers in 3 goes. If it is 2 to the power 10, we're discarding all the numbers in 10 go, right? So if it is 1024, next time we'll have 512 numbers, then we have 256 numbers, then 128 numbers, 64, 32, 16, 8, 4, 2, and 1. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In 10 times, we can discard all the elements in the array. So this is called the binary search. So we have understood the concept of linear search. We have understood the concept of binary search. Now we will try to code it once, okay? So that we are very certain that we have completely understood it. Okay. So the first thing that we'll code is the linear search, okay? Simple. So let's take an array. Okay, we are taking an array. Let's put some random numbers into it. Okay, let's also put some negative numbers into it. Okay, let's search for 7. Okay, so we'll just loop through the array once. Okay, so while looping through the array, we check if ARR of I is equal to the number that we want to search. If it is equal, we'll simply print out that index and we return. So return basically closes the code. So when we have found the index, we'll just print that and return. Okay. If we come out of this for loop, we just print cannot, or we just print -1. Okay. Let's say -1 is code for not being able to find a particular number. So when we haven't found any number, it will print -1. If we have actually found the particular number, we will print that index and close the code, right? So let us run this. So 7 is at index 5. So index 0, 1, 2, 3, 4, 5. Okay, so the question is just find one of the indices where that particular number is. Okay, we are considering arrays with all different numbers right now. So that won't be a problem. So now let us take a number that is not in the array. Let's rerun this code. So we can see it has printed -1 because the 0 is not in the array that we have considered. Okay, so very good. So this is the code for linear search. So the next thing that we'll do is called the binary search. Yeah, we'll see the code for binary search now. Let's try to create a code for that. So we'll delete this code. Now we'll make code for binary search. Okay, so first of all, we'll take an array. Now the array has to be sorted, otherwise we can't take it, right? So 2, 4, 6, 8, 10, 12, 14. Okay, let's take a few negative numbers as well. 6, 4, -2, 0. All right, let's search for 4. So now what we'll do is we'll take 3 integers like we took in the algorithm. One will be called the beginning. It will start from 0. E will start from length -1 and mid. Okay. This is what we were doing in the while we were running it on the whiteboard as well, right? We were taking these 3 integers. Now, for how long do we actually run this particular loop? We use a while loop here. Now we run it till beginning is less than end. Okay. While beginning is less than end, we have a range. If beginning is greater than end, we don't have a range, right? If we are talking about a range, beginning needs to be less than end. Only then we'll have a range to consider. If beginning is greater than end, then we don't have a range to consider. Now we'll calculate the midpoint like we were doing. We'll use the same formula here. Begin plus end upon. Okay, so we have calculated the value of m. Now what do we do with this m? We create the 3 test cases that we like, 3 possibilities we considered, right? And else. So the first possibility was array. Sorry, what is the name of our array? ARR, small. Okay. Array of midpoint is less than k. Array of midpoint is greater than k. Right. So when it is less than k, what do we do? When array of m is less than k, what do we do? And equal to m plus 1. If our starting number is -6, ending is 14, midpoint is on 4, and we have to search for -2. Sorry, we have to search for 10. What do? We make the beginning equal to m plus 1. The previous half is discarded, right? So we make the beginning equal to mid plus 1. Now if array of m is greater than k, what do we do? If the current element that we are looking at is greater than the number that we have to search, so the next part, the latter part, is discarded. So e becomes m minus 1. So now we'll make the e equal to m minus 1. Great. Okay. Now, if it is not less than k, if it is not greater than k, else will mean that it is equal to k. So we'll return the value of m. Okay, so basically this is a void function. So we'll print the value of m and return. If we come out of this loop, that means that we were not able to find that particular number, and we'll print a -1. Okay, so if you think this code will work, type work. If you think there is a mistake, type it won't work. All right, if b is equal to e, what happens is midpoint is also equal to like b or e. Then if it is not equal, then either b becomes e plus 1 or e becomes b minus 1 and the code closes. Uh, so like we saw in the example as well, if b actually becomes equal to e, then midpoint is also equal to them. Then if the number is there, then that point is returned. Okay, cool. So let's just run this. So 4 is at index 5. So this is index 0, 1, 2, 3, 4, and 5. Okay, let's search some other number. Let's search for 10. We have 10 here. We have 10 at index 8. Okay. Let's search for a number that is not there. Let's search for -100. So we have got -1. That means -100 is not in the array. Okay, so this is the binary search, right? Let us now see a few use cases where we use binary search. Okay, so let's say we have a sorted array with repeating numbers. Okay, so let's say our array looks something like this: 2, 3, 4, 4, 4, 5, 6, 7, 8. Okay, so how do we find the first occurrence of a particular number? Let's say we have to find the first occurrence of a particular number. If we are giving 4, we want to find this index: 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So we want to return 2 specifically. We don't want to return 3 or 4. We have to return 2. How do we do that? It is very similar to binary search. I mean, just 1 or 2 changes here and there, and we'll get there. That we do a normal binary search until we find one of the 4s. Okay. So we put the beginning here, we put the end here. What would be the value of mid? Beginning plus end by 2. 0 plus 8 by 2. 4. Right. So at index 4, we have a 4. Now, after we have found any of the 4s, we do a linear search backwards. We go back linearly. Is this equal to 4? Yes. Is this equal to 4? Yes. Is this equal to 4? No. So this was the first 4 in the array. So we return 2. So the problem is the time complexity for this approach is also O of n. Why? Let's say we have an array with all 2s. Right. So in this case, let's say this is the midpoint. After that, we'll have to go for n by 2 elements backwards. Right. So the time complexity is O of n. So it would be better if we do a simple linear search instead. Right. It would be simpler to code. Search here. Is it a 4? No. Go here. Is it a 4? No. This is a 4. So obviously this is the first 4. So return index 2. Right. A normal linear search and this binary plus linear search has the same time complexity, have the same worst case time complexity. All right. So now I'll tell the approach. Okay. So let's take an example. 2, 2, 2, 3, 3, 4, 4, 4, 5, 5, 6. Okay. Now let us search. Let's search for 3. So let's write the indices. 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So let's give the values of beginning, mid, and end. Beginning is 0, end is 10. So this is our mid. Now mid is basically array of mid is basically greater than k. What do we do in this case? We make e equal to m minus 1. Right? So e now becomes 4. Beginning stays at 0. Mid becomes, what is the value of mid now? Updated value 2. Very good. This becomes 2. This is mid. Okay. So now array of mid is basically equal to 2, and that is less than k. In this case, we make b equal to m plus 1. Okay. So b equal to m plus 1. What is the new value of b? So b becomes 3, e becomes 4. What is the value of mid now? 3 plus 4 by 2 is also equal to 3. Okay. So mid becomes 3. So now we check. Now we see that it is equal to our value k. But now we don't return m straight away. What we do is we check if array of m minus 1 is also equal to k, we make e equal to m minus 1. Else we return m. So basically, in this case, we couldn't actually apply this thing. So let's take a very small but other example, right? Where we can actually apply this algorithm. Second, just scroll down. Like 2, 2, 2, 3, 3, 3. 0, 1, 2, 3, 4, and 5. Beginning, end, and we are searching for 2 here, okay? So 0 plus 5 by 2 is actually 2. So this array of k, array of m is equal to k. So we check if array of m minus 1 is equal to k or not. So this is also equal to 2, right? So we make end equal to m minus 1. So end comes here. Now we again calculate m. Now m is equal to 0, right? 0 plus 1 by 2. Now m is again equal to k because m minus 1 does not exist anymore because m is equal to 0. So you can't do a m minus 1. So now we return 0. When m was equal to k, array of m was equal to k, we did not return it simply. We again check the previous index. I'll just take the pencil again. Beginning, end. What is the value of mid? beginning plus end by 2, 0 plus 5 by 2. Now array. Now this is the case. This is the case, right? Array of m is equal to k. What do we do? If array of m minus 1 is equal to k, then we do e equal to m minus 1. If array of m minus 1 is equal to k, yes, it is equal to k, we do e equal to m minus 1. So e comes here. Now again, what is the new value of m? Beginning plus end by 2, 0 plus 1 by 2, so it is 0. Now array of k is again equal to k, right? Now m minus 1 does not exist. It doesn't exist. There is nothing at index minus 1. So we simply return m. So we return 0 here. All right. So let's try to code this algorithm now. So we have to find the first index in an array with repeating numbers. Let us take the array first. Okay. So let's take an array 2, 2, 2, 4, 4, 4, 6, 6, 6, 6, 8, 8. We'll go for 6. Now we'll take the 3 integers. Beginning, end, beginning equal to 0, end equal to array dot length minus 1 and mid. How long do we run this loop? While beginning is less than ending. Now we calculate our mid, p plus e by 2. Okay, this is how we were, sorry, this is comma. This is how we were calculating our mid, right? So this is same as binary search. Till now we are doing everything same to binary search, exactly same. Till now everything is exactly same. Now again we'll create the 3 cases, right? Because that much is also same. We'll just change a few things in the else. Nothing very difficult. Okay. Now array of m is less than k. So b is equal to m plus 1. Okay. Great. Now if array of m is greater than k, e equal to m minus 1. Awesome. Now in else, we have already seen the pseudo code. Now if m is equal to 0, if m is the starting, if m minus 1 doesn't exist, we simply print m. Okay, and return. Otherwise, if array of m minus 1 is also equal to k, else if it is not, m minus 1 is not equal to k, then we simply print m and return. If we have come out of this particular for loop, while loop, where does it end? It ends here. We print minus 1. Now let us try to run this particular code. So the answer is 6. 0, 1, 2, 3, 4, 5, 6. So the first 6 is by chance at index 6. Let's try to search for 4. Okay. So 4 is at index 3. 0 index, 1 index, 2 index, and 3 index. Let's try to search for 7 because 7 is not there. Minus 1, so 7 is not there. The code is running, right? So these are the only 2 types of searching that we have. Okay. There's a linear search, there's a binary search. Linear search can be applied to any array, whether sorted or unsorted, but it takes a little more time, that is O of n. Binary search has a limitation that it can only be applied to sorted arrays, but it is giving you a better time complexity of O of log base to n. All right, and we also saw why we are doing this log base to n, because every time we are removing half the numbers. Okay. So now the next thing that we have to learn is, so basically searching is done. Searching is over. Next thing that we have to learn is called sorting. Okay, so the next thing that we want to look at is sorting. Let's take an array. Okay, let's put numbers into it randomly. So how will you sort it? So the most basic approach that comes to our mind if we are actually sorting these things is we create another space, like an empty space. Okay, we take the smallest number. We check which is the smallest number. We remove that number from here, add it here. We again check what is the smallest number. We take it out of here, put it here. Again, we do the same thing. We keep doing it repeatedly. 6, 8, and 10. Is this how you'll do it? In normal life, this is how we'll do it if we don't have a computer. Take the smallest number, put it here. Second smallest number, put it here, and so on. So the problem is, how much time did it take? So basically, there are n numbers. And to find the smallest number, we have to traverse the whole array. So to find the minimum number, we take O of n time, right? And we have to do this n time because once we traverse the array, we are only able to place one number in the correct position. So n into n will become O of n square. That this is a O of n square approach. Yes. So this is very high time complexity. Another problem, space. We have created another array. So space complexity is also O of n. The size of the array is n. So space complexity is also O of n. So time and space complexities are high in this. Let us study one algorithm. So basically, okay, so I'll explain that with an example. We have a bucket of water. Okay, it is completely filled with water. All right, let's make the water in blue color. We have very pure water. It's completely blue. Okay, let's say there are two bubbles. We make two bubbles. One is a big bubble, other is a small bubble. This is big bubble, this is small bubble. So buoyancy basically means that the upward force generated is directly proportional to the volume of water displaced. Okay, upward thrust is directly proportional to water displaced. B is displacing more water, so there would be more upward thrust for this bubble. Okay, so this will reach the surface before S. B will reach the surface before S. So now I have also taught you buoyancy, right? This is also a physics class now. So this is called as bubble sort. Why is it called a bubble sort? I'll show you. If we have water in a beaker and there are different sizes of bubbles. Let's take 4 bubbles. Size is 4, 3, 2, and 1. So after some time, when bubble number 4 reaches the top, okay, when bubble number 4 reaches the top, so each bubble will create a different thrust because their sizes are different. When bubble number 4 reaches the top, bubble number 3 would be somewhere here, 2 would be somewhere here, and 1 would be somewhere here. If we take this snapshot, if we take a picture of this thing, is it sorted? Did it get automatically sorted? Yes. What we'll do is let's take an array. 2, 3, 4. Sorry, let's take an unsorted array. 4, 2, 3, 1, 5, 0. Okay. So now what we'll do is we'll take 2 pointers. Okay. So now if 4 is greater than 2, 4 and 2 will be swapped. If this is pointer A, this is pointer B. If number at pointer A is greater than number at pointer B, swap their values. Otherwise, do nothing. So if A is greater than B, swap the value. So this becomes 2, this becomes 4. So basically, bubble number A was larger than bubble number 2. So it has come to the top. Next, we move A and B by one number. Basically, we move them one place forward. So I'll again take the pencil. A, B. Now again, if A is greater than B, A comes forward, B go, we swap A and B. So we again swap. This becomes 4, this becomes 3. Now we move A and B one step forward. This becomes A, this becomes B. Now 4 is greater than 1, right? 4 is greater than 1. So we'll again swap. This becomes 4, this becomes 1. Now we again move A and B forward. So we don't do anything, we just move A and B forward, we do not swap. So this becomes A, this becomes B. Is 5 greater than 0? Yes. So now these get swapped. So after one iteration, the last number, the largest bubble, is at the correct position. I'll repeat this sentence. After one iteration, the largest bubble comes at the top. The largest bubble has reached the surface. The rest of the array is not yet sorted, but the largest bubble has reached the surface. So one bubble we have taken to the top. So after the first iteration, the array has become something like this. 2, 3, 4, sorry, 2, 3, 1, 4, 0, and 5. Now we will again do the same thing. And the second largest bubble will reach the top. I'll just show you. This is A, this is B. Do we swap? We don't swap. A, B. Yes, we swap. 1, 3. A and B, do we swap? No, we don't swap. No swapping. A and B, do we swap? Yes, we will have to swap. So I'll swap these. We'll end this here. Why? Because the last number is already in the correct position. So we'll just end it here. We won't move forward. Okay, we'll simply end it here. So now you can see that the second last bubble is also in the correct position. So we have to do these iterations n times because every time one bubble gets at the correct place. And the time complexity for one iteration is n. The time complexity for this approach comes out to be O of n squared. So now one type of question that we solve with this is, let's say we have a very large array, 2, 6, 3, 1, -8, 10, 100, whatever. If we have to find the, listen to it very carefully. If we have to find the fifth largest element in this array, fifth largest element, run it only 5 times. So this is the most optimized way of finding the nth largest number. Okay, So if we want to find the fifth largest number, we run this algorithm 5 times, and from the back, we take the 1, 2, 3, 4 fifth element, whatever will be here after 5 iterations, that will be the fifth largest element. So this is what your bubble sort is basically for. Okay. So we have seen two types of searching and we have seen one type of sorting.
Let's have a quick quiz question, guys. And the question is, which of the following are string and pattern matching algorithm? And your options are Z algorithm, Rabin-Karp algorithm, KMP algorithm, or all of the above. Please mention your answers in the comment section below.
We present to you the top 50 data structure interview questions that you can use to ace all of the interviews and to help you land your dream job. This is a compilation of questions which have the highest amount of probability to be asked in any data structures interview. So even if you're a beginner, an intermediate person, or an advanced learner, we are sure that you can take away an ample amount of information from this video. Well, before we begin with the session, make sure to subscribe to the Intellipaat's YouTube channel and hit that bell icon so that you don't miss any updates from us. With that, let us move to the first question. Of course, the first question will be, what are data structures? Well, data structures are actually methods and techniques which are used to handle and store data in an organized manner. Well, basically, when answering this question, make sure not only to explain about all of the data structures that are present, such as linked lists, stacks, arrays, and whatnot, but make sure that you have an understanding of what data structures are. Basically, all of these data structures are used to attain a common goal, that is to either build dependency in terms of data entities, to build and manage relationships between the data entities, or to even produce meaningful connections in between data. So basically, these are the entities, methods, and techniques which are used to store data in an organized manner. Well, coming to question number 2. What is the difference between a file structure and a data structure? Well, a file structure is an entity which gets stored only on the hard disk drive or only on the local storage. But then when you're talking about data structures have the ability to natively be stored both on the RAM, that is the random access memory, and the hard disk at the same time. Then coming to the second point, there are certain policies which guide the storage of data. So with respect to file structures, we have the standard file storage policies which works across based on the operating systems and how the data is supposed to be stored. But then when we work with data structures, there are customized storage policies which make the use of data structures very efficient and increases the read-write capability, where you can access it faster, read the data faster, and write it faster as well. And then coming to the third point basically talks about the compatibility when you're working with external applications. There is a low compatibility when you work with file structures because of point number 2, one being it has standard file storage policies, and the second thing being that so most of the applications are basically written based on the individual unit entities whenever data is in concern. So whenever data is supposed to be stored, each individual entity of data is actually in concern when developing policies and compatibility whenever you're storing with external applications, because this unit entity that we just spoke about is basically already optimized in this particular case. That brings us to question number 3. What is a linked list? Well, this has to be one of the questions that will surely be asked, because linked lists form a very vital aspect of data structures, and linked lists are nothing but the most used data structures in today's world, because these form very nice methodologies and these provide very nice ways the user can store and handle data, where every individual element in a linked list is called as a node, and each of these nodes form a chain-like structure whenever you connect it to other nodes. Each node will have the data present to it and a certain address associated with it. This address is used to basically access the data, and then of course the data can be changed however required. There are many types of linked lists. There are single linked lists, there's double linked list, there's circular linked list, and more. And with that, we have question number 4. Well, where are data structures primarily used? you can answer this question based on multiple factors. One being that you can find data structures almost everywhere around you in the world. Data structures are an integral part of almost everything with respect to information technology. Everything from numerical computation, operating system design, artificial intelligence, compiler design, all the way until statistics. Data structures pave to be one of the foundational concepts which are very much required in today's world to handle data and to find the most efficient way and the easiest way to do it. See, at the end of the day, you're converting raw data into useful information. Finding the most effective way to do that in a structured environment is where data structures shine the most. So make sure to quote at least 4 or 5 places and concepts where data structures are used, and it would of course be advantageous if you could explain on where it is used. For example, if you're talking about data structures are used in database handling, just don't state database handling. Just go on to explain 1 or 2 lines where you're stating that they are used to form entities such as linked lists. It can be stacks and queues, and these stacks and queues provide a way to have organized access to data. So make sure to elaborate a single point based on the usage that you have mentioned. Coming to question number 5, what are the types of searching methodologies used in data structures? Well, there's two main types of searching whenever you talk about data structures. It's linear search and it's binary search. Linear search, as the name suggests, is basically moving across the data in a linear fashion. Linear fashion basically means one after the other in a certain order. When you talk about binary search is a better form of searching because it's more efficient, number one. Number two is that it splits the data in the middle, and then it just forms two entities where it can search on the left side of that and on the right side of the data if the number is lesser or greater respectively. More on binary search in the next couple of questions, but then at this point of time you need to know that there are two types of searching, linear and binary, where linear is a simple form of searching in a set order, either from left to right or right to left, and binary search involves breaking the data into smaller chunks, searching in that, break it again if required, and search, and this can be performed many number of times. Coming to question number 6, how does binary search work? Yes, this would be a very important question which has a very high probability of being asked. Well, binary search, as the name suggests, it's two entities. The first thing you have to always remember when you work with binary search is that it will only work on sorted data. Well, your data either has to be sorted in the ascending order or the descending order compulsorily. And once you have the ordered data, basically you have an array. Let's say you have an array. And basically, if you have to search an element in this particular array, the first thing you'll do is you'll find the middle element of it. If it's an even number, your middle number will be considered as the average of those two numbers. But then if you have an odd number, you will find one singular middle element. So then the data is basically split into the left side and the right side. Now, if you arranged it in the ascending order, let's say we have top 7 elements, 1, 2, 3, 4, 5, 6, 7. 4 will be the middle element, right? So if you're searching for 3, then of course you already know that you don't have to search up and above 4 because it won't be there. Your data is already in the ascending order, so you'll of course search below 4. Then again you will split it into 1, 2, 3, 4, where 1 and 2 can be put into one side, 3 and 4 can be put into the other side, and search. So this goes on in an iterative order. It's basically all dependent on the order of arrangement and what value you are searching for. Binary search is really simple to implement, considering that you know how the process of iteration works and how it can be put into effective use. Coming to question number 7, how are individual elements accessed in an array? Well, whenever you talk about arrays, there is a concept called as indexing. Indexing is basically denoting the position of elements in an array. And whenever you talk about arrays, and in majority of the programming languages out there, the first position will always begin with 0 rather than 1. So if you have an array size of say 10 elements, the last element will not be 10, it will be 9, because if n is the number of elements in the array, then the last element is n minus 1. It is n minus 1 because we are starting from 0 and not from n. And then whenever you talk about indexing, you can access any element that you desire from this array at any point of time. If you want the sixth element, let's say you have an array which is of the name A, and you want the fifth element to it. If you want the fifth element of array A, you'll be accessing A of 4. A of 4 because A of 0 is the first one, A of 1 is the second one, A of 2 is the third one, and all the way until A of 4, which becomes the fifth element basically. So yes, individual elements can be accessed. And when you talk about multidimensional arrays are basically spanned across rows and columns and more. So a row entity will have a separate index, a column entity will have a separate index. So when you have these two indices mapped side by side together, A of 2 comma 3, or A of course it'll be in brackets, A of brackets 2 big brackets 3, this will denote a specific element, say in that particular column and in the particular row in discussion as well. So I hope I was clear with that. Now coming to question number 8. Question number 8 says, what is a queue in data structures? Well, a queue is one of the most used data structures, in fact in real life as well. So the data structure entity such as queue was basically based on the real life fact that we use queues everywhere. So whenever we talk about queues as a data structures, you need to understand that it is all about accessing something in order, adding an element to an array in order, or removal. So order is everything when we talk about queues, because as a literal queue, let's say whenever you go to the shopping mart or to pick up anything, you get in from one direction, you pick up something, there are people behind you, and you get away from the front of the queue, right? So basically that it's basically first come first served. If you're first in the queue, you are served and you are sent off. If you're last in the queue, then you have to work your way towards the front end and basically get your order done, right? So that's exactly how queues work here as well. Of course, whenever we talk about queues in literal, there's elements such as the top element, there's the front element where the data exits, the top element is where the data comes in, and much more. Of course, you can choose to write a tiny piece of code which will denote an array and how a queue can be implemented as well. This will effectively improve your candidature there too, and of course it will impress the hiring manager as well. Coming to question number 9, what is a binary tree? A binary tree, as the name suggests, it's basically a tree-like structure which has one primary node, and then this primary node or the main node, or it's called as a root node as well. So this root node is split into two nodes, and one is on the left and one is on the right. Hence it's binary. Every single element here will have entities which are on the left and on the right, and each single node can have only two other nodes as well, and these two nodes of course can have two more nodes, and it will go on exponentially. But then a binary tree will consist of two nodes left and right to the root node. And of course, if you're wondering where binary trees are used, or if you're wondering why is a binary tree required when we have something such as a linked list, understand that binary trees provide an ample number of advantages whenever you're using a linked list. And of course, it is considered as an extended linked list for the same reason as well. Now coming to question number 10, what is the meaning of a stack? A stack is literally, again, as the name suggests, like a stack of books or a stack of cards. This is another data structure which has been implemented based on real life implementation. So whenever you're working with queues, you have to understand the data can exit, enter, and do anything it wants in both of the directions, left and right, front and back. When you're working with a stack, data can only be worked within one point of time. For example, if you're placing 10 books on your table right now, to linearly and easily pick up a book, it can only be done from the top element. Of course, you can slide your hand under and pick up any number of books you want as well, but that is not the concept here. The concept here is that to easily able to lift without disturbing other books. So in that particular case, you can only lift the top one, and once that's gone, you can pick up the next one, right? So if you think about putting the books in order, if you put book number 1, it will be at the bottommost, 2 is on it, 3 is on 2, 4 is on 3, and so much more. So if you have to delete an element, you have to pick up the 10th book first. The last book which went in is the first book that comes out. Again, we're going to discuss this concept in the next couple of questions. And with this, pretty much stack implementation is again very easy, and of course we'll be looking at that in detail as well. Now coming to the thing that we were talking about, question number 11 states, what is the working of LIFO? Well, LIFO, as you can look at it, is an acronym which stands for last in, first out. LIFO is basically telling the user or giving guidelines on how data is accessed and worked on. Because whenever you think about LIFO, think about two data elements and compare it. If you put in something, it means that if it goes in at the last, it's the first one to come out. Well, now this sounds very similar to question number 10, right? Because in a stack of books, the last entity is the first one to come out. Of course, LIFO is the governing principle of how a stack works as well. If an element is pushed in at the last, it's the first one to come out. And of course, if you have a requirement where you want to get the first element stored, then you have to retrieve all of the above ones, and then only the last one, which is literally the first one, will come out. And with that, we move to question number 12. Question number 12 states, what are multidimensional arrays? As we discussed, multidimensional arrays are these arrays which span in more than one single direction, more than one single dimension. It will have a specific set of rows and specific set of columns, just like a matrix in real world. And with this comes more than one index variable, because one index variable is for the rows, one index variable is for the columns, and more. So the interviewer might ask, saying, why do we require multidimensional arrays? Well, one good reason of why you would require multidimensional arrays is when you cannot represent an entity in just one dimension. See, whenever you talk about, let's say, GPS coordinates, latitudes and longitudes, as you might have studied in your college or school days, whenever someone asks for a location, an exact numerical location, you cannot just provide the longitude and say, I am here. You'll have to provide a latitude and a longitude to represent your position as well. So these two entities cannot be split into two data steps, right? To bring it together into one is again a very, very good example of a two-dimensional array. And now coming to question number 13. Question number 13 is again asked a lot, so pay attention. It says, are linked lists linear or non-linear data structures? Well, the answer is it's best of both worlds here, because it primarily depends on how you're using what the storage policies are. See, it can work in a linear fashion as well, in an ordered data set or in an ordered fashion. And of course, it can work in the non-linear structure where, position can be picked up, random data can be picked up based on where it is, what are the strategies that are put into retrieving the data. And basically, this is what forms to give it that linear behavior, as the name suggests. So yes, whenever you ask this question, so make sure to tell them that it can be used both as a linear data structures and as a non-linear data structure as well. With that, we come to question number 14. Question number 14 asks, what is a binary search tree? We saw what a binary tree was. Well, what is binary search tree? Well, again, just like a binary tree, it consists of two primary nodes from the root node. So one root node where one of the child nodes is on the left and one of the child nodes is on the right. But if you're talking about binary search tree, and since the data is always numerical whenever we work with trees, the value in the left structure of the tree will always have to be less than the root node, and values on the right side of the root node will always have to be greater than the root node itself. This is one important thing that makes a binary search tree what it is. Let's say if you have 5 as the root node, elements between 1 and 4 will compulsorily be on the left subtree, and elements 5 and above will be compulsorily on the right subtree. And then again, in another step where you're breaking the tree into further subtrees, the same rule applies. The primary root node of that little subtree that we're talking about should have values which are greater than the left subtree and less than the right subtree as well. And this is how the entire tree can be generated. With this, we come to question number 15. What is the meaning of FIFO? We saw LIFO, right? Last in, first out. FIFO is basically first in, first out. First in, first out is how queues work in real life. You go first in, you're served first, and then you are outside first, right? So you're first in, processed first, and you're outside first. Well, remember it like that. If you're ever confused between what LIFO stands for or where LIFO is used, FIFO is used, and please do not mug up this concept. It's pretty easy to remember. If you go first in a queue, you're served first. Think of FIFO, think of queue. And then if you put 10 books on the top, the last book you put as the first one you'll remove. Hence LIFO, last in, first out. Right. So coming back to FIFO, FIFO is basically, again, just as I mentioned, you'll be served first based on the order. And it's pretty much as simple and as straightforward as that, right? And you can, of course, take a real life example to show the interviewer that your understanding on the concept of FIFO is concrete. Now, coming to question number 16. What is the difference between void and null in data structures? Well, both of these sound very similar, right? Void is like, deficient of something, and null says nothing. So basically there is a small difference. Whenever you talk about void basically says that whenever there is a certain data which has been declared, let's say a variable has been declared, but then if it does not have any value associated with that while initializing, it means that there is no size. It means void in computer science terms. Now when we talk about null is actually a value. It is a value which has no physical presence on the memory, but then it's saying a particular state of that element or of that data structure at that given point of time. Void says that there is no size involved, but then null says that hey, I am a value, I have no physical presence, but I denote something. This is the very simple difference between void and null. Coming to question number 17. Question number 17 states, what is dynamic memory management? Well, dynamic memory management is a way, it's a methodology where, all of the storage units which are basically used to store your data changes. What I mean by this is that, as the name suggests, since it's dynamic, memory is basically managed as and when the data occurs. See, if you buy a hard drive worth 1 terabyte, but then if you only store data worth 1 gigabyte, it won't make sense. Now, if you have to store 1 terabyte, but then you have a hard drive worth 1 gigabyte, it's impossible, right? But then if you could find out what your data size is, and if you could go on to match and store the data into the hard drive one element after another, where let's say size is unlimited in both of the cases, this is exactly how dynamic memory management will work. Each of these entities gets separated or combined to eventually be stored, and whenever you separate it or combine it, they form entities called as composites, and these composites are used as entities to be stored on the final data drive as well. And these composites basically change in case if your data is changing, so make sure you mention that. Now coming to question number 18. Question number 18 is of course the most asked question in all of data structures interviews. What are push and pop operations in data structures? Well, a push operation is when you add an element into the data structure. A pop element is when you remove an element from the data structure. So whenever you think of push, think of it that you're pushing an object into something else, and whenever you're pulling, you're removing one from the other. This is the most simplest way that I used to remember push and pop operations way back in the day. So whenever you think push, think of adding elements. Whenever you think of pop operation, make sure that you're thinking about removal of data from the data structure. It is as simple and straightforward as this. Coming to question number 19. How is a variable stored in memory when one is using data structures? Well, see, whenever a variable has to be stored in memory, you have to understand the value that is associated with the variable and how much of space is required to actually manage the memory for that particular entity. So whenever your quantity of memory is assigned, say, I need 10 bytes of data to store this value. Well, firstly, it depends on the data structure that's being used. And the second thing, now whenever you're using dynamic allocation, what basically happens is that it understands and knows that 10 kilobytes might not be the only size that the variable will have. It can have 10, it can have 100, it can become 1 gigabyte in 10 seconds and much more. So a dynamic allocation will ensure that it will provide ample number of space and it will provide the extra legroom which is required to store this variable. And in fact, even if there are rapid changes in the size of the variables, that it can be stored very well in an effective and an efficient way, as we discussed in the previous couple of questions as well. So make sure to mention that too. This brings us to question number 20. Question number 20 states, what is merge sort? Well, as the name suggests, you might guess that since it has the word sort, it has to do something with sorting elements in a certain order. Merge sort is one of the popular methods used to sort elements whenever you have a linear data structure. Now, let's say you have an array where you want to perform merge sort on it. The main working of merge sort is this divide and conquer approach. This is one very important thing that it'll add a lot to your candidacy if you mention. It's the divide and conquer approach. So basically, each of the entities in a merge sort will be adjacent to each other, right? So the elements will be next to each other, and these entities will get merged together, and these tiny mergings or these tiny entities which are formed after merging will be sorted. And then these sorted lists are kept aside. Another couple of elements are taken. These elements are again sorted and then put to the left. Think of it like taking a chunk of colored rubber bands and then sorting each of these color rubber bands into their final color and then putting it aside into separate units. Well, that is how merge sort works as well. You merge a certain set of elements, you sort it out, you put it to the left. You take in more, merge it out, sort it and put it to the left. And now when you combine the entire thing, everything from the left to the right will have been sorted because you took individual elements and sorted it, right? That is how merge sort works. And now coming to question number 21, why should heap be used over a stack? Well, heap is another wonderful data structure which is very helpful whenever you are working with data structures because it provides the user with an efficient way to work with. Again, when we talk about data structures, when we talk about efficiency, you might be wondering, is this have to do something with dynamic memory allocation? Yes, heaps are data structures which are basically used whenever you have the data which requires a dynamic memory allocation requirement, and where the data is removed and added as per the requirement as well. So the access times and the storage methodologies, the policies and whatever govern heaps in the back end of it, which of course you should not be concerned with at this point of time, makes it very effective. It makes it very efficient to use, whenever you compare it to a stack. But then with the extra added dynamism, with the extra added efficiency in read-write speeds, if you directly compare it to a simple stack, the memory time is actually a bit slow. Why is this a bit slow? Because you have to have all of these things working in the back end to make sure that dynamism is maintained. It is efficient, no wonder. A complex heap will be efficient when you compare it to a simple stack. But then if you're very hardcore about time complexity, then of course a simple stack will win. So make sure to mention that as well. Coming to question number 22. What is the meaning of data abstraction? Well, data abstraction is it's a tool, it's a concept which is widely used in data structures. Data abstraction is a concept of simply breaking down complex entities into smaller problems, then solve each of these smaller problems, and then eventually you will have solution to the entire problem. So this approach, this tool, this technique is called as data abstraction, where you take a complex entity, you break it down into simpler steps, and further you can break down those simpler steps into even more simpler steps to work with. So it is in the similar working analogy as a tree data structure. You have one entity, you break it down into two, you break the two into four, and much more, right? So think of it like that. Coming to question number 23. What is the meaning of a postfix expression in data structures? Well. Postfix, prefix, and in order traversals are very important questions which are asked in data structures interviews. So make sure you understand each of these. Coming to postfix expressions first, where postfix expression is a situation where each of the operator that you have, whatever operation you're performing on, operator plus, minus, multiplication, division, whatever it is, this is basically preceded by its operands. Operands are the numbers which you're working with. So why we use prefix, postfix is to basically ensure, we have to remove all of the parentheses or to remove any sub-expressions wherever you're working with operators, because this forms a very vital thing. Number one, with operator precedence. Number two, if you're performing any sort of lexical analysis, you're working with postfix and prefix expressions will add a lot of value there as well. So with that, question number 24 is again another very high probable question. What is the working of selection sort? Well, selection sort, as the name suggests, is another way of how you can sort the data. Selection sort is very simple. Let's begin directly by understanding how it works. So whenever you're working with selection sort, let's say if you're working in the ascending order, it will directly select the smallest entity first inside the entire array after traversing it once, and it will make sure to set the index of that to 0. So what happens is, as soon as that is done, this element will be compulsorily the first element. Next, it finds the next smallest element, puts it on the right of the first one. Next, again, look at the entire thing, find the smallest one, put it in its final place. iterate through the entire thing, find the next smaller one, put it into its final place. So basically, by iterating through the entire array, you will be putting the element directly into its final position by putting an index value to that. This is what is the simple working of a selection sort. And of course, that is done until all of the elements are sorted. Now coming to question number 25. What are signed numbers in data structures? Well, signed numbers, again, pretty simple. As the name suggests, it is numbers which will have a bit in the beginning, which will basically denote if the number is a positive number or a negative number. This bit that we're talking about, it is called as a sign bit. And since we're talking about binary, if the signed bit is 1, it means that the number is negative in terms of binary. And if we talk about the signed bit being 0, it means that whatever number you're working with is a positive number. So if the signed bit is 1, it indicates the number is a negative number and the presence of a negative sign. If the signed bit is 0, it indicates the presence of a positive sign. And with this, we come to question number 26. Question number 26 states, what are the minimum number of nodes that a binary tree can have? Well, before we move on to the question, can you take a quick guess about the minimum number of nodes a binary tree can have? Well, you might have guessed right. A binary tree can have 0 nodes. Yes, 0 nodes, or of course a minimum of 1 and 2 as well. So a binary tree is not a compulsion of having 2 compulsory nodes. A binary tree with just a root node is also a binary tree. A binary tree with 1 node is a binary tree. A binary tree with 2 nodes is another binary tree as well. And if you're thinking about how it can be 0 in another perspective, if there is a null value in your tree as the root node, again, your binary tree is considered to be having 0 nodes as well. Coming to question number 27, what are the data structures that make use of pointers? Pointers. These form to be very, very important foundational concepts you have to know whenever you talk about data structures. So pointers are basically entities that are used to point to an address of an element. Well, why do you want to point to an address of an element? To make sure that you can access it from one part of the memory, right? So let's say if you want to visit your friend who's staying probably 1 or 2 roads away, and if you know just the person but you've never gone home, you will need an address to go to meet this person, right? This is exactly how data works as well. You need the address of where that data is located to work with it, to pick it up, delete it, add to it, remove it. So pointers are used for that. And then when we talk about the use of pointers in data structures, it is used everywhere. Binary trees, linked lists, stacks and queues to denote where each of the elements are and what are the addresses of each of those elements present in these concepts. So make sure you mention at least 3 or 4 data structures where pointers are used. Coming to question number 28. What is the use of dynamic data structures? Well, dynamic data structures, as we have discussed, is very similar to the working of dynamic memory allocation. Here, the entire data structure provides the user with a flexibility where data can be stored and manipulated based on the amount of data. You can work with it. So basically, it is so flexible that you can change the entirety of the inflow of data, the amount of data, etc. before it enters into an algorithm where it's worked on, or before a program is executed as well. So a dynamic data structure is very similar to the working of dynamic memory allocation. And then, of course, I'm pretty sure you guys can elaborate on this as well. Now coming to question number 29. What is a priority queue? We know what is a queue, but what is a priority queue? Well, a priority queue, as the name suggests, is a queue where each of the elements have a priority associated with it. Now let's say you're stuck in the traffic. Each of the cars that will move is one after the other, right? Now if there is an ambulance or an emergency vehicle, a firefighter vehicle in the back, we're pretty sure that all of us will move to the side and give the highest priority to these firefighters or ambulance vehicles, right? This is exactly how it works here in data structures as well. So a priority queue is basically a regular queue, but then each of these elements have a priority. If an element has a higher priority, it means that it will get processed quicker than the element with lower priority. So when you're working with priority queues, well, it can be a question on its own. What is the minimum number of queues that are required to work with a priority queue? Well, you will have a queue for the data and you will have another queue where you're storing the priority of the associated data. You get it, right? You have 10 elements on the left side, which is the actual data, but then you'll have another queue on the right side, which is basically another 10 entities, but then this is not the data, but the priority to the data. So if you asked a question saying what is the minimum number of queues required to implement a priority queue, make sure to answer it as 2. It is not just 2, it's a minimum of 2. You can of course have more, but then these get into the complete range of complex data types. But at this point of time, make sure you answer it as a minimum of 2. Now, coming to question number 30. Pointers allocate memory for data storage. True or false? Well, we discussed pointers to be addressing elements, right? Of course, the answer is false. Well, pointers basically work as we discussed by pointing the governing data handler to a basic respective location. It does not mean it can allocate memory on its own. Well, memory is allocated entirely in a different procedure, but then the memory is later accessed using pointers. We hope that's clear to you. And of course, whenever you talk about memory processing will mostly work in a dynamic environment only when the program begins its execution, because only when you're executing it, you will understand what the data is required, how much data is required, and if it changes, how you can handle that as well. So the answer to if pointers can allocate memory for data storage is true or false is false. Now, coming to question number 31. Question number 31 states, what is the meaning of DQ? We saw a regular queue, but then what is a DQ? A DQ is very simple. It's a double-ended queue. It means that, very simply, you can add or remove data from any of the two sides of a queue. Of course, if you're wondering if we can implement this on a regular queue, yes, you can implement this on a regular queue and basically use it as well. So what this does is, when you're talking about linked list, there's a concept of doubly linked list or circular linked list. Here you will have the data element and a left pointer and a right pointer and much more. So whenever stuff is double-ended, where data has to be accessed from both the ends or removed from both the ends, you will be implementing a DQ, or in short, for double-ended queues. Now, question number 32. Differentiate between linear and non-linear data structures. Well, we discussed this in the very first couple of questions, right? Now let's get back to that in a little more detail. As I have explained before, a linear data structure is when data is stored next to each other in a linear fashion, in an ordered fashion. A non-linear data structure is basically an entity which is stored in memory where it's not next to each other and it's stored in a haphazard way when you look at it literally. See, for example, each of the elements in arrays, linked list, stacks, and queues are stored right next to each other. Of course, they can be stored anywhere in the memory. We're not talking about the addressing of the memory. We're talking about them literally being there. So in linear, the data is stored next to each other, but then when we're talking about graph data structures, when we're talking about tree data structures, it is non-linear. And of course, when you go on to visualize both of this, you will get a clear-cut picture of what the difference is between a linear data structure and a non-linear data structure. But then one important thing, make sure you give examples to support your claim and your understanding of this as well. With this, we come to question number 33. Question number 33 states, what is the meaning of an AVL tree? Well, we saw regular trees, we saw binary trees, and we saw binary search trees. Now, what is an AVL tree? An AVL tree is basically a simple type of a binary search tree itself. Well, an AVL tree is different from a regular binary search tree in a way where it's only one part of it is being balanced. Not the entire tree has a compulsion to be balanced like a binary search tree. Now then, what is balance? Balance is basically when you're directly comparing the height of the subtree from its main root node, right? So if the balance is off in a binary search tree, it can be considered as an AVL tree. But then if the entire tree is perfectly balanced and if it's non-ambiguous, it can be called as a binary search tree. That is a simple AVL tree. Coming to question number 34. How does the Huffman's algorithm work? Again, this is a very widely asked question. The Huffman's algorithm, basically, whenever you're working with Huffman's, you have to understand that you will require one table which stores the frequency of occurrence of elements. If you have like 10 elements occurring 100 times each, you will have one table in Huffman's algorithm which will basically state that, hey, this element is occurring these many times. So why is this required? Well, whenever you're constructing extended binary trees which will have a lot of subtrees or which will have only minimum weights, you will require a method to keep a track of this easily. Huffman's algorithm is the governing entity which helps you keep a track of this by giving you the frequency of occurrence where each data entity or each element presence is denoted in a structured format. And of course, you can explain this with an example using a sheet of paper as well. That will add a lot to your candidacy. Now, coming to question number 35. What are recursive algorithms? Recursive, as the name suggests, is a methodology where you're doing something in an iteration. You're doing something again and again in a loop. So a recursive algorithm is an algorithm which will work by taking a complex problem and simply breaking it down into simple problems. And these simpler problems are worked on in a loop format in an order one after the other to solve the eventual big problem. So when you talk about recursion, the output of stage 1 of recursion will be the input of stage 2 of the next loop of the same thing. Now the output of the second one is the input of the third one. So that is how recursion operations work. Whenever you talk about recursion, you're talking about looping and you're talking about how data moves in such a way that the complex problem can be broken down into simple entities and handled at the easiest way possible. And this brings us to question number 36. Question number 36 has to be the question that's been asked probably in all of the data structure interviews, right? Well, question number 36 states, how does bubble sort work? Well, bubble sort is basically another sorting methodology which is applied to arrays where elements are next to each other and values are compared. The working of bubble sort comes when the adjacent elements, two elements right next to each other, are compared, and based on where they're supposed to go, they're directly changed. This is a very simple understanding of, let's say, if you have an array which says 1, 3, 2, 4. Now you compare 1 and 3. 3 is greater than 1, so the 3 stays right there. Now you compare 3 and 2. You realize that 3 is greater than 2, but 3 is on the left side, but 2 is on the right side. So you just swap 3 and 2, and that's how it works in an iteration. That is how bubble sort works simply. And so if you're wondering why a bubble sort is called as a bubble sort, it's only because of the direct comparison between a bubble floating to the top of the water, but then anything heavier than a bubble will of course be sinking to the bottom end, right? If you're thinking of comparing a bubble to a rock, and when you throw it inside the water, the bubble will float above the water while the rock will sink. This is exactly the working of how you can understand the working of bubble sort as well. With this, we come to question number 37. Question number 37 is an interesting one. It says, which is the fastest sorting algorithm that's available? And in fact, this question is very subjective because there is no fastest, sorting algorithm that's available, which is one algorithm which does everything. So when you're working with data structures, you're trying to solve a very specific niche problem. This particular problem that you have can be sorted very quickly using bubble sort, but then you will have another program or another problem you have to solve, which can be solved the fastest using merge sort. So the answer here is that it directly depends on the data and how the algorithm processes the data as well. So there is no single fastest sorting algorithm. It is based on your data. It is based on how the algorithm works as well. And the concept of time complexity is used here to track what is efficient and what is not. With this, we come to question number 38. What is the postfix, a form of the expression you see on your screen? X plus y is multiplied by z minus c. Now again, if you remember, we're doing the prefix and the postfix expressions to basically keep the data ready for lexical analysis and to remove the presence of brackets as well. So here, the operators are preceded by their operand. As you can see, x, y, then we have the plus, and then we have z, c, where we have the minus after the operands. And then of course, there is a simple formula. There is as a simple structure that you'll be using to work with postfix expression as well. So my advice here is to make sure you take up certain examples on your own, see what the formula is, and then solve it. Because if you are given a random prefix or if you're given a random expression by the interviewer to solve, you will of course have the ability to do so as well. But then to keep it simple in this question, we have given you the output as is. But then make sure to practice on how you can get here as well. With this, we come to question number 39. Where are tree data structures used? Well, again, as all of the other data structures, even tree data structures are used in a lot of places. But then these are some of the most important places where tree data structures are sort of championed. Whenever you're working with lexical analysis, whenever you're working with hierarchical data modeling, step-by-step data handling, whenever you're working with something called as a symbol table, where when you're creating a symbol table, you will be using a tree. And then whenever you're handling basic arithmetic expressions as well, tree data structures are used. If you want to perform traversals in order, pre-order, post-order, you can do so in a tree data structure as well. So whenever you ask this question, make sure to give 2 or 3 examples of where it's used. Of course, more than 3 will again be an added advantage, but make sure that they are accurate and not incorrect as well. This brings us to question number 40. What are the data structures that are used to implement graphs? Well, whenever we have to implement a graph, we are literally not drawing a graph using programs here, right? A graph is a data structure. Now, when you have to implement something called as a graph, you need 2 important data structures here to implement one data structure such as graph. Basically, we are talking about adjacency matrix and adjacency list. So adjacency list is used to tell you, and it's used to represent the data which will go in, and the adjacency matrix is to basically tell you if your data is sequential and how you can go on to work with and store the sequential data as well. So whenever you're asked saying how are graphs implemented, make sure you mention 2 things: adjacency matrix, which will show you the sequential data representation, adjacency list, which is used to represent linear linked data. Well, this is pretty much the most straightforward answer to this question. With this, we come to question number 41. What are the data structures that are used in DFS and BFS algorithms? Well, DFS and BFS are again acronyms for depth first searching and breadth first searching. These are again concepts which are used to perform searching operations when you're working with data structures. But then know this: when you're working with depth first searching, you will be basically using the stack data structure, and whenever you're using breadth first searching or the BFS technique, you'll be using a queue. So if it's depth first, it's stack. If it's breadth first or BFS, it's going to be queues. And of course, if you think this might get a little confusing, just try to see if you can find a way to remember it in a simpler way. But then if you have actually worked with data structures, or if you've had experience using these, then it becomes quite literal of why a stack is used in DFS and why a queue is used in terms of BFS as well. Now, coming to question number 42. What are the time complexities of linear search and binary search? As I mentioned, linear search and binary search are basically 2 forms of searching, and each of these are different in its working, and of course binary search is more efficient than a linear search. And how do you track this part where you say it's more efficient, right? So basically with time complexity, we can understand that with each iteration of how the working is. So we have something called as the big O notation, where we consider how fast an entity can execute for that particular values as well. So at this point of time, to answer the question and to keep it concise, basically you need to understand that the time complexity for a linear search is O of n, but the time complexity for a binary search is O of log n. And then O of log n, you don't have to explain the working of it. It's basically the working on the logarithmic scale. But then in quite literal terms, it means that the binary search is of course more effective. It takes lesser comparisons to search, and it takes eventually lesser time to find an element in an array. With this, we come to question number 43. Question number 43 asks, where are multi-linked data structures used? Well, multi-linked data structures are very, very important in 2 concepts. When we talk about multi-linked data structures, make sure you understand that it is used wherever you require a sparse matrix and wherever you have to create an index, whenever you have to perform any operations with respect to data handling. So when we're talking about sparse matrices, and if you answer this question with saying that it's used to generate a sparse matrix, the interviewer might ask you what a sparse matrix means. So basically, a sparse matrix is a matrix which will contain minute number of non-zero elements. So it is a matrix which will consist mostly of zeros and less number of actual elements. So it's basically used as a way in numerical analysis and scientific computing, where it denotes only the functional components which are required in the matrix while omitting the ones which are not. So in case if you are asked a follow-up question saying what sparse matrices are, you can use that answer as well. So coming back to the original answer, a multi-linked data structure is used in the generation of these sparse matrices, and it is used whenever you have to create indices for data entities as well. With this, we come to question number 44. What is the methodology that is used when you have to perform in-order traversal? Well, in-order traversal is when you have an operand on the left, the operator on the middle side, and another operand on the right side, in case if you're working with binary operations. But then if you're working with trees, the question is asking you about trees, right? Of course, when you talk about traversals, mostly it's trees. So the tree is basically sought out and traversed through from the leftmost subtree. After the left subtree is processed, the root node is processed. After the root node is processed, the right subtree is processed. This is how it will work in the individual subtrees as well as the entire tree on the whole as well. First, the left is processed, the middle element of the root element is processed, next the right element is processed. Now, if you break the tree down into another subtree, again there left, center and right is the rule which will go on for the working of in-order traversal as well. And then there is a good chance there is a follow-up question which would state, what is post-order traversal then? Well, post-order traversal is basically when you traverse the left subtree first, and then instead of going to the root node, you will traverse the right subtree. After the right subtree is visited, you will come back to the root node. So instead of left, root and right as in-order traversal, with respect to post-order traversal, you will do the left first, the right subtree the second, and then come to the root node. So make sure you understand these subtle differences, because understanding them and remembering them is simple, but once you start implementing them, it can slightly get confusing. So with that, we come to question number 46. Question number 46 states, are there any disadvantages to using queues, or what are the disadvantages when you're implementing queues when you're using array? Well, whenever you're using an array, you need to understand that with queues, you might have any number of elements which can be added or removed, right? So if you're standing in a queue at your favorite restaurant to get your table or something, it's not like 5 people stand there at a time, right? So you can have 5 people standing, 10 people standing, 100 people waiting for their tables. So with array, whenever arrays are created, their sizes are not dynamic by default. Of course, you can have dynamic allocation, but then so it provides a situation where there is a discrepancy when you're creating the correct array size, because you do not know how long your queue is going to be, and in this case how many elements you will have when you're working with queue. That's one disadvantage. The second disadvantage is that whenever you store queue elements, right, it cannot be reused. So it's basically stored once, and if you have to reuse it, you cannot. Why is this? Because whenever you think about working with queues, literally as the name suggests, insertion will happen only at one point of time. When you insert data at that point of time and keep pushing your data one onto the other, you can use it only once. You cannot use it more than once, and this will cause memory dumps where you're just making it a little less efficient, because you are adding a bit of discrepancy here too. So whenever you asked about the disadvantages of implementing queues using arrays, make sure you talk about array sizing and memory dumps. Now with this, we come to question number 47. How can elements be inserted into a circular queue? A circular queue is where one entity of the queue is connected onto the other, and the last one eventually is connected to the first one as well. So it's placed in a circle. Now, if you're asked about how elements can be inserted in a circular queue, make sure that you talk about two conditions, two cases. So basically the first case is when the front value is not 0, but then the rear value is max minus 1. When you talk about this particular condition, it means that your queue is not full. That is what rear is equal to max minus 1 states. If your queue is not full, then of course you can start implementing and inserting elements at that point of time. The second case is where your rear is not equal to max minus 1. If rear is not equal to max minus 1, it means that the queue is not full, and this indicates that you can add on the values wherever you require. But then since we're talking about queues, you will only have to add these values at the rear end of it. That's why we're checking if the rear end is either less than max minus 1, or in fact if it is not equal to max minus 1. Now these concepts are, if you're wondering about why it's been named like this is exactly a standard structure that is used to go on to write code with respect to handling queues or handling stacks or any other data structures as well. Of course it can be anything else, but then to keep readability at its high, the namings have been given as such. So make sure you mention these two cases. With this, we come to question number 48. Question number 48 states, what is the use of void pointers? We know what regular pointers are. They're used to basically address and index an element in memory. Now what is a void pointer? A void pointer is basically an entity that is used whenever you have to store another pointer. Well, a regular pointer points to data. A void pointer will point to another pointer. It has the ability to store up data of a pointer, right? So it's pretty simple. It's as simple as that. A void pointer is an entity which is used whenever you have to store another pointer inside of it. And this pointer which gets stored inside, of course, it can be a regular pointer where it's pointing to the variety of data that it is usually used for. So where is void pointer used? Well, it's basically used whenever you have to implement multiple linked lists which are not similar to each other as well. So now if you have a case of implementing these linked lists in multiple programming languages, and if you have to bring it together at once, you will require one pointer which is pointing to another one where you're storing the data of that pointer as well. In that particular case, you will be using a void pointer.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ICT IIT Guwahati, the course link of which is given in the description below. Now let's continue with the session.
With this, we come to question number 49. What is the meaning of the Stack Overflow condition? Well, Stack Overflow, as the name suggests, that your stack is literally overflowing. It means that your stack is completely full, and whenever you insert any more elements, it is not possible to store it into that stack. So an easy way to remember this is to remember a stack which is actually overflowing. So let's say you have 10 books in your locker, or you have 10 books on your bookshelf, but then you don't have space for the 11th one. So this means that you have hit a Stack Overflow condition. And of course, this is a direct analogy of how it works here as well. But then if you're asked to state the condition where Stack Overflow happens, well, when the top element is equal to the max size minus 1, it means that the stack is full and the overflow condition has been hit. So make sure to mention that condition if asked. Now, question number 50. Have you earned any sort of certification to improve your learning and your implementation process? Well, it is of course advantageous to have a certificate in whatever concepts that you're looking at. It might not be just data structures, it can be anything, data science, Python, data visualization, so whatever it is. A certification will of course boost your candidature a lot. You're just basically proving to the interviewer that you have put in a good amount of time, you've put in a good amount of effort in learning new things and implementing them, and that you would want to do that for a good amount of time in your life as well. So basically, when you ask this question, make sure you talk about your certification attempt, what you learned in that certification, the projects that you did, and how you solved real world problems as well. Because with this, you're telling the interviewer that you have a strong aspiration to progress in that field, and that you're an effective learner, followed by having interests to build your career on that. So this is a very important question where you can change the direction of the interview as well. So list all of the certifications if you have. Talk about what you did in the certifications, talk about what you learned, and how it's been helping you to apply, in fact, for this job that you're interviewing for as well.
Just a quick info, guys. Intellipaat provides full stack web development course in collaboration with ENICT IIT Guwahati. The course link of which is given in the description below.